Cool. We're going to get started. So if everybody could find your seats. So welcome to day 2. I hope everybody had a great day yesterday and enjoyed the party. So today, just a few reminders. We've got the office hours drop-in, so you can talk to Substrate developers, you can troubleshoot your problems, ask about, what's the, how would you architect this? That is in the room right behind here. So that's all day, and you don't need an appointment for that. You can just show up. We have most of the program today is the same as was planned. We just have a slight change at 4 p.m. Gav is going to give his keynote. Then the AMA is still going to be at 5 p.m. Right now, on the workshop room, we have Arjan doing a PocaScan workshop, and so that is downstairs, and in the workshop room, just follow the signs. Right now, on this stage, we've got Joe Petrowski, who is a research analyst at Parity, and he's going to be talking about fees and measures. Welcome, Joe.
Ian is on vacation, and so he just asked a couple weeks ago, can somebody fill in and do this? And I thought that's a great way to learn about doing it, or learn about how these work, is to actually learn it and present it. So yeah, I remember like 6 months ago seeing some like comments appear in the Substrate code base about weights, but they were just comments and like kind of like to-dos. And I was like, I should learn about that, but I didn't in time. And so I kind of crammed to put this together. But yeah, hopefully it's useful. So where do fees come in? So transaction execution, a transaction when you submit it over an RPC, like it goes into the transaction queue, and then it does pass some checks that Tomek can tell you more about. But if it passes these checks, then it gets inserted into a block, and then that's where the fee gets computed. So it's going to compute the fees, deduct it from the sender's account, and then if that successfully passes, it'll actually dispatch the transaction. So I'll talk about it a little bit later, but there are cases where the transaction just won't even get dispatched to begin with. So this is very different from like gas metering, where it'll just start executing a transaction, and it just may run out of gas in the middle of it. In this case, we're going to do the whole fee computation before even dispatching the transaction. So fees have a bunch of different components. There's base, length, weight, and an optional tip. And all of these things combine to be an inclusion fee. So these 4 things are what actually gets computed and deducted before a transaction gets dispatched. And then there's some other stuff that you can do within the function itself that I'm going to talk about at the end. But these 4 things together constitute the inclusion fee. And so that's what most of this is going to be on. So the easy ones, a base fee and a length fee. Base fee is just a fixed fee that's applied to everything, and then a length fee, you're probably familiar with like the way that a transaction gets encoded. That has a length in bytes, and then you just set like a per byte fee. So those are pretty simple and intuitive. Weights is where it gets more fun. So the weight fee is based on the resource consumption of a transaction, and they represent all of the resource consumption in a single value. So this could be like computation, memory use, I/O, like how far, like how many tree lookups it has to do and stuff. And there are 2 types of them. That's normal and operational. And so weights should have a couple of properties. So one, they should be computable ahead of dispatch. So we don't have any access to like the function logic. We're not in the function yet. We have to be able to compute this before we even dispatch it. They should be lightweight. So this is kind of intuitive. You don't want to have heavy computation in deciding how much fees we should charge for computation. And it's limited to the dispatch logic. So it doesn't know like what the dispatch logic is going to do. And this would be like, you could know, when you decide on your weight, you could know that you're going to iterate through some list, but the weight computation function itself doesn't have access to these variables, so it doesn't know how long this list is going to be. And so if you have variable consumption like that, you're going to have to put more fee calculation inside of the dispatchable function. So blocks are limited by fullness, so they can be limited by weight and by length. So the system palette accumulates all the weights for a block, and it's also adding up like all the encoded transaction length. And so in Polkadot, we target 25% fullness, and then 75% is the maximum weight for a block for the normal operations. And then like the operational ones, those can go over up to the maximum. So 25% of the block is always reserved for the operational class. So how does this stuff all get represented? So in your runtime lib.rs, it's pretty simple. Maximum block weight, available block ratio. So you see we have 75% of the block reserved or available for the normal dispatches. Maximum block length. I just took this from the Kusama runtime, so it's 5 megabytes. Those all go into the system module, and then all of this transaction base fee, byte fee, target block fullness, you can see is 25%, 10 millicents per byte, and then we have this like fee multiplier update and weight to fee stuff that we're going to talk about. So this all just goes right into your parameters in your runtime. So normal versus operational. Normal dispatchables are most transactions. Almost anything that a user can call is going to be normal. And then operational, these are things that you deem to be high-value transactions. So a fisherman reports, you don't want that to be delayed because like the block is full of other transactions. You want that to have kind of reserve space in the block so that it can get executed right away. And then either of these can have zero weight, max weight, or variable. So this is just in an enum, simple dispatch info. You can have fixed, max, and free. And so this is really like the simplest. This is the simplest like implementation that you could possibly do. So you should go to the recipes page. We have some more that you can do with this to do fancier stuff, because you can really do like your own custom implementations for like how these get represented. So how do we convert weights into fees? Because they have different types. So like with the base fee and the byte fee, that's pretty simple. You can just kind of multiply like the length by balance. But for weights, we have to convert it. You can put really any kind of logic that you want in here, but you just have to implement this convert function for a weight to fee. So in Polkadot, at least right now, it's really simple. It's just, what is this, 1/10 of a cent. You just take the weight and multiply it by that, and you get a balance out. But when you make your own chain in Substrate, you can do really whatever you want with this, whatever kind of custom logic, and you can even have multiple ones that I'm going to show a little bit later. So adjusting fees. Demand on blockchains is irregular, and there's a trade-off between having rapidly changing fees or long inclusion times. So you can imagine like a fee that adjusts very quickly. It's nice because it helps you prioritize transactions, but the problem is you could have your fee change by like 10% over the course of a mortal extrinsic in like 50 or 100 blocks. And people might not want to pay that much. They might prefer to actually wait. So the other option is a long inclusion time. Or what we did is we took the long inclusion time and we added this tip. So it takes this like base, byte, and weight, and then you have this option of adding a tip. And in the transaction queue, the priority of transactions is sorted by the sum of all four of these things. So you have, if you don't think that your slow adjusting fee is going to make it in time, then you can add a tip and that'll move it up in the priority of the transaction queue. So the way that fees get adjusted is it just has your current fee, and then it has a multiplier for the next block. And so this just goes block to block. You can only predict for the next block. So to do a little example, like if you wanted to predict how much your fees could change in a transaction, we have this struct targeted fee adjustment, and this just converts the current fee multiplier to the next fee multiplier. I left out the actual logic of the function because it's a lot of lines of code that wouldn't fit on here. But basically we have this, you take the previous block weight minus the target weight of the block. So in Polkadot's case, the target weight is 25%. And then you just take the previous weight, whatever that was, subtract the target weight, and then run through this equation. The Web3 researchers picked this V of 0.00004. I'm not sure how they arrived at that conclusion, but there are a few of them floating around. And it just returns the next multiplier. So if we wanted to calculate the phi over like 100 blocks, you could just raise this to the 100th power. So the maximum a diff could be would be 1, and this would be really if you had a target block fullness of 0. But we can just take this equation, get the maximum phi multiplier update for the next block, raise it to the 100th power, and we could find that fees could change about 0.4% over 100 blocks, which is really not a lot when you think about like how quickly demand on a blockchain can change if there's like a huge surge in transactions. So we really expect people to be using tips in order to prioritize their transactions. So yeah, tips, they adjust slowly, demand adjusts quickly, and they're optional. You don't have to add them. I think you can also decide kind of like what to do with this whole transaction fee. So all 4 of these things that constitute the inclusion fee, you can decide like, so in Polkadot's case, we send 20% to the block author and 80% to the treasury, but you can also implement that, like whatever you want to do with these fees, that's customizable. And so yeah, the dispatchable stuff, so once you get past the fee, I kind of mentioned at the beginning, there's other ways to take fees or limit resources. So one is like an account creation fee. And so in this example, like when you create an account, you're adding another item to your tree. And so just by like adding another item to your database, you're going to make other lookups, other operations slower. And so you might not want to account for this before the transaction because it doesn't have the internal transaction logic. So inside of your transaction, you might want to take an extra fee for something like that. Other things you can do is like a voting bond. So like when you vote, you have to iterate through this list to see if you've already voted because you don't want to be able to insert the same vote twice or insert different votes from the same account. And so the dispatch logic doesn't really know how long that list of voters is going to be. And so you might want to take a deposit when somebody votes. And then you can just put like hard-coded in bounds. And so like in staking, we set like the maximum number of nominations to be 16. And this just limits the size of the list that Fragment has to iterate through when it goes. And so there's a lot of different options you have for limiting resource consumption, and it all depends on exactly what you're trying to do or like what kind of logic you're using or what kind of state that you're operating on. So I think that was it. There was one other thing I wanted to show that I forgot to put in the presentation. I don't know how to use a Mac. Here we go. Oh wait, how do I change tabs? Yeah, thanks. So this all gets implemented in this transaction payment module. And so some of the stuff I showed you, like there's weight to fee. And so F. Yeah. So you have this like weight to fee of how to convert a weight to a balance. And I also don't know how to do control F on here. Here we go. So like in this compute fee function, you just have this weight to fee. And so if you wanted to implement various weight to fees, and so this is all like in the recipes also, you can see this. You could do like a linear weight to fee or a quadratic weight to fee. You could have different weight to fees for different functions or different modules. And so this is just the simplest implementation where it calls a single weight to fee convert function, but you could really put any kind of custom logic you want depending on which module or function you're using if you want to compute fees based on the same weight in a different way. So it's quite flexible. Substrate right now really has like the most simple implementation of this, and so it's really like, yeah, you have a whole palette to explore on and develop your own custom fee structures. So I think I can open it to questions now. And if Rui Tao wants to start setting up, because I know he wants to change laptops, we can do that. Yeah, Chris.
Hello, Joe. So it might seem like sort of an obvious question, but where do the fees go? Who receives the fees?
Yeah, that's up to you. So in Polkadot's case, 20% goes to the block author and 80% goes to the treasury. So I don't remember off the top of my head where that actually is implemented, but yeah, you can set it. You could set it to burn. You could set it to go to the treasury. You could, I mean, if you build a chain, you could just set it to go to yourself if you want, and people won't use it. So yeah, it's totally custom.
Okay, thanks.
Any other questions?
Yeah.
Hi, I'm Julio. I'm wondering about the treasury that you just mentioned. So 20% to a blog author and 80% to a treasury. That's when a substrate chain becomes like a parachain in Polkadot, right? Could you explain a bit more what is that treasury and what is the purpose and future like vision?
Yeah, so, I don't have the laptop anymore. But yeah, so the treasury it's sort of DAO-like, and in Polkadot, well, so first of all, it's just a module. Like there's a palette treasury, and then you can make proposals to this treasury. So actually on Kusama, someone did this a couple days ago. They just made a proposal to send themselves 100,000 KSM. I don't think it got approved, but yeah. So the treasury is just this. It's like literally an account on the chain, but in order to spend funds from this account, you have to make a proposal that gets passed via some governance mechanism, which could be a council or democracy or whatever kind of rules you implement in your chain. But yeah, it's at its lowest level, it's just an account, and then you get to decide you get to decide how people decide how to spend funds from this account and under what conditions funds go into this account. Does that make sense? Yeah, another from Adam.
Thank you. Hey, so I'm just trying to understand, so you have, so extrinsics have this weight that you can kind of decorate them with, and then in some cases you also take an additional fee. So I think one of the examples you had is when you're creating a new account, there may be some additional fee associated with that. I'm trying to kind of, I mean, if you're always taking a fee when you're doing that, why wouldn't you just account for that fee in the kind of weight of the transaction rather than having separate logic in the actual extrinsic to extract another fee? So I guess I'm trying to understand, you know, when do you take a fee as part of the logic in the actual extrinsic versus kind of just decorating the extrinsic with an additional weight?
Yeah, so we have this concept in the dispatchables of like verify first and write last that Sean will be happy to tell you more about. But so if you're familiar with like the existential deposit, actually one thing I should have mentioned at the beginning in the like transaction queue and execution logic is that when you're taking this fee based on weight, it has a keep alive requirement. And so you'll never actually kill an account just based on the fee that's being taken. And so there is a possibility that you take this fee and it would just actually, it would just stop execution and not dispatch the function at all. And so you only want to charge this. And then there's also other checks within like a balance transfer where you might say, I'm going to create an account based on this transfer, but you don't actually know if you're going to create an account or not. It could be, you could be transferring to a new account and you're checking within the function, does this account exist yet? And if not, then we need to create it and pay this fee. And if it does, then we don't need to actually pay this fee because the account already exists on chain. We're just updating something that's already there. And so it depends if you want to take it ahead of time or if you want, or if there's like some logic that could lead to this not being taken.
Okay, so if you always know that you're going to take a fee in a particular extrinsic, you should sort of do it at the top level. If there's some conditional logic, maybe sometimes you take a fee, sometimes you don't, then you have to kind of defer it until later and take it.
Yeah, and there's also other logic that could just lead to this, say like transfer not even happening at all. Like you could try to send more balance than you even have, and even if it would have created an account, it's just not going to execute this transaction at all.
Thank you.
Yeah.
Hi. I was wondering, how does the client best estimate what fees they need to pay? So specifically, I'm thinking about this tip. Is it always paid, or is it just, yeah? Does the client only pay for what they need, or do they actually always pay the tip, the full tip? Does that make sense?
Yeah, so however you come up with tips is really up to you, and will probably evolve as we see how transaction demand evolves. But yeah, you have to pay the whole tip. It's not like just a minimum.
Thanks.
I just want to confirm that. So now it's possible that first the transaction will, in any case, include in the block, but before dispatch, it may have some check field and run out of gas or fees, and like it won't just go to the dispatch process, right?
Yeah, that's
Okay,
correct.
thank you.
It should be quite rare because, so Sean talked about this signed extension yesterday, and it actually checks this in the transaction queue before including it in a block. So it would have to be like a really like a very like borderline case that something changes between checking the signed extension and actually having this block finalized. So it should be quite rare, but it is possible.
Any other questions? All right, thank you so much, Joe.
Thank you.
So next up, we have Ritao. We have Ritao next up, co-founder of Laminar, discussing new possibilities and challenges with Substrate. Welcome.
Thank you. Yep, should work. I think it should be fine. Hi everyone, my name is Ray Tao. I'm the co-founder and CEO of Laminar. We are a team that's passionate about DeFi, and we are building a number of DeFi solutions on top of Substrate. Today, I'm going to share a short introduction of who we are, what we do, and then I'm going to go through some real business case and scenarios to help explain like what is new possible, like what sort of new possibility we can do differently if we build on top of Substrate, comparing to other like major smart contract platforms. So this talk will be slightly different from like, I'm not just going to introduce like what we are doing like commercially. I'm gonna share first-hand experience like what we encounter during our development in Substrate. So we are founded August this year, so we're a pretty new company. We are a team of blockchain experienced engineers. Currently, we have around 7 people, and we're looking for more engineers to join us. So the company is pretty much engineer focused. However, we are backed by financial institutes that not only provide resource, but also provide financial expertise to help us to design these products by combining the real world financial experience with blockchain. Most of the team is based in Auckland, so it took me like 24 hours to fly here. I'm pretty still very, very jet lagged. The time zone is completely different. So that is actually an issue when communicating with the Web3 teams, like their early morning is our late night. So excuse me if I'm still have some glitch in this speech. For me, it's late night time. This. We have presence in Singapore, and recently we have also have a team working from Shanghai. So talk about our projects. We have two DeFi products that's currently in our pipelines. We have FlowChain, which is a synthetic asset and margin trading platform. We also have Alcala Network, which is a collateralized stablecoin. I think I'm going to explain what Alcala Network first. It's a concept that's very easy to understand. So it's a collateralized stablecoin. It's built with multi-collateral from day one, and with some unique aspect of the Polkadot / Substrate capability, we are able to do something that's not possible with the other smart contract platform. For example, we can use Bitcoin as collateral once the bridge has proven to be successful. The initial plan is to have DOT as collateral and create a stable coin. We'll call it AUSD. And next, for FlowChain, we are a specialized platform focused on synthetic assets and margin trading. With FlowChain, you can pretty much trade anything that as long as it has a reputable price fit, and as long as there's a mature market with liquidity, you can source. To put it simply, to put it this way, is that we are able to decentralize the liquidity from the centralized exchange through our protocol. I have a few slides here to make it better to understand how the Flow protocol works as an example. And later on, I will use this as scenario to say that how we can do this differently with Substrate. So first, the protocol is going to decide that there should be a market. In this case, we're using the Bloomberg as the oracle and to fit the price for Euro USD into the Flow protocol. And the liquidity provider sees this opportunity and see that, hey, I should join in and provide liquidity in this Flow protocol. So he lock in $100,000 with a bid and ask spread. More on this later, like what is the spread, and more on this later, like why there will be a liquidity provider. And later on comes a trader, sees the opportunity to trade Euro USD in a fully decentralized way. So the trader happily lock in $1,000 and the position is open. The logic is now enforced by smart contract and it's dictated by the oracle. So as the price update on oracle, the profit and loss is calculated in real time, as you can see here. So that's pretty much the oversimplified workflow of how the synthetic asset and margin trading works. Of course, there's a lot more other stuff we have need to take care of, such as like the swap, interest rate, and things like that. So that's the general idea of how it works. So the question, obviously, we're asking that why would a liquidity provider losing a lot of money on chain by backing this liquidity? The answer is that for mature marketplaces such as Euro, USD, the liquidity provider is able to hedge the risk anywhere. For example, Deutsche Bank, in this case, they are the largest forex broker, and anyone with trading experience shouldn't have any problem sourcing this sort of liquidity. And we talked about the bid and ask spread early. Because this is a central exchange, it has much more liquidity, it's much more mature place. There's no problem for a liquidity provider to be able to get a much better, a slightly better spread if the liquidity provider chooses to hedge the risk using the centralized liquidity. And that will end up with a small fee, and that will be the profit for the liquidity provider. Obviously, some liquidity providers choose not to do that. They are gambling against their traders, and this used to be a huge problem with the centralized exchange because later on, if the liquidity provider loses a lot of money, they might not want to pay out. But in our cases, this is okay as well because their collateral is locked in a smart contract. There's no way they can run away from that, and it's like the profit and loss for the trader is guaranteed. This is also a new source of revenue for traditional broker. Like if they want to get into the blockchain world, they can now utilize our protocol to have a new source of revenue. And obviously, like any existing DeFi solution, there will be a sort of liquidator to ensure that the system has integrity. Like a risky position will be liquidated by the liquidator with a small reward from the trader. More on this later. So the idea of the flow protocol is to able to, because as long as there's a reputable price feed, and as long as there is liquidity provider willing to offer the liquidity, there should be more variety on blockchain, and there should be more traders. We can offer Bitcoin price index, we can offer Apple stock, or things like that in a decentralized way. Because we are a product level protocol, it doesn't really matter where we implement our protocol. So we have implemented the first version of the protocol on Ethereum. It's currently live on the testnet. We have a front-end dev as well, and we are now heavily working on our Substrate solution in this flow protocol. And if you want to test that right now, you can actually go in there, and it's on Coven. You can get some fake DAI and then start to trade on there. Obviously, there's a question like, how do you bootstrap these products? Like, there's a chicken and egg problem. Like, where do you get the liquidity from? Where you get the initial liquidity provider from? Because we are backed by financial institute, we're lucky enough to have like 2 liquidity providers that's willing to work with us. We also have another arm that's working on OTC service, because some of the traders that we're trying to target, they are not crypto users. We're trying to target mainstream trader that has interest to get into the blockchain world. They would like to trade Bitcoin, they would like to trade their traditional instrument as well. And we are working on that. We are greenlit by a major crypto bank to provide OTC service. We also have a custom acquisition network with a significant amount of high-value traders that we are able to convert. So those is how we bootstrap the flow chain. Now I'm going to talk about the possibility that is possible when we build on blockchain on Substrate. I'm going to compare how we design the stuff on Ethereum and how we design the stuff differently on Substrate. I'm going to cover a few topics. Ranging from block time, transaction fee, to upgradability, or things like that. So this is the possibility that we found when we designed the flow chain. So block time. Obviously, block time is the how fast you can update information on the blockchain. And what we found is that in the current major smart contract platforms such as Ethereum, block time is not guaranteed, and block times tend to be very, very slow. And we found that the longer the block time, the larger the spread. And also, the longer the block time lead to risks such as front running. When we talk about front running, it's basically like with Oracle fitting the price into the blockchain, the information on blockchain is always lagging behind with the real choose of the data. And in this case, you need to have some sort of spread to make sure that no one can predict the future, because people can predict the future if your Oracle is lagging a little bit behind. But that is the case like this. In this case, like if the price of this particular asset get too volatile, and someone is able to do a transaction, like someone sees this, and then they press an order right before the price getting updated on Oracle, they have an upcharge opportunity here, and we don't want that to happen. So you will have the only thing you have to do is to increase the spread, but that ends up with like a worse price for the trader. With Substrate is that you get your full flexibility to design your own block time, like as low as 2 seconds. That's what Chainx has been doing. It's maybe too extreme, but you can do that. There's also a separation of block time and finalization time. But in the world of DeFi, a faster block time always means to better spread and better trading experience. The trader that we are talking to, they are already quite used to like instant confirmation, like click a button, the order is done. And if we do it on Ethereum right now, it's like you click the button, you wait for a minute and hope that your transaction is being mined. So Oracle. The Oracle design is also slightly different in the way that we implement that in Substrate. On current major smart contract platform, generally you require a fee for you to update data on the blockchain, so Oracle is no exception. You have to pay fee to update data on blockchain. And we estimated it will cost us $20,000 per year for one Oracle to update on the Ethereum blockchain for every 3 minutes. But as for Oracle, you want the Oracle to update as fast as it can, because I mean, that's end up with a better trading experience. And also with the current major smart contract platform, there's no quality of assurance that your Oracle transaction is going to be mined. Like you pay some certain gas fee, you hope that it's gonna be mined. And whatever happens, like if there's a crazy debt game that's getting so popular and then your Oracle price is getting outdated because your transaction is not getting mined, that's a huge problem. With Substrate is that you have the full flexibility to design your own logic. Like some cases we've been thinking like there should be a whitelist of Oracle address that can submit the data for free. Because you can't allow free transaction. You will end up with like spam causing the network to be lagged. But with Oracle, you can have a whitelist of like, hey, this X amount of Oracle, they are approved. And you can have also like, you can stake native token in order to get to this free transaction. You can also say that there's some sort of governance model you can design that some particular address can submit the transaction for free. Reward can be even awarded to Oracle operators. Like feeding the price into a blockchain should be like an activity we should encourage. So this is also possible with Substrate design. And also there's operational transaction that we can have some sort of assurance that the Oracle transaction will be always prioritized. So in our cases, this can be free plus prioritized. And as the liquidity provider, they have interest in updating their price as well. They might want to change their spread. And because they stake $100,000 here, we can say based on your staking, you can also get free update on your pricing. The next topic is about transaction fee, and that's echo what Joe just talked earlier. Like in the in the current major smart contract platform, the blockchain has counterintuitive fee model. Like DeFi user pay double fee. They need to pay for the native gas fee of the underlying blockchain. They also need to pay the protocol fee, and we find that it's very, very counterintuitive. When we talk to like traders, they don't have the idea like why do I have to pay Ether as fee when I want to trade some USD. With Substrate, we have the capability to design the fee model in full flexibility. We can say that fee is payable in one token or in various tokens. Like if I'm trading USD, I will expect that my fee will be deducted from USD. If I'm trading Euro, I will expect that my fee will be deducted in form of Euro. And there will be pathway to free transaction as well. Like if we are designing the Alcala network, we would probably say that, hey, if you have X amount of USD, then you get to transfer the USD for free for X amount of time. So that also open the possibility to freemium model. Like if you have something like you can have free transaction 5 times a day, and after that, it will actually start to charge you a fee. Like this is all possible with Substrate because you have the option to customize this. And in our cases, like this, if this trader trades this particular position and trying to close the position, the fee will be charged in US dollar, and that will be okay for the underlying flow chain to just recognize this as a fee. And it can happen like complete opaque to the user. At the back end, you actually buy back some of the native token and burn it. But for the user, they doesn't know that this happens. And this is basically like we giving dividends to the token holders. And all this design is possible. The next topic we talk about is liquidation. So the liquidation is the liquidator bot we talk about. I'm pretty sure most of you are familiar with the liquidation bots, such as like MakerDAO has liquidation bot, Compound has liquidation bot. I mean, the liquidation bot is actually more of like a trade-off rather than like by design, because most of the blockchains generally doesn't have an automatic scheduler built in. And to maintain system integrity, bot is incentivized to run off-chain to monitor on-chain position. You end up with problem like there's actually duplication of logic, because sometimes you have on-chain contract and you have off-chain bot. Your off-chain bot have different code bases, most of them written in Node.js. And you also need momentary reward from trader to maintain, so it's like it's costly for trader in some way. It also has safety issue. Your bot might not be run. Your logic might be out of sync with the on-chain contract. So generally, I think it's a transitional solution rather than an ultimate solution. And also, this end up with like the counter-productive incentive. Like there has been a research article that in the Compound protocol, if you pass through a particular liquidation line, the actual liquidator bot will push you into more insolvency. So with liquidation, we think about that, hey, maybe in our blockchain design, we can build this liquidation built-in within the node with the validator node. So there's already an option worker talk earlier by the parity guy. So I think this is very good. Like we can now put the liquidator bot right inside the node, and they share the same logic as the liquidation, how the liquidation should be happened. It also means that if we can tie the liquidation into some sort of slash event, like if you don't force to close risky position, you'll be slashed, then it's actually more safe, and then there's just one place to run it, and there's no longer fee needed to maintain this system integrity. And so that is liquidation. And the next step, I'm going to talk about upgradability. So this is the money Lego that's so popular this year. Everyone's talking about this money Lego, and this is good. And people start to build money Lego like that, and this is great, until it becomes something like that. It's so complicated, you don't know when it's going to collapse. And especially think about that, hey, once that piece is there, you can't move it. So in order for you to replace that pieces, you have to tear down the whole building apart and then to replace that pieces. This is actually what's happening right now because the MakerDAO just migrated to MCD, and I have to migrate my SAI to DAI. So this is actually very, very, very not user-friendly. Like I have to migrate my money. So allowing seamless upgrade of protocol without affecting existing user experience is the key for bot user adaptation. With Substrate and Parachain, it's like you think less about how you design a super technical upgrade pathway for your protocol. Instead, you start to think about how you can come up with some sort of governance model that ensure that your protocol can be upgraded. And the whole upgrading experience is much, much better. There's no migration. Well, they're seamless migration. The end user doesn't feel anything. And there's no fork. And the final topic I want to cover is the security of this. Like, we want to design this flow chain, and we want to design all this custom solution, but they are not possible. Like without the shared security model of Polkadot, it's actually very hard. So the general conception idea is that if you want to run a product level protocol, you should run it when the base layer is much, much valuable than your product. Because otherwise, like this is good. Because otherwise, if it looks like that, it's easier to attack the underlying layer. So people can attack the underlying layer and to gain the value that's on top of that. And this becomes extremely difficult to judge if like the underlying layer is actually, because in order for you to judge the underlying layer blockchain's value is very, very hard. Some of the existing protocol, it might seem that it has a lot of valuation, but it might end up to be like some of them is not really solid or not very credible, because you need to take account into like token value, you need to take account into like liquidity of the token, the actual usage of the underlying network. So for us to launch this flow chain with fully customized design, there's just few options for us. We can deploy this in a smart contract platform such as Ethereum, but then we cannot customize all the stuff that I talked about earlier. We lost the flexibility. Or we can raise enough capital to become a viable proof-of-stake network. We can probably do that, but it's not viable for every business to raise a lot of capital and become a viable proof-of-stake network. So the shared security model of Polkadot is actually a very, very good viable path for you to launch your customized network without sacrificing security. So there's already project pay-as-you-go, there's project for long-term lease. And I believe it's a pathway for viable business model and growth. So all of this that I talked about earlier is not possible without this shared security model, because we can just launch your blockchain with few nodes and it's still pretty centralized. Okay, so that's enough good stuff for Polkadot and Substrate and everything that's built by the awesome Parity engineers. Now there's a few challenges that we experience when building our product as well. So I'm going to share that as well. So one challenge that we face is that Substrate code is evolving, and we are at bleeding edge development. So one story that we heard is that one day the Parity guy, they changed the name from SRML to Palette, And then later on, the day after, they changed it to frame. They actually drive one of our developer crazy because, well, as a non-English native speaker, he spent a lot of time to remember palette and palette. And then the other day, they just say that, hey, we don't need to do it anymore. We just change it to frame. But I mean, that's one experience that you will have, like when you're working with bleeding edge developments. There's breaking change, there's lack of documentations. So potential solution for that is be prepared, like expect chaos. And also there's route channel that you can talk to dev. That's very, very helpful. So just join the route channel to get hold of core devs. We find that it's a very good experience working with the parity engineer of the route channel. So the other challenge that we're facing is currently there's lacking of standard features. So one of the challenge that we're facing is that for us to design and characterize stablecoin or to design an synthetic asset, there need to be some sort of like a token standard, like an ERC20 like of token standard, maybe called PRC20. And also there's lack of common feature and libraries. Most of the library that's currently available was for Polkadot, and there's a lot of common library that we think might be useful, but it's not available. And solution for that is like just good news. There's already a Polkadot standard proposal, PSP1. We actually submitted the first Polkadot standard proposal about forming a token standard. So that's where you can look for, like in the GitHub link there. And for the common libraries, because we are working with 2 projects right now, and they have a lot of common, similar requirements. So we created an Oracle module, we created an auction module, we created a multi-branch module. We turned it into something called ORML, it's like Open Runtime Module Library, and it's open source. We're happy to share, and you can all contribute into that as well. Like maybe we can change. We have to change the name now. It's called Frame. We may come up with some better name for that, but. Yeah, and the final challenge that we find out is that when you are designing your own blockchain, like when you are coding your runtime, it's different from like writing a smart contract. So there's lack of runtime level atomic storage modification. Like you need to do the verification first, and then make sure that your transaction is sent, and then later on you need to do the order write. And if in some unfortunate case the writing become failed, that there's no database level of rollback. So that is one thing that makes us, in terms of writing some code, it's tricky to think about that, hey, we need to make sure that the write wouldn't fail. So maybe there will be database like rollback in the future, like for the runtime support, I don't know. But that's one of the experience that we would like to share. So that's pretty much the whole experience that we'd like to share. Thanks a lot. And please follow us, and all the stuff that I showed today, including the Ethereum implementation, including the Alkaline network implementation, they are all open source in GitHub. They are available for you to check. So that's pretty much it. Thank you. Any questions?
Huitao, thank you for the presentation. It's wonderful to see higher level projects like this with actual business utility. My question is about high frequency. Do you believe that Polkadot will achieve the performance needed for high frequency trading?
I wouldn't say you'll be achieving the high frequency trading as if like you were compared to the existing centralized exchange, but it's already a huge step forward compared to Ethereum. And I think, as the underlying technology grows, it will keep becoming better and better. But for now, if we can say assume a block time of 2 seconds or 3 seconds, and we can assume some transaction have finality, then we can already do a lot of things better than the current major implementation. So we already see a glimpse of hope of what we can do. We don't think that it's going to compare to what is currently available on those centralized exchange. But still, for the early adopters, they are willing to pay the price of, like, it's not that user-friendly, but it's trustless, it's decentralized, yours forever.
Thank you.
Thank you. Oh.
This is Sayed from Web3. Could you tell me why the liquidation bots need to be off-chain? Why can't it be part of the logic of the runtime?
We think about designing the liquidation bot as an off-chain worker, so it can, I mean, for us to liquidate, it's like in the current model, you need to provide some sort of incentive, right? For now, we haven't decided where would we put it yet. Maybe we can put it in the runtime as well. But the thing is that I'm not sure if there's also for runtime is there also an automatic scheduler. The reason that we put it was we designed it and assumed that it's going to be an off-chain worker is that you can hook it to each block and it can invoke per block level, right? Maybe in the future we can put it directly in the runtime as well, and it can ensure the integrity of the system from the runtime built-in. Any more questions? Yep.
So when building application with blockchain, one of the challenges that a lot of developers face is that storing data, you can't store everything on blockchain. Some of the things that is not necessary, some of the things is better to be stored elsewhere.
Mm-hmm.
So one of the things we are here at Totem we're faced is that we're using NoSQL database to store off-chain data.
Mm-hmm.
I was wondering what other solutions do you face? And one of the challenges we are facing is that if you want to actually store those off-chain type data into blockchain, you can't actually make it queryable. Or if you use some of the other people we talk to, they are using IPFS to store those data, but that's actually just storing as a file. You can't actually query that. You can't manipulate or do other stuff with that. So I just love to know what they're doing to that.
Yeah, and in terms of storing the data, I don't think for our two project we need to store a lot of data on the blockchain. There's just price feed and there's just a balance module. And for the Alcala projects, maybe some of the CDP we need to store. I don't think we need to store a lot of data, either off-chain or on-chain. There's just minimum amount of data. The reason that we talk about the off-chain worker is that I think it's just more comfortable for us to have one code basis that rule everything rather than have the liquidation logic in a completely different set of database. It's actually more of having the logic in one place rather than have to store it somewhere else.
So the off-chain data is basically stored in a traditional database in your case?
I think when you design the off-chain worker, it only runs after you have a full synchronization, right? And most of the data is on-chain for our solution. So the off-chain worker have the ability to read everything, the latest state on the blockchain. So I don't think it even needs its own database.
Okay, thanks.
Thank you. Any more questions? I think that's all. Thank you.
All right, thank you so much, Ritao. So next we are going to have a coffee break. We'll be back here at 11:30. But quick reminder that if you want to ask a question for the AMA this evening at 5 p.m. with Gav and Frederick, go to slide.do and the code is Sub0.1. So once again, that's slide.do and the code is Sub0.1. And we'll be putting that on the screen shortly as well. We also have Substrate office hours in the room right here. So just drop in if you have something you want to chat about with the Substrate dev. So next up in this room at 11:30, Sean will be back to talk about storage, and Adam from Polymath will be talking about decentralized identity for regulated assets. And then meanwhile, in the workshop room, starting at 11:30, Joe, who just recently spoke, will be hosting a staking and validating roundtable. All right, have a great coffee break. Thanks. Okay, we're gonna get started again. In the workshop room, right now, Joe is hosting a staking and validating roundtable. So, and then here we've got Sean, who's going to be talking about storage. So if you want to take a seat, we'll be started in a moment.
Testing? Yep. Okay, hey. Hello, everyone. Yeah, I'll be talking about substrate storage. I'll be going pretty deep, explaining how it works, what it means to you as a runtime developer, and hopefully maybe answer some questions which are not fully understand about the structure of the substrate storage. First, I'm very aware that I talk quite fast, so I leave it to the front of the audience to start waving their hands if I start going a little too crazy, okay? Yes, like just like that, perfect. But yes, there's a lot to cover, and so let's get started right away. First, let's talk about the abstraction of substrate storage. So you all are probably most familiar with this runtime storage API level. This is the declare storage macro, things that you most commonly use, but there's a lot of things that go underneath, and this is kind of what we'll be covering over the course of this presentation. But let's kind of go one by one and try to understand these different pieces at a high level. First, the runtime storage APIs. So there's a crate, SPIO, which can ultimately write to these other parts of storage given some key and value. You can actually use this SPIO crate directly, but we provide a bunch of easier APIs through the declare storage macro. So we have this very friendly way for you to define these maps and storage values and double maps. And these are the kinds of things that are generated automatically with the declare storage macro through the SPIO crate. Then we have this overlay change set. I'm not actually sure how many of you are familiar that we have this, but it's basically an optimization to avoid consistently writing and unwriting data from the database. So whenever you use a module and you query a storage item or you want to change a storage item, first, actually, it checks if the value is in this overlay change set. It's kind of this cache. If it doesn't exist, it'll go all the way down to the actual database, pull the value up, but then additional changes or reads will happen at this overlay change layer. There's two kinds of changes in this overlay change layer. There's this perspective changes, things that may happen. So there are things that we don't know we should actually commit to the database yet. And then eventually there's some state that we know we will commit to the database at the very end of a block, which is the committed changes. And again, ultimately these overlay changes are actually committed to the actual database once per block. So when you're doing multiple reads to a value across multiple modules, all within one block, it's all actually happening in this overlay change set. Then we have a Merkle tree. This is also known as the HashDB, and this is implemented in this crate parity tech tree. It's basically a data structure on top of the key value database. One of the things I'll be iterating over and over here is that this tree structure is actually like a virtual tree structure. That makes more sense later, but basically we support at this level arbitrary key and value lengths. The nodes here can be branches or leaves. And again, we'll kind of go deeper into the whole trie structure later. And then finally, at the bottom, we have this key value database itself. This is the thing that's ultimately implemented with RocksDB. It is basically some hash to some arbitrary byte array. And in Substrate, we use the Blake 2256 hashing algorithm to generate the keys here. And this is the literal database. This is the literal storage. So at the core of it, in Substrate, you have just one table with some key and some value. But the abstractions above it is what makes it kind of the API that you all use. And that's kind of what the story I'll be telling as we go through these slides. Cool. So again, I'll reiterate this over and over. There's two kinds of keys. There's a tree key path, and there's a key value database key hash. And we'll hopefully explain that with some visuals. So Substrate uses a base 16 Patricia Merkle tree. So what do these things mean? So let's break it down one by one. A Merkle tree. Well, this is a thing you might be very familiar with in the blockchain space. It's basically some kind of structure to allow recursive hashing so you can get a fingerprint of the underlying storage. So you have some data, you hash that, you take the two of these data hashes, hash that, take two of that hashes, hash it all the way to get to the top. And this last final hash is literally a unique fingerprint for all the data underneath it. Merkle trees allow you to more easily prove that some data exists within the tree with a Merkle proof. And again, we'll go back into that a little bit later. But this is something that, if you're in the blockchain space, pretty familiar with, hopefully. Then we also have a Patricia trie. This is a special kind of structure where basically the position in the tree defines the associated key. So you can see here, there's going to be a key like parity. And if you want to navigate that tree path, you follow the path, so parity. Or you can follow the path party and see that it shares nodes where it has common elements, it's common prefixes basically. And through this, you can generate actually a pretty efficient way to navigate these kind of arbitrary length key paths where there might be a lot of shared prefixes. Does this make sense, right? Cool. Finally, all the pictures I showed you there were binary trees. It's way easier on PowerPoint to just do 2 lines. But of course, all of these data structures scale way beyond binary trees. So in Substrate, we use a base 16 tree. This is really nice because one part of a hex character, a nibble, is a value between 0 and f, which is 16 characters. And so yeah, everything just works the same. It's just scaled up. So we take the best of the technologies, we put them together, and we get this base 16 Patricia Merkle tree. So let's get visual. What does it actually look like? So first, I'm going to show you kind of some of the pieces here. These are individual pieces that we're going to be showing in the next couple slides. Again, there is a literal key value database here. This is actually something that is not going to be shown very much because I can't fit everything on one page, but know that this exists, and this what we're using is the actual database. There's these different kinds of nodes we support. In the Merkle trie, you have these leaves, you have branches, and you can see branches can have values or no values, and we'll talk about that a little bit later too. We have a virtual trie table, so this is the actual keys that you might be most familiar with, the things that you're actually using. And of course we have a node structure. The actual node of a trie has these different components, like the header, the key, the children, and some value, okay? So this is the lay of the land, and now let's look at a very complicated graph. This, okay? So what we're doing here is we have this tree key path table, and we basically want to see what does that visually look like. It looks like something like this. Let's kind of walk through it. So first you can see that all the different nodes at the very end here are represented by these individual nodes here. Right? Great. Next you'll see that nodes with a shared path are the children of a branch. So all of these nodes here with the tree key path, they all start with A7, and therefore the beginning of our little pathway here is going to start with a branch with a partial value of A7. Then we want to progress and navigate through this tree, and we'll do that basically by following the children and just kind of following the tree path itself. So if we want to get to this leaf 0, 0, the next character is 1, we go to chog 1, and we'll be able to find it, right? You'll see that when we follow the path, if, for example, this first one, node, leaf 0, 0, it ends, there's no more children underneath it, we get to the final node, the leaf itself. But you'll see actually that this line I'm drawing here, this is a key value database lookup. This is the thing I'm not really showing you well on this picture, but what we're actually doing here is looking up, querying the key value database to actually find where to get to this node. And I'll explain that a little bit more later, but you can follow the tree. You'll see here these middle 3 here, they all have a shared path of D3 next, right? So what do? We hit another branch. But this branch is a little bit different. This branch has a value, right? And so this is really important. Because we allow arbitrary key lengths in Substrate, we must, of course, allow for branches to also have values. Because we want to set a value at this path, but we also know there's children underneath it. So this is pretty unique. And then, of course, we keep going, and you reach the end when there's no more branches. That mostly makes sense, right? Awesome. So what did you just really see? Well, you saw that Patricia provides this tree path. You can go and navigate, follow the partials, the children, keep going, and ultimately generate a tree path to your data. And then Merkle provides this recursive hashing, right, of the children nodes into the parent. So we actually choose, we take this node, this is basically some serialized object, we hash that whole node object together with the prefix, with the key, and with the value, everything, and we get some hash. And that hash is where it will exist in the key value database. We, of course, take that value, put it into the children, and then hash that. And this recursive hashing is where the Merkle part of the structure comes from. And so ultimately, there's two kinds of keys. This is the big takeaway. There's two kinds of keys here. There's the tree key path, which is set by you. This is something like the code. This is where the WASM blob for the runtime is stored. And you have full control over the arbitrariness of the key, the length, all that kind of stuff, right? And ultimately, this key is encoded into the tree node as part of this key, the prefix, or the final end path, all that stuff. But ultimately, you hash this whole tree node, get a hash value, and this is the value on your actual database. So if you were actually to query the database file on your computer, you would need to know the hash value of the tree where you want to go and get the node content, right? Okay. But wait, there's more, of course. There's child trees. So child trees is like kind of a extra level of abstraction or kind of a cool feature that you can implement here. Basically, we have our normal stateDB tree, great, and then we can actually have a leaf node where the value itself is some hash, which leads you to the beginning of a brand new tree, right? And so what's cool about this child tree is one, the data here is kind of isolated. So anything in your child tree only affects it is inside of your stateDB. So changes to child tree will be represented in the final hash of your stateDB. But you can also track changes within just the child tree itself using the child tree root node. And also you can implement your own kinds of trees. You don't have to use our base 16 Patricia-Merkle tree. You can implement your own kinds of trees starting at the child tree level. So this is a really useful abstraction, one that we use in both Substrate and Polkadot. We also have a prefix tree. This is similar to a child tree, but the API isn't quite as good. But you can see here a prefix tree is basically some kind of virtual tree where you start at a point where all the elements share a prefix, and then you can of course find all the elements with that prefix. This is actually something that's temporary, and I think ultimately these will all be represented as child trees in the future, but we actually have some pruning issues within Substrate that we're still looking to resolve. The reason I talk about prefix trees, though, is because this is actually what is being used right now with the runtime storage. And this is actually new since the last Sub0. It's actually quite new in general. But if you're very deep into the storage already, you may be familiar with the fact that we take things like, when we use the declare storage macro and we generate for you these tree key paths like automatically, what we actually do is we take the module name, the storage name, and do some hashing stuff. Before we used to hash the module name and the storage name together in one hash. But now we actually separated it out so that there's actually individual prefixes for your data. So now when you generate some storage items for a module, all of your module's storage items will be under one prefix, right? And eventually it'll be under one child tree. And this is really awesome because you maybe migrate storage for a module knowing that all the stuff about this module stayed the same, even though your overall state tree might have changed. That makes sense, right? Cool. Okay, so let's talk about pruning. So pruning is another thing. Maybe if you're a validator or you've ever run the CLI, that you might have this pruning flag on, right? So pruning is meant for, is this process meant for holding older block states and cleaning it up. So we have this, this block 42, which has this root hash, and we go all the way down, this is a full tree. And let's say we want to update these two values of this tree at the very bottom. So what we're going to do actually is we're not going to recreate the whole tree in our database. That doesn't make sense. What we're going to do is just going to create a new, the new values and generate all of the nodes we need to get up to it. And the root hash can still refer to the old values. So what we're really doing is we're creating new database entries, but keeping the old ones too, and only creating database entries of the new things we need, right? So starting at block 43, I can start with this root hash. It'll point me to the old data, which hasn't changed, but also point me to the new data. And of course, we can continue to do this for another block, a new change. And eventually, what we do is we prune the old data. So you can see here, we just, when we want to clean up block 42, we just eliminate the parts which aren't being used by the other parts of the other blocks, the other parts of our storage. Another thing you can do actually is pin data. So similar to pruning where it cleans up data that's not being used, you can actually say, I want to pin this data. Even if it's not being used, even if it should be cleaned up, I can actually keep it in my database. Cool. So let's talk about Merkle tree complexity. This is an important part of when you're actually doing development, kind of what you need to keep in mind. First, reading data is not so great in a Merkle tree. It's O log n reads, whereas a normal database is something like O of 1 reads. So this is really not so great. You need to obviously traverse the whole path to get to your final value. Writing data is even worse, honestly. It's O log n reads, O log n hashes, and O log n writes. So you need to basically go here, read to the path of the value you want to change the value, hash the value, write the value, go up, hash the value, write the value, go up, all the way up. This is very expensive for a database. So why do we even use it? Like it's bad for reading, bad for writing. It's great for light clients. This is the important part. Substrate is a light client first platform. And it's really important to achieve a decentralized, trustless world, right? And so when you want to do things like Merkle proofs, you get really great performance in a light client. You only need O log n amount of data, basically, to be able to prove that some value exists within this tree. So you have something like a light client says, hey, prove to me this data exists. I know the root hash, and that's pretty much all I know. A full node will be able to traverse the path, collect the data, send it over, and then the light client only needs to do like, O log n hashes basically to verify, yep, this data and all this value you sent me does match the root hash that I know is correct. And this is really great. So we basically take all of the extra complexity onto the full nodes to make the light client node world better. So best practices. So you as a runtime developer, what should you be doing in general? So I think the first thing I want to say before I show you any of these slides is that you as a runtime developer are empowered to make decisions. And that is important. And you may decide, I want to break some best practices. That's probably fine as long as you're being conscious about the decisions you're making. And you have to be conscious about the economics and basically the impact you have to your network. But I think I can still give you some general best practices and see how you best want to apply them. So first, the fundamental goal as a runtime developer is for you to minimize the amount of storage your runtime uses. And so how do you do this? Well, you should only store consensus critical data in your runtime storage. You should not be storing random arbitrary metadata, random strings, random things, only consensus critical data. And I think maybe a good check of this is like, if there's no point in your runtime logic where you read the data, well, probably it shouldn't be stored, right? Okay. So let's think about a scenario, like a decentralized blog, right? The runtime should be able to come to a consensus about the content of the blog post. I think we all agree here that, what blog post is there should be known. But you don't need to store the entire text, right? You could do something like use IPFS. You could store the text on IPFS, receive a unique hash, and store that hash on the blockchain. You're able to achieve the same consensus-driven approach, but not having to bloat your storage with unneeded actual metadata information. Okay, so let's talk about structs and multiple values. So basically, you make it to a point where you need to decide whether or not you need to use a struct to combine a bunch of data, or maybe you want to just separate everything as multiple values. Well, first, it's kind of important to understand the direct cost and indirect cost of just making a decision to add more nodes or less nodes to a tree, right? So there's direct costs of basically increasing the number of reads and writes to the overall tree when you add more nodes, right? Each one is O log n, where n is the number of nodes in the tree. And there's some indirect costs, right? Like the size of the value. Like when you have a larger struct with a lot of value, it just takes longer to read that value. So in general, the best practice is if you can store a struct. We know that it will cause less reads and writes to update multiple values, especially if these values are all being used together. So here, adding small items into large items when they're both accessed and used at the same time is basically free in terms of these read operations. And then of course you create less overall nodes in the tree. But if you use a struct, there are some downsides too. Like it's less efficient for storing a single value. So if you have some big struct and all you want is this one piece of information, you have to load that entire piece, that entire data. It's not as efficient if you know that you're always accessing one piece of data kind of individually. Additionally, upgrades to structs require storage migration. There's kind of a well-defined structure for storage, and if some later point you want to update the storage, have more items, less items, or kind of just change things around, your blockchain is not going to understand how the things are currently encoded in your storage. So you're going to have to migrate that data over to be able to continue to use it. So these are the kind of decisions you need to make when you actually use a struct. But if you can, and this is what we do a lot in Polkadot and Substrate, is try to combine data that is relevant with one another into these structs. And this is basically optimizing the number of nodes you have in your tree. Okay, so you can also, using our friendly APIs and the declare storage macro, define the storage tree path generation. So here's an example of what you would write in your declare storage macro for a double map. And you can see actually you're allowed to implement different hashing algorithms depending on what your needs are. So if you define something like this in your code, the actual final tree path will be this, the hash, again, we did prefix hashes here. So hash of the module concatenated with the hash of the storage name, concatenated with the hasher you choose on key 1, and then concatenated with the hasher you use on key 2. Okay? And so what hashing algorithm should you use for generating these tree paths? Well, by default, again, I think I said it here, by default we use Blake 256. But Blake 2 is a cryptographic hashing algorithm, but it's quite slow. But it's important to use this kind of hashing algorithm when the user can influence the input of your hash. If you know the user cannot influence the input of whatever you're putting in this hashing algorithm, you can use a non-cryptographic but very fast hashing algorithm like XXHash or 2x. And this is really useful when you, the runtime developer, controls the value. So let's take a look back at one more slide. So you can see here, in the case where you control the module and the storage name, that's you as the runtime developer, you can use 2x. You're not a malicious actor. You're not going to be messing up your own storage. But if you have a user allowed to basically set these keys over here, they could mess up your storage, and I'll show you how. Basically, they can cause you to have an unbalanced tree. And again, this is impossible if the user can influence the path. So if the user can mess with these key values, control where in the tree that they put their, the tree, their node exists, you can basically create these unbalanced trees. And basically what happens is you lose the properties of your operations being O log n. That if you go down this path, like the overall total number of nodes here, if you go down this path, it's going to be one different type of complexity than if you go down this path. And this is going to be really bad for your database if the user is able to attack it. Additionally, if a user really has a lot of control over where they can put their key in this database, they can actually place their node underneath some other heavier node, right? And this means when you have to do Merkle proofs and you have to submit the data to the light client, you need to submit this heavy item. Imagine putting a storage item underneath the WASM of your runtime. That means every single light client proof using a node underneath it would have to include this WASM blob, and this is really not good. So not allowing your user to basically mess up your storage is important. That all of these properties that we have about the storage is assuming that there aren't attacks on this tree path generation. Great. And so let's talk about lists. So lists is another common thing that people need to include, and I think it's a little bit confusing how exactly to use lists correctly in your runtime. So you can store a single value storage item with a vector. This is great for storing a bounded number of values. And it's really good when you need to basically change or access multiple values at the same time, and it enables iteration. So a good example of this is like the current validator set. We know that the validator set is fixed number. It's not going to be arbitrary length, so if we have a loop over the validator set, we know that it will be within some certain constraints or bounds, right? And we want to access necessarily the validator set all at once. You know, we want to know who all the validators are kind of as one operation. We also have maps, which are good for storing an unbounded number of values. And it's good for random access. So we use this for user balances, like the amount of money they have in the balances module. And we don't know necessarily how many users are going to be on our blockchain. We don't know if we go under like a Sybil attack where basically you spam the millions of accounts with no balances in them. So we don't know necessarily how many values are going to be in this map. And also we know that we're not going to necessarily access data together. You know, when I access your balance, I don't really care about anyone else's balance. I'm not accessing multiple users' balance at the same time necessarily. So it makes sense to separate things out, use this map. Finally, we have this linked map. And linked map is honestly a trap. It's this kind of thing that we provide to you, and you should be very careful how you use it. It really only makes sense to use a linked map if you're storing an unbounded amount of data, like a map, but your UI or off-chain worker needs to iterate on the entries, not you. So again, what's really important in your runtime is that you're not iterating over unbounded data. You cannot create a wait function. You cannot create security around your runtime logic if it's unbounded and you have some kind of loop there. So really, this linked map is really more of a implementation deal for kind of this off-chain UI stuff. An example of this is the list of nominators and their nominations. So we don't know how many nominators there will be on a platform. We don't know their nomination information. And within the runtime itself, we don't really care, to iterate over all of it. But the UI definitely cares who are all the nominators, what are they doing. They want to show good information, they want to have easy access. And really this linked map, and I think this API will go away. Again, one of the things I mentioned here is we just moved to this prefix map. We will move to the child tree map. I believe once we actually have these things all as child trees, any map will be iterable. You will be able to go and use the API basically to go to the prefix you want where it has this map value and then just iterate over all the children. This abstraction really exists before we had these other things, but these APIs aren't quite fully up to date, and I think you'll see them continue to evolve. But these are the kinds of things to keep in mind when you're using different things. Yeah, so in general, the summary and takeaway here is that you really need to think about all the layers when you're writing to storage. When you're writing your runtime, it's not just like, bam, I'm just gonna put some value in there, no problem, just keep adding more, removing more, whatever thing I want. That you're working probably mostly in this runtime storage API, but it has ramifications and impacts to all the lower levels. And you really need to be conscious of that to be able to make the best decisions for your network. Okay, and yeah, that's what I have to say. Any questions?
Hi, that's very interesting. Thank you. Have you looked at QP trees to increase the fan out to beyond 16?
Definitely, I have not. I actually have. I do not even know what a QP tree is.
It's a Calcus. It means more than 4 bits. So it's like sparse arrays as each node, and then you can have I think up to 64 entries per node. So the depth of your tree will be much smaller.
Interesting. Okay, well, I can say this. I honestly haven't looked. I can give you the best informed answer I have, which is that one, the 16 base tree makes sense because obviously it represents a nibble, right? And we have these values represented in hex. Being able to access a nibble just by a single hex value makes sense. Additionally, we have this child tree structure where if there's something about your blockchain, which this is the perfect tree to use, I think you can implement it under this child tree notion. Fred has the mic and he...
I can just say we have looked at sparse Merkle trees, but they're sort of research territory. And like this is an area that we know this works, we know what the implementation is, what the abstraction layers look like, we know how to work in this world. I think either sparse Merkle trees or some completely different accumulator is the way to go in the future. Like Merkle trees have a ton of problems, and you can solve them with things like RSA accumulators and a bunch of other structures. But like RSA accumulators come with a trusted setup, and sparse Merkle trees come with their trade-offs, and none of them have any like sound implementations in progress that I know of, at least. So it's a bit yes, but research.
Yeah, but I do think an important takeaway for everyone in this room is that we understand that what you might be building may not have the same assumptions that we have when we're building the rest of Substrate or Polkadot, and you might have some tree system that you really want to use, and we have the abstractions available to allow you to use these parts in the isolated parts of your module storage that you need. But I don't think, for example, all of our balances and all of our other modules will use our generic structure by default.
Is that, yeah. Can you elaborate a bit on what the child tree pruning challenges are?
Yes, I can actually. I learned this. Basically, I think right now, again, you remember that the hash of the actual database location is based on the contents of the try node, right? Let's go this one, right? So that you actually hash this node and you actually get the value of the database location. If you can have basically the null node, which has no values in it, and that will generate the same hash twice. And then you can have two different empty child trees basically point to the same database place, and this can cause problems. Like if for some reason that you clean it up, you basically get conflicts in this empty node space. Beyond that depth, I'm not quite sure, but that is the general problem that I think is being solved. That just basically trying to resolve any conflicts with where a child tree is being located. And I believe the solution is basically prefixing it with some kind of arbitrary prefix that you can define. So I want to have a child tree, and I'm going to define the beginning of the child tree with some unique value, like my tree, and then it'll prefix that in addition to avoid any type of conflicts between two different trees. But that's the best of my understanding in terms of what the current problem is. Yeah. And there are PRs available.
So maybe I'm confused, but you talked about the possibility of having a value on the branch and not on a leaf node. And it wasn't entirely clear to me why a value would end up on the branch, because if you're hashing the value, you should get a full hash, which should take you all the way to a leaf node, I would assume.
Yeah, so this is the picture you're talking about, right?
Yeah.
Okay, so first we need to agree that there is arbitrary key path allowed in Substrate. So you will have a path which has this, which is a leaf node, and you will also be able to define a path which should have some value, which is a subset of this path.
Okay.
So we agree that there must be some kind of subset here which also has a value. And basically what we allow is through this prefixing, we can basically define like this branch with prefix 11 is different than this branch with prefix 10. This prefix 11 branch has a value. And basically when you go to this path here, you're going to be able to find the children, but you're also able to find the value of that path. So the reason why we allow for a branch to have a value is basically to allow this arbitrary path length.
But isn't doing that what allows for like the attack that you were talking about, where you could have something stuck under like a large data blob?
Right, but I think in general, so that is a possibility of an attack, and it's something that you can avoid by doing other best practices about how you generate the tree key path. But the thing is, I think what the important part is that our layer keeps it abstract. If for whatever reason you have a decision to make, this path here, you can. You can also make your layer, again, let's go all the way back to the beginning real quick, that there's this SPIO, right? This is ultimately where you define the keys. And we generate the tree paths using that hashing in the declare storage API. So we actually will not run into this problem if you follow our API, but we leave it to you as arbitrary as possible to do what you want to do. I think it's kind of one of those things, it's a power. You can use it, you cannot use it. We provide a safe way to use it. If you choose to use it, you should be conscious about how you're using it.
Okay, so you can just shoot yourself in the foot basically by putting large data blobs at a branch and then putting stuff under it, and then your Merkle proofs are like gigantic. And
I think so. And we actually had a conversation with some of the other parity devs about even ways you can optimize that. For example, instead of having the value in the branch itself, you could hash the value, have that be in a database, and have only the hashed value in the branch, right? And then of course all your branches would be like fixed size, fixed length, I mean. So you would avoid this kind of problem. But that incurs an additional database read. So I think you as a runtime developer, if you're brave enough to go into the Rust code, could probably even make that happen within the storage. But I think our current choice are based off the assumptions we've made about our own storage APIs.
Okay.
Makes sense? We have a hand in the back, the very back.
I have two questions. First, I didn't understand how the child tree is different than a subtree. Like if you just move what you draw.
The prefix tree?
No, child. Because you said when you update the child, the hash will come up to the main tree as well.
Yes. Let's look at this picture. Love pictures, right? Where was it? This one, right?
Yeah. So if you just had a space and you put it there.
Yeah. So basically, you have a child tree. You generate this root node, you hash it, and this hash value is placed into this leaf node. So as you change the child tree, this hash will change, this value will change, this node will change, and it will propagate all the way up to changes up here. So as you change the child tree, it will update this root node through this process. It's just different. This is a lookup, basically. This value is a lookup. Hey, a child tree starts here. And it just points you to a different part of your database.
If you would move it there instead.
Like if you actually put more nodes underneath this.
Yeah, because okay.
Yeah. So then you're talking about the difference between like a prefix tree and a child tree. So the important thing to remember here is that the child tree itself is some kind of interface, it's some kind of abstraction, right? Mm-hmm. And so the thing I mentioned here about the prefix tree is not being not having this same API. You can't get the root hashes because we basically haven't implemented a way in the API to just grab the root hash of any node. I think it's just I don't know exactly why we wouldn't implement the API, but we haven't. But child tree itself is its own kind of abstract object, and this is why you can actually implement your own tree structures using this child tree thing. If you started here, and then all of a sudden you were using a brand new tree structure, it wouldn't work. Your code wouldn't be able to traverse this half of the tree and this half of the tree the same way, right? But if you say, starting here, I'm going to jump somewhere else and use a completely different abstraction, it makes sense, right?
Almost. Like you could have given the API, but underneath not be actually this.
Again, I think that a lot of the storage APIs will be changing. I think that I don't know the historical reasons why we just now moved to prefix trees, why we haven't been using child trees altogether, but there are some problems with the APIs, and I think long-term vision is everything will be child trees.
Mm-hmm. The second question, so when you put for the pruning slide,
yes.
So there are like different value for the same key in the database, no?
No, actually, so this is all unique, right? So this root hash will be different than this root hash. So there'll be different values for the same tree path. That's correct, right? So they're saying the tree path will have different values, but its location in the database will be different, inherently because the value in that thing is different. So you must say, if I want to get this tree path information for which block, I want to get the tree path starting at block 43, I will navigate the tree path down, and I will get some value. But if you say starting at block 42, I will navigate the same tree path but get to a different point because these nodes represent different values.
So KVDB keys depends on the value.
Yeah. So again, the KVDB key is the hash of this whole tree node, which
Okay,
has the value.
You're right.
Right? So really, every single node is unique. And when you're adding new values to your database, you're literally creating new database entries. Every single new value in this thing is a new database entry, and you navigate to that database entry using this tree path. Again, the tree path is a virtual table. It's a virtual tree here. Really, the only thing that exists is a key value database as a table. Right? This is the. Okay. We have one last question that I'm gonna stop talking.
So as a best practice, you recommended using structs over multiple values. Is there kind of a point at which that would no longer be true? Like, I mean,
yeah. So
otherwise, the logical extreme of that is like we have one struct and it holds all the data for our module.
Yeah, and that is exactly this size of the value thing. So you should not be doing things crazy like that. Like if you're trying to access a single value in this big thing, it should be its own value. Like if there's logic which running this function will access this one value, that should probably be its own storage item. But if, for example, I have a kitty, right? And a kitty, I'm always going to be looking up like what is its owner and its ID and it's this. You could put it in a struct. Actually, in my upcoming kitties tutorial, I'm going to actually split it up because it's going to be, we don't have enough items in my kitty module to really, justify the difference between 3 items or 1 item. Like n doesn't matter if it's 1 or 3 more, right? But at the overall level of your runtime, you really should make conscious decisions. Like if I'm adding a new item to my runtime to upgrade it, if I can put it into a struct, that'll be better. And there are times you see that we shove some data into a struct just to optimize the fact that we always use this data with the context values around it. So again, this is kind of a decision you need to make your decision. It's hard to be up here and be like, this is what you should always do. Always use a struct, have everything as one struct. That is not the correct thing to do. But you have now the tools and the information to basically make that decision yourself. You should look again at the code you've written and figure out, okay, is this value being used in the same context at all the same times? Right?
Okay, so like if you had accounts and there was a lot of information associated with each of these accounts, they should probably be separate values as opposed to a gigantic lookup, a gigantic map.
If you have information about accounts which all is kind of independent of one another, yes, they should be separated. And if you think about it, we have all this different data about accounts, like whether it's a validator, it has some stuff in the validator modules, and whether it's just its balance in the balances module, we split it up itself. But if there's something about it, like being a validator, you have a bunch of properties that you that you want to update. Like how much commission do I want to take? Plus what is my whatever validator status, all that kind of stuff. Those things all get updated in a single function. Like it's like update my validator preferences, right? And obviously then we should have validator preferences be a single struct because we're always going to update it using one function in one time. Right? We're always going to read it once, update everything, write it, and so it makes sense to make a struct. I think we have one more here in the front, or in the back. Wow, lots of questions. Storage is cool, right?
Yeah. A simple question. Are there any plans for changing RuxDB to hyper-level DB or other new generation?
Yes, my understanding is that the abstraction layers we've built allows for you to swap RuxDB with another key value database. I think we as a substrate or a parity, we're not going to be making that a friendly thing. I don't think we're spending any time being able so you can switch to whatever key value database you use. But I think RuxDB has the needs that we want. I mean, we've been pretty happy with it, I think, for what we're doing, for our needs. But the abstraction levels, I think at a certain point, again, if you're brave enough, you can get in there, and I think it would be possible to change it.
Okay, we've got one more question.
Cool.
So can you talk a little bit about the difference between storage for modules and storage for smart contracts?
Yeah, so
particularly in the context that I hear that
child trees.
Transactional changes to storage for modules is coming.
Right. Okay. So the contracts module is probably the most advanced module we have in Substrate, and it of course allows for contracts to have their own storage, and these are actually child trees. We actually use child trees in this case. So for every contract, it will have its own child tree, And the data will be put there. So I don't know if I need to say more than that for your particular question, but really, when you're accessing the storage and if you look at the code, we will use a child tree to represent all the storage items for all the different contracts in your contracts module. Is that enough, or is there maybe something more specific that I can attempt to answer?
So, yeah, as I understand it, storage for smart contracts is therefore revertible in terms of using overlays.
Right.
Whereas for modules, so far it's not revertible, but
yes,
transactional storage mutation would change that.
Yeah. So the overlay chain, this transactional overlay is actually, this logic is built into the contracts module. So Sergey himself has written all this code to be able to allow you to manage basically if the contract function failed, that it could get reverted and that isn't updated. And he does this by making some assumptions about what contracts have access to, I think, at the moment. I will say this, if you go to Substrate and you look at one of the PRs, there's a PR which is actually going to, which hopefully will enable this transactional overlay at the runtime level. So you'd be able to define saying, hey, this part of my code is going to be in the overlay, and at this part of the code, commit it. And this is something that ideally will get in there. I think there's been some kind of problems getting it merged because it's kind of a heavy change, but I think we absolutely know about this problem. I mean, we heard the last presentation that this is one of the complaints that we have, and we actually have a current PR right now with, I think, all green check marks that will solve this problem. And so if that's the case, then I think even Sergey will be able to remove his unique abstractions and basically use this transactional overlay for reverting the bad state changes for any type of transaction to the runtime level. Okay, cool. Great, thank you for your time.
So next up, we have Adam, head of blockchain at Polymath, who's going to be talking about decentralized identity for regulated assets. Welcome, Adam.
Hi, everyone. It's great to be here in Berlin at Sub0.1. So I'm Adam Dosser. I'm the head of blockchain at Polymath. So Polymath's mission is to unlock global access to wealth creation through a digital economy. So we have a layer 2 protocol on Ethereum, which has been live for around 2 years now. And we've recently announced this kind of new initiative to build a new security token purpose blockchain called Polymesh using the parity substrate framework. So what I want to try to cover today is a little bit about our journey to Substrate, why we decided to use the Substrate framework. I want to talk about some of the kind of design and architecture decisions we've made during that process. And we're continuing to make. And I want to do a little bit of a deep dive into one of the components, which is identity, which is kind of absolutely at the core of Polymesh and what we're doing. So journey to Substrate. So back in late 2017, Polymath was founded, and we had this very clear mission to bring regulated securities and assets to public blockchains. So back in 2017, Ethereum was there. Ethereum was a pretty mature network. There was kind of a great community. There was pretty good tooling. There was some best practice around sort of smart contracts and deploying protocols on Ethereum. So it was kind of an obvious choice, and that's what we did. We've released version 3.0 of our protocol on Ethereum. We're about to release 3.1, and releasing on Ethereum for the last 2 years has given us this kind of great opportunity to kind of get traction, get adoption, and also importantly to learn lots of lessons about the technology, about obviously blockchain technology, as well as the kind of business around regulated assets and securities on blockchains. So what are some of those lessons that we've learned? I think there's lots of lessons. The first is the kind of importance of standardization, particularly to the financial industry. So we kind of led the creation of this ERC 1400 standard, which is this library of interoperable security token standards. And that's seen lots of adoption. We have a bunch of different companies using it, Consensus using it, and many others. So that's one important lesson, was kind of this idea around standardization. Another key lesson or a key insight was this requirement for kind of modularity, flexibility, and extensibility. So, in the regulated world, you have dozens and dozens of different asset classes. You also have hundreds and hundreds of different legal jurisdictions. So if you want to be able to, we have, our mission is kind of to be this global platform, right, which can be used for any asset in any jurisdiction. So if you really want to fulfill that, you have to make sure your protocol is pretty extensible, right? Because it's very hard to anticipate up front every single possible regulation, every single possible law and compliance that may apply to any kind of pair of asset and jurisdiction combination. So that extensibility, very important. Another lesson we learned, right, is that there's a lot of stakeholders. There's a lot of different kind of requirements in the space. So we have spent hundreds and hundreds of hours talking to regulators, standardization bodies, issuers, investors, KYC providers, custodians, exchanges, legal marketing firms, and so on and so forth. So lots and lots of different stakeholders, and they all have requirements. They all have kind of considerations, and over that time, there've been a few, I guess, insights, particularly related to Ethereum, which is obviously where our protocol was based, and around the kind of adoption side, certainly some of the larger, sort of more risk-adverse institutions had some kind of particular concerns around Ethereum and the approach taken by Ethereum. So, and I love Ethereum. We've been working with it for a number of years, but there's this kind of saying, right, that you can please all of the people some of the time, or some of the people all of the time. And Ethereum is very much in the former category, right? So Ethereum is a general purpose platform. It's not optimized for any specific use case. So it's not optimized for CryptoKitties or prediction markets or DAOs or security tokens. It's kind of tries to be general across all of those different use cases. So there's a bunch of design decisions which kind of reflect that and which are really suboptimal for our specific use case of regulated markets and compliance and security tokens. So I'll give a few kind of concrete examples to sort of highlight our motivation to move away from Ethereum towards Substrate. So one of the concerns that's raised, say, particularly by larger, more kind of risk-adverse institutions is if you're executing a transaction on Ethereum, you obviously have to pay a gas fee to do that. That gas fee is consumed or is sent to a miner. That miner could be in Europe, it could be in North America, it could be in Asia, but it could also be in an OFAC or a sanctioned country, so North Korea or Iran or whatever your favorite or least favorite sort of sanctioned country is. And for a large institution, which is in the kind of full glare of regulatory scrutiny, that can obviously be problematic. That's one key concern, is that kind of permissionless mining process. Another concern often raised is around finality of transactions, right? So one of the kind of touted advantages of blockchain is that you have this instant settlement. So, you send, if you're purchasing, let's say you're purchasing a security, you send your stable coin, you get your security back in a kind of single atomic transaction, and it's settled instantly. But, in practice, that's not really true, right? So with proof of work, blockchains like Ethereum, obviously like Bitcoin and many others, what you really have is you have a probabilistic guarantee around that settlement. So depending how deeply your transaction is buried in the chain or how deeply the block that it's in is buried in the chain, you have a kind of probabilistic guarantee. And we've seen some pretty major blockchains. So I think Ethereum Classic, I'll pick on as one example. We have seen block reorganizations of, I think, up to 2 days a few months back. We saw a massive block reorg on Ethereum Classic. So really, if you're a bank or you're some institution using this blockchain, you don't really have instant settlement, right? You have to really wait, potentially some relatively long period of time, right? In Ethereum Classic, probably up to 2 or 3 days to have that guarantee around settlement. And to really understand that, you have to kind of get your arms around the fairly murky world of miners, mining pools, ASICs, hash power, all these sort of things, and sort of understand that so you can understand what the sort of guarantees you have around settlement and around transaction finality. So that's another problem that's often raised. One last kind of concrete example, which is raised a lot to us, is around forks and governance. So Ethereum, and I have a lot of respect for Ethereum. They kind of cleave very, the core devs and Ethereum developers cleave very closely to this sort of decentralized ideology, which is great, but it means that there's always some probability of there being a contentious fork. Maybe it's unlikely. Obviously, there are examples in the past, Ethereum Classic being the obvious one, where there has been contentious forks. Quite possibly, and this is maybe contentious, right? But as we approach Ethereum 2 or ETH 2, there's some probability of there being some more contentious forks in the future. Actually, for crypto-native assets, forks are maybe not a terrible thing, right? You have Ether, you have ETC, they coexist. The market gives both of them a value. But for when you're tokenizing real-world assets, it's more problematic, right? If you tokenize a building and it's a blockchain fork, or let's say a fork in Ethereum, unfortunately, the building itself doesn't get duplicated, right? The building is not forked, so you have to choose a side, you have to choose a fork, and if you have a protocol like Polymath, and you have a whole bunch of asset issuers, and some asset issuers want to go on one side of the fork, some asset issuers want to go on a different side of the fork, it becomes complex to manage. And the advice from regulators and kind of some of the big auditors is that if you're going to use a public blockchain where that's a possibility, you need to have like a kind of governance council or some sort of working group that monitors that risk. And that's a big ask, right? It's a big burden on these types of companies. So these are some of the kind of motivating factors that led us away from Ethereum towards Substrate. Why Substrate? I mean, we've heard obviously a lot over the last couple of days as to the kind of features around Substrate. It gives you all of this great functionality out of the box, but also gives you the power or the kind of option to adjust and tweak that functionality, both at the kind of consensus level, so right at the kind of basic enabling level of the blockchain, but also to add business logic right at the kind of core level or layer one of the blockchain. So you can kind of add this business logic at the core level, and you can also tweak all the consensus stuff that you need to tweak so that you can optimize it for your specific use case, which in our case is regulated assets. So I'm going to talk a little bit about the architecture of Polymesh. So there's sort of three levels I'll go through. The first is the sort of base level. I've called it security here. I'm not sure if that's the best word. So Polymesh is a public blockchain, but it is also a permissioned blockchain. So what does that mean? There are some some aspects of that. So the first is that every network participant must go through some sort of basic KYC process. So everyone who wants to use the network, who wants to submit transactions to the network, has to go through a basic KYC process. That means obviously that the network has a kind of root of trust in these KYC providers, and that set of KYC providers is managed through transparent on-chain governance. I'll talk a little bit more about the on-chain governance, but there's kind of an on-chain governance process that manages the addition or removal of KYC providers that are trusted by the network. Another aspect is that the validators or block producers, the kind of nodes which are contributing to consensus and producing blocks, are permissioned. So obviously in Polkadot they're not, and by default in Substrate they're not, but in our kind of implementation of Polymesh using Substrate, they are. So this kind of helps obviously address some of the problems I talked about just a few minutes ago. And again, that set of permission validators is managed through transparent on-chain governance. So in terms of the on-chain governance, the way that works, it's similar to, or has some similarity to how Polkadot works and how other blockchains work, but you have there's kind of one part which is token holder led. So if you hold Poly tokens, you can propose new changes or upgrades to the network or inclusion of new KYC providers or validators. And there are also these kind of governance committees who are more kind of federated layer on top of that. So we have this sort of on-chain governance. The next layer is a sort of business logic layer. So we have these runtime modules, or I sometimes call them financial primitives. So the idea here is that you can take key core bits of functionality needed for regulated securities, like identity, key management, regulated assets, settlement, and so on, and have those as runtime modules. It makes them, means they're accessible, they're standardized, they're easy to interact with. You can kind of fix the costs, like the kind of gas costs or transaction costs associated with those. And obviously because it's Substrate, you can upgrade them, you can iterate them as needed. And the last one's kind of interesting. So, I talked about modularity and extensibility. So it's great to have this kind of core business logic as runtime modules, but obviously runtime modules, although they can be upgraded using a network upgrade, that's a relatively heavy process to upgrade a network. It's a relatively heavy process. So the way we've addressed that extensibility is we introduce this idea of smart extensions. So a smart extension is a smart contract which is written in a particular DSL, and it's constrained in some ways. And the idea is that you can have these smart contracts or these smart extensions and attach them or plug them in to certain runtime modules or financial primitives to extend the behavior of those runtime modules. So to give a concrete example, suppose that you have a compliance rule that says you can have at most 100 investors in your asset. You can codify that compliance rule, so codify that you can have at most 100 investors in your asset in a smart contract or a smart extension, register that smart extension with your asset, and then every time you execute a transfer of your asset, it checks with that smart extension that you're compliant with that rule, and if you are, great. If you're not, the transaction fails. And the same logic applies to, say, pricing or STO. So if you're fundraising, if you're selling your assets on chain, maybe you want to set pricing based on tiers, or you want to set it based on timing, or you want to have some sort of auction-based methodology to set your pricing. Rather than us try to build all of that logic in at the runtime level, we allow users of the blockchain to define that in smart contracts, connect that into the settlement runtime module, and then define their own logic, which is then used by the settlement module when people are purchasing the asset. So one reason this is kind of interesting is that when we first looked at Substrate, sort of towards the start of the year, contracts and runtime modules kind of lived in their own universes. So you had the contracts SRML module or palette module now, and you obviously had runtime modules, but there's very limited sort of interaction between those two worlds. So one of the things we've been working with the Parity team over the last couple of months is to help flesh out and bring richer interaction between runtime modules and smart contracts, so that smart contracts can read state from runtime modules and vice versa, and you can kind of interoperate or interact between those two worlds. And that's something which is in progress. I think there was some PRs merged into master a couple of weeks ago. There's a bunch more work coming this month. We're hoping that most of that functionality will be done this month. So that's something which is exciting. I think that it's obviously important for our specific use case. I think that type of functionality really helps to kind of showcase some of the power of Substrate and some of the power of kind of having runtime modules and smart contracts to work with, and how you can kind of use them together to really kind of provide some powerful functionality. Okay, one more slide very quickly. So I think I talked about actually the first two layers. We have our financial primitives, which are basically runtime modules. We have our smart extensions, which are these smart contracts, or these slightly constrained smart contracts written in DSLs, which plug into certain runtime modules to extend the behavior. And then we also want to open up the network to unconstrained smart contracts, right? So that you can start to see these sort of open finance or DeFi protocols come to Polymesh. And DeFi is obviously super innovative, exciting space. There's a whole bunch of people working on it. We think that there are two constraints to DeFi protocols as I see them today. One is that they tend to focus on kind of crypto native assets and utility tokens, things like Ether and utility tokens. If you can bring regulated assets and start using your Tesla shares or your Microsoft or Apple shares as collateral and so on, that massively expands the kind of scope of what you can do with DeFi and open finance. And the other constraint, the reason that most of these DeFi protocols rely on over collateralization is that you have a sort of Sybil problem, right? So the worry is if you borrow assets on chain, you can obviously run away with those assets unless you're over collateralized. Because Polymesh has this basic KYC process that every participant has to go through, there is some measure of Sybil protection in Polymesh, and we think that also can kind of greatly expand the design space of open finance or DeFi protocols. So that's something we're very excited about. Okay, so I'm going to talk a little bit in more detail about identity. So what is identity? So identity in Polymesh is absolutely kind of core to what we do. So typically in a blockchain, every transaction is mediated through an account, right? A sort of public-private key pair. You sign your transaction, gets sent to the network and included in a block. In Polymesh, every transaction instead is associated with an identity. So every single transaction in Polymesh is mediated through an identity. So what is an identity? An identity is effectively a collection of claims or attestations from other identities. So you can see some examples. This is an example KYC claim here. There are some standards around sort of self-sovereign identities. So the W3C group has some standards around DIDs, which are decentralized identifiers, DID documents, verifiable claims, and as, to a large degree, we're kind of compliant with those standards. It's an evolving space, and it's we're kind of involved in lots of those groups defining those standards, but we're trying to comply as far as possible with those standards. So how does it work? So something else that's worth mentioning is that all of your assets, so as well as all transactions being mediated through an identity, any assets you hold on Polymesh are held at the identity level, not at the account level. So any poly balances you have, but also any securities or assets that you own are held at the identity level, not at the account level. And last but not least, so there are a few constraints that, because we're operating regulated markets, there are a few that has an impact or adds some constraints to the way identities are managed. So for example, if you want to hold, let's say you want to hold Apple shares, that means in order to hold Apple shares, you must allow Apple to be a claim issuer on your identity. So generally speaking, you kind of control who can issue claims against your identity. But if you want to hold a particular asset, you must allow the issuer of that asset to make claims about you so that they can, so we have this logic which allows asset issuers to manage transfer restrictions based on identities and claims on those identities, and so that the issuer of that asset can kind of be in control of that process, they have to be able to make a claim about you. So for example, if you're an employee if you're an employee of Apple, they would make a claim that you're an employee of their organization. There may be some transfer restrictions that apply as a result of that. So that's identity. The next kind of related bit, right? So if all transactions are mediated through an identity, identities can't sort of naturally sign transactions, right? So you have to have some way of actually kind of controlling that identity. So what does that mean? So the way we've modeled it is that every identity must have exactly one master key. So there must be one account, which is a kind of like an admin account or something like that for the identity. Typically that account will be like a secure account, so maybe generated on a hardware wallet or a paper wallet and held off chain and so on, and would interact relatively infrequently with the identity. So every identity has to have exactly one master key. And in addition, you can create and attach multiple signing keys to your identity. And signing keys are other keys that can act through your identity, and they can have kind of constrained roles. So, I think there are some examples down there. So, you may want to create a signing key for your CFO, or maybe a signing key for your COO, which only has a role, only has permission to update the documentation associated with your assets. So they can't mint new assets, they can't transfer assets, or maybe you want to create a signing key that only has permission to transfer assets and can't do anything else, can't mint assets and so on. So you can define these very kind of granular or fine-grained permissions for each of your signing keys, which gives you the flexibility. It lets you kind of delegate functionality. It lets you, kind of create this kind of set of signing keys with very specific permissions. You can manage the security, obviously, of those keys, depending on how the keys are generated and managed. You can have appropriate kind of permissions against them. The other thing you can do with signing keys in Polymesh is that obviously you can have external signing keys, where an external signing key is effectively just a public-private key pair that you sign transactions with, but you can also have other types of signing keys. So one example is a multi-sig. So for lots of different use cases, you may want one of your signing keys to be a multi-sig, where 2 or 3 or 4 or 5 different individuals have to sign off on a transaction before it's executed. So you can have signing keys which are multi-sigs. And then another interesting use case, which is kind of shown up here on the slide, is that you can have a signing key which in turn is another identity. So in this example up here, you have Apple, so the identity on the left is, let's say, for Apple, and the identity on the right is for a transfer agent. Apple may want to delegate certain functionality or certain permissions to their transfer agent. So the transfer agent has their own identity, and Apple can set up a signing key which is linked to the transfer agent's identity, so that transfer agent can then act on behalf of or act through the Apple identity. So it's quite a nice kind of feature, right? It lets you do a few things. It means that the transfer agent has kind of full autonomy and can unilaterally manage their own keys. So if the transfer agent wants to add a new multi-sig signing key to their identity, they can, and that's sort of independent of the clients for which they're acting on behalf of. So you have that kind of nice sort of split of responsibilities. And it also lets you model different types of organizations. So maybe, some examples, you might have an organization which has its own identity, which has employees that have their own identities in turn with their own claims, and the organization wants to kind of permission or add signing keys for certain of their employees' identities. So it lets you model things like different kind of organizational relationships and so on and so forth. So it's a kind of nice way to represent that type of behavior. So that's kind of key management. So I'll give a kind of quick update on where we are in terms of roadmap. So we've been working, so we started working on Polymesh around April this year. So we've been working on it for a number of months now. We kind of completed a proof of concept a couple of months ago. Obviously, as lots of people have said, Substrate itself is a rapidly evolving code base. So that's a challenge, but it's also exciting. It's obviously bleeding edge technology. We're aiming to release the testnet in Q2 next year, so Q2 2020, and then move on to the mainnet in Q4 2020. That's the high-level roadmap. Something else to mention, so we recently open-sourced our code base. So our code base is up there. So if you Google Polymath or Polymath Network and GitHub, you'll see our code base. Lots of the stuff I've talked about today is already on GitHub. Obviously, it's a fast-evolving code base. We have a bunch of engineers working. There's PRs going in every single day, but it's out there. There's a lot of interesting functionality. We use some of the stuff that's been talked about this week. So we use sign extensions to manage this idea of every transaction being mediated through a identity rather than an account. We use sign extensions for that. We're using off-chain workers for certain types of functionality and so on. So lots of kind of interesting use of some of the Substrate functionality is there. One of the reasons I'm excited about working with Substrate is the community that comes with Substrate, and we're trying to give back to the community in some way. So some of the work I mentioned around smart contract and runtime module interaction is obviously all going back into the main Substrate master branch. But we're excited about people taking a look at the code base. We've had a few PRs and a few issues created by third-party developers. So if you're a developer and you're interested in Substrate or Rust and so on, come and take a look. We're, any good, bad, or ugly comments or issues, we're all super interested to hear from. The other thing to mention is that we are hiring, we're recruiting. So if you're a developer and you're interested in the space, in Rust, in Substrate, in regulated securities, then I think on the next slide there's some email addresses, or you can come and find me. I'll obviously be around today, but we'd love to hear from you. Yeah, and that's it. So there's some email addresses up there as our website and our GitHub. Come and take a look. We'd love to hear from you. I'm happy to answer any questions. I also have some caps for people who ask good questions to help motivate it. So yeah, so any questions?
So how do you handle kind of the bootstrapping identity trust issue? Like, like someone's like, hey, I'm the Apple issuer, so I can, make claims about this Apple stock. Like, is your company going to do that, or did you like find a group of entities that are going to do that? It seems hard.
Yeah, so that's a great question. As you say, there's a bootstrapping issue, right? Because you kind of so the answer is, so we have the idea is that we will have a set of trusted KYC and KYB, so know your client and know your business service providers. Companies like I won't say the companies, but a bunch of like reputable KYC and KYB providers who will be onboarded at Genesis, let's say. Those will obviously be decided effectively by Polymath and ahead of Genesis. Once the blockchain is launched, that set of KYC providers will then be managed through on-chain governance, but there will be an initial set determined effectively through kind of Genesis configuration on day zero, on block zero, whatever, of the network.
Hi, very interesting. Have you got plans to become a parachain in the future? What's your view on that?
See, that's a really interesting question. So parachains, parathreads, bridges, etc. One of the big advantages I see to working with Substrate is that, obviously, Substrate-based chains, there's a relatively easy pathway to becoming a parachain or parathread or whatever. And interoperability, interoperability is obviously key, whether it's interoperability with Ethereum, where we already have a protocol and a utility token poly, or interoperability with some of the other DeFi protocols we've seen presented today and stablecoin protocols is important. So it's an area we're looking at very closely. I'd say we have no immediate plans to do it, but it's something we're kind of tracking very closely. So we're probably unlikely to be a very early adopter, let's say one of the first parachains, but it's something that we're super excited about. We're tracking, we're keeping an eye on. Obviously there's trade-offs, there's security trade-offs, there's all this sort of stuff. So it's something, and you say there are different ways as well, whether it's a parathread, a parachain, or a bridge. There are different ways to kind of get into that interoperability layer. So it's something we're excited about, something we're keeping an eye on. It's not something we have a kind of concrete plan to do on sort of day one of the network. I can't throw that far, but you can maybe come after.
Hi, can you tell more about your cooperation with Charles Hoskinson and IOHK?
So could you just repeat the question?
Can you tell more? There on the slide, there was like you have a cooperation with Charles Hoskinson from Cardano and IOHK. Can you tell more about this? And the second question, where are you based?
Okay, yeah, I can answer both those questions. So Charles Hoskinson, so to be clear, right, we don't have a relationship with IOHK. We have a relationship with Charles Hoskinson. So Charles Hoskinson is one of our advisors. He's obviously a technical advisor, you could say. So he's helped guide our progress and guide our choices towards frameworks, including Substrate, and so on and so forth. But it's with Charles rather than one thing that's often a little bit unclear, right? So it's a relationship with Charles rather than IOHK or Cardano. It's just the sort of Charles bit of that. And he obviously has great experience. He's launched blockchains, obviously Ethereum and Cardano. So there's a lot of operational experience, a lot of technical experience, a lot of like business kind of knowledge and so on that he's he's using to help guide us. You asked where we're based. So we have an office in Toronto and an office in Barbados. Lots of our developers are remote though. So we have developers all over the world, and most continents we have developers at this point. So we're super kind of open to remote and decentralized working and so on. You can find me afterwards if you have any questions though. Yeah, go on. Yeah, thank you.
Hi. So it was really fascinating about the interaction between the runtime modules and the smart contracts. I understood from your talk that you spent a lot of time on the compliance runtime modules, and I was just wondering, with your smart extensions that are going to allow people to build new types of applications or dApps on top of that, how are you going to manage the compliance of those smart contracts that are going to use the base runtime modules in different ways?
Yeah, so I think that's a great question. I mean, so one nice thing, right, is because you can have rich interoperability between smart contracts and runtime modules and smart extensions. If you're building, let's say you're building a kind of compound-like protocol, let's say on Polymesh, you can, so today on Ethereum, Compound uses ERC20 tokens and so on, right, and Ether and so on. Rather than using ERC20 tokens, you can use our regulated asset runtime modules so that if let's say you're allowing someone to use Apple shares as collateral, you can use like the kind of regulated asset representation of asset shares, which comes with all the kind of compliance built into it and so on and so forth. So because smart contracts have access to those runtime modules and the compliance and all the functionality associated with that, these DeFi protocols can kind of implicitly make sure they're remaining compliant. Now, of course, if you have some DeFi protocol that builds an entirely new kind of representation of assets outside of our runtime modules, and they would lose that ability. But the intention, obviously, the reason that they have access to that functionality is that they can kind of leverage it and build on top of it. Yeah, thank you. I have another 3 or 4.
I guess the simple question is, who are your customers? Who's going to pay for this, bluntly? Is it more sort of the traders or more the asset issuers? Like, which side?
So in terms of payment, so it's a blockchain, right? So we're putting a lot of thought and time. We're actually working with some external kind of consultants or experts in like economics and tokenomics and that type of thing. So we want to make sure that the economic model of the blockchain is sustainable, is fair, has the right incentives for security and so on. And that is a work in progress, which is why I haven't talked too much about it at the moment. Obviously, we will be talking more about it. In terms of who our clients are, I kind of see it. My view is it's sort of like a 3-sided marketplace, right? You have issuers, so people who have assets who want to tokenize them. So that could be if you have a company or a startup that you want to tokenize, or a real estate fund or something. You have investors, obviously, who want to access those assets, obviously, for investment purposes. And then you have service providers, people like exchanges, custodians, KYC providers, those types of firms that are sort of providing services to participants on the network. In terms of payments, it's a blockchain. You obviously have, there are fees to transact on the network. The fees depend on various, both on kind of gas metering and functionality and so on. And so that's something we're still working through. And then, it's a proof of stake network. So you use, the security is through proof of stake and so on. It's a nominated proof of stake. So yeah, so those are our kind of key clients. There are, stakeholders slightly broader than that. So we spend a lot of time talking to regulators in various different countries in Europe, in Asia, and in North America. They're a stakeholder, whether they're actively participating on the network, whether they're just pulling data from the network or using it for reporting and so on. One of the things regulators are super excited about, one of the reasons to hold identity on chain, so there are other kind of identity solutions like Hyperledger Indy where identity is off chain. One of the reasons to have identity on chain is it means you can do compliance in real time, right? So you can have identity rules so you can have compliance rules that depend on identity, which you can enforce in real time as assets are being transferred, which is quite, the current process around compliance tends to be auditors come in every 6 months and do a retrospective audit, check whether an asset has been traded compliantly or not. If it's not, issue fines or whatever they do. The beauty of blockchains, bring regulated assets onto blockchains, is you can do all that compliance in real time, upfront, with real time reporting, and that's something that regulators are very excited about, whilst also being regulators, so risk adverse, somewhat, not the fastest moving kind of organisations in the world, but they are slowly beginning to engage certain jurisdictions more than others, of course, but we're starting to see that type of engagement.
Hello.
So I think the microphone isn't working, and I couldn't quite hear that.
Hello.
Okay, sorry. Where is the identity information stored, and how you handle privacy for that?
Yeah, so that's a great information, great question. So identity is broadly stored, so these claims and attestations are stored on-chain, but you can think of them as kind of being markers, right? So we don't store any PII or personal identifiable information on-chain for obvious reasons, because of GDPR and all these other kind of data privacy type issues. So, for example, so identity in Polymesh is pseudo-anonymous. You have a pseudo-anonymous string associated with your identity. And the marker will say, this pseudo-anonymous identity has passed a KYC check issued by this particular KYC provider. So there's no PII data. It's more like it's just a sort of marker that's on-chain. But having that on-chain does mean you can do this kind of real-time compliance. And if you have some transfer rule that depends on whether an investor is or whether an identity is accredited or non-accredited or qualified or sophisticated, you can do all those checks in real time on-chain.
All right, we've got time for one more question.
Hi. My question is regarding key management. You said one identity, one master key. And when it comes to like decentralized identities and decentralized key management, how would you ensure that a person that is using the service and buying stock from Apple, it's not going to be tracked through that one identity, one master key kind of system?
So you're asking how would it be tracked, or?
Yeah, like if it's one identity, one master key, then how does that work with like a decentralized key management system to like preserve users' privacy?
So privacy is an interesting area, and confidentiality is super important, right? So confidentiality and privacy, for regulated assets is very important. It's one of the key concerns of institutions and investors. It's an area that so with confidentiality, Polymath, we're more in the kind of R&D stage. So we have some cryptographers on the team, and we're doing R&D around that. Confidentiality would likely be in the next, sort of version 2 of Polymesh, rather than version 1. We're looking at all of the usual technologies, zero-knowledge proofs of identity, using zero-knowledge proofs to hide the amounts and types of assets being transferred. Identities themselves are pseudo-anonymous, so you have pseudo-anonymity kind of out of the box, but for that kind of higher level of confidentiality, that's something we're more in the kind of R&D phase, and for sure we'll be publishing more information, but it's probably a little bit early at the moment.
Yeah, okay.
All right. Thank you so much. All right, thank you so much, Adam. So, as you can hear, we've got lunch now. We'll be back at 2 p.m. When we're back on the workshop stage, Robin will be leading a workshop on ink. On this stage, we have a pretty action-packed session. We'll hear from Web3 Foundation about grants and Hack Osama. We'll hear from Parity about the Substrate Builders program. We'll hear from a lot of projects, including Radical, Soleng, Solidity Compiler, Subsocial, Vue Polkadot.js, Encounter, and Substrate T. A quick reminder that if you want to ask a question for the AMA that's going to be today at 5 p.m., go to slide.do, and the code is Sub0.1. All right, thanks everyone. Have a great lunch. reminder that if you want to ask a question for the AMA, that's going to be at 5 p.m. with Frederick and Gav, then go to sly.do, and the code is Sub0.1. So right now, we've got Dan talking about Hakusama.
Welcome to the stage.
Hi, everybody. Hopefully you had a good lunch and having a good time the last couple days. Thanks to Alex and Anna for putting all this together. I know it took a lot of work, so thanks for your hard work. I'm Dan Reeser. I work on community and growth initiatives at the Web3 Foundation. We're the nonprofit foundation behind Polkadot, working on a lot of research, community growth, collaborations, and the like. And today I'm going to talk to you about a hackathon coming up in January, where hopefully you can put some of the things that you've learned the last couple of days and over the last, the previous months as you've gotten deep into Substrate. So hopefully you can put that to work and start building some parachains and tooling on Kusama. So Hakusama will be a 6-week hackathon in mid-January going through the end of February. It'll take place online over the course of about 6 weeks, really to ensure that we can get some high-quality projects that are close to the point where they could potentially be implemented and integrated with Cumulus to the actual relay chain of Kusama. So the hackathon's going to look really like this. So there's a couple categories. Number one being parachain. So I'm not going to go through everything on the slide here, but a few examples just being like a privacy chain, a gaming chain like that came up yesterday in Rob's talk, a DeFi chain, and really an open-ended parachain challenge here just to get your creativity going and seeing how you can implement a parachain in kind of the real working Kusama network. And on the other side is the tooling challenge, so really just trying to continue building out the Substrate tooling to make the experience building with Substrate and building on Kusama as clean as possible, as easy as possible. So certain challenges we're looking for here would be like a testing suite, a transpiler for smart contracts, and then a Java being an example for an RPC client that still needs to be built for Substrate. The prizes here are pretty substantial, so we're looking for top 3 prizes in parachains and then top 3 prizes on the tooling side that will be given out from the judges over judging criteria that's really evenly distributed across things like the level of decentralization, how much this kind of integrates into the Web3 ecosystem as a whole, and a few other categories that the judges will be looking at as they go through that process. Just a couple more details. So the hackathon will take place on DevPost. It's not published live yet, but this will be going up probably in early January as soon as all that is finalized. And as I'm talking through this slide, if you're interested, you can scan the QR code here and just provide me your email address, and I'll keep you in the loop as things get finalized. I can send you the link to sign up for the hackathon, and you can start organizing a team around this. And then I just included the judges here. We have the 5 judges on the slide, and I think some of them may be here today, so thanks to you for already agreeing to help us out with the hackathon. And then last, another QR code if you finished the previous QR code already. This is for signing up for the ambassador program if you are interested. And I just wanted to see how many people in the crowd here are currently Polkadot ambassadors. So I've met a couple of you already, but thanks for coming, and come up to me afterwards. I'd like to meet all of you in person. It's great to see all of you here. But quick run through of the ambassador program. So we have 111 ambassadors and apprentices now across 37 countries in the world. And the community is very active. We have bi-weekly calls where people come and check in with other ambassadors on either technical work that they're doing or kind of community growth work that they're doing. The community is, like I said, about split half and half technical and non-technical. So there's plenty of opportunities for people to get involved. And once you get onboarded, we'll take you through the Trello board where we keep track of all the tasks and projects that people are working on so you can get a better idea of how you can start contributing to the community. And then here's just a few examples of projects that are ongoing at the moment. We have, I know, so Hyung Suk is one of our ambassadors from Korea. I just talked to him this morning, and they have a lot of work ongoing in getting a technical certification program going at Korea University. We have another ambassador, Alex, in São Paulo, Brazil, working on a Substrate implementation with a local enterprise there. And then last, there's a lot going on with translations of our content, documentation, website. So someone in Thailand has been working on a Polkadot and Substrate kind of local community and study group, and also getting videos and things out in the Thai language. So just a few examples I wanted to walk you through. And if you're interested, again, you can sign up here or just come find me afterwards, and I'm happy to talk more about what myself and Chris Hutchinson are working on with the Ambassador Program. So next, I'll hand it over to Dieter, and Dieter's going to talk a lot about the Web3 grants and how you can get involved in that.
Hi, everybody. Thanks so much for coming to Sub0. It's great to see so many talented and motivated people here. So I'm actually not really going to talk much about the grants program, counterintuitively to what Dan said. But I will be talking about kind of a major initiative, a major goal of the Web3 Foundation, which is a little more general than, kind of the theme of this conference. So, everyone here is, very focused on Substrate and building on Substrate, which is awesome. But what we want to do at the foundation is support the entire Polkadot tech stack. So, these very simply, this is the set of technologies that either contribute to or rely on Polkadot. And right at the top, we have user-facing applications. And a major goal of the foundation is to really kind of sponsor the build-out of this entire tech stack in order for us to, in order for you and, people in the ecosystem to produce effective, decentralized, user-facing applications. So one thing we've been working on at the foundation is to really, graphically represent the stack, which is not so hard. But then what's more important than that is to actually kind of take stock of all the pieces of technology kind of within that stack that we think we need, and where and kind of catalog where we are in the development of that, and what the remaining things are to be built out. So this is like a very broad picture of the stack. And right at the top, we have user-facing applications in many different verticals. So DeFi, gaming, I think Providence is up there. Immediately below that, we have kind of other user-facing things. So browsers, wallets, node explorers, block explorers. These are often things that users need to actually use applications, but sometimes you can also use them on a standalone basis. And then I think there's immediately below that, we start getting into like the more dev-focused layer. So, things like developer tooling, APIs, languages. This is an area that needs a lot of love. And right below that, we kind of start at the more, Polkadot Substrate-focused layers. So things like second layer protocols, Plasm, state channels, rollups. I mean, arguably, this is part of the layer below that, because these things are normally all, as the Plasm team is doing and as other teams are doing, implemented like right on the parachain or right on the runtime. But I think they're different enough that they deserve a bit of special mention. And then immediately below that, we have your runtime layer. So parachains, parathreads, bridges as well, mostly fit in here. And, I think right now, the majority of the teams kind of in this room and in the ecosystem are largely working on this layer. And this is kind of a function of where we are in the build out of this whole effort. Right now, kind of the different functionality built at this layer is going to be the most important in actually dictating the functionality of these user-facing applications that we'll eventually get. And then right at the bottom, of course, we have Polkadot. Well, not quite at the bottom. And this is, core protocol and largely a focus of Parity. And then finally, we get into the pieces of tech that Polkadot relies on. So peer-to-peer networking, the actual cryptography in there, WASM, Rust, and then deployment tooling right at the bottom, which is really things that you need in order to actually deploy the protocol. So node infrastructure, validator infrastructure, HSMs, kind of really low-level stuff that's super important. And so, this graphic on its own is like nice, but not super useful. But where things get a little more useful is actually when you kind of break down the pieces of technology within each layer. And so what we have here, we have the kind of runtime layer. And then, what we've tried to do is think of, okay, like what are all the pieces of technology that we want eventually built here? At least we think we want right now. And where is this at? So the first layer would be pieces of technology where either there's been significant work done on or where significant work is being done on there. And so, the reason why we sort them like that is because from the foundation's perspective, from grants and collaborations, we really want to know like how we should focus our time and how we should prioritize supporting the build out of different pieces of tech. And for kind of this top, like thin red band, we think, okay, there's already a lot of work being done here, and we don't have to spend as much time looking for builders to actually build out this layer. Similar to that, the yellow layer would be, pieces of technology that we think, where there's been some work done, but where we could probably use more people actually building things. So this would be kind of a medium priority layer. And then right at the bottom, which is like not coincidentally the largest and thickest layer, would be pieces of technology where there's been little or no work done on yet. So, this is where we, focus the majority of our time trying to at least source teams to actually build this out. And so what we want to do with this is we want to, do this breakdown essentially for each layer, which is, pretty well already done, but put this on the internet somewhere, keep it up to date, and really allow it to serve as a guide for the community to know where we're at with building out this stack. So, not only can you actually find pieces of technology that are relevant for what you're building, but if you want to actually contribute to building this stack, you know what we need and you know kind of what already exists. One other thing that's super important to mention is that all this, like this kind of general broad representation and this, slightly more detailed representation is really like our interpretation of things. We can easily get things wrong and there's probably things we're missing. So by no means do we want this to stymie creativity, and we don't want people to kind of think that this is all we need, or that we haven't missed anything, or there are things there that, or that there aren't things there that are also important. So by all means, if you have a great idea or any idea, like we want to hear about it and we want to hear what your impression is. So thank you very much. If you are interested in the Foundation's grant program, please get in touch. My email address and Telegram are on the board. There's general information about the grants program on the website, which is also on the board. And we're also hiring. So if you want to join a great team and help build out this tech stack, then please also get in touch. Thank you.
All right, thank you so much, Dieter. Next up, we have Fabian Gompf, VP of Parity, talk about Substrate Builder Program.
Hello. Yeah, so I can make this pretty quick. It's mostly an announcement. We're gonna do like a proper blog post and stuff like that next week, but you've heard it here first. We're launching something that we call the Substrate Builders Program. I'm gonna just describe briefly what it is and why we actually want to do this. So for all of you who have listened to Fred's opening talk yesterday, you should be all aware that this is a pretty fast-growing ecosystem, and we, as Parity, kind of like set the standard for us to really support teams in this ecosystem and make sure all the teams building have everything they need. We're slowly becoming victims of our own success. Like, it's impossible for us to really fully be up to date, who's building what, gather everyone's feedback and make sure it's being acted on, adequately support every team. So we thought quite a bit about how can we structure things differently to ensure this again. What we came up with is what the Substrate Builders program is. This is by no means a silver bullet for this, but it should help at least mitigate some of these things that we're seeing. So what is the Builders program? The Builders program is a program to identify, support, and mentor substrate-based projects that are building impactful chains. It is, there's no limitation on what kind of chains we're talking about. So whether you're building a parachain, a parathread, a bridge chain, or you're building a chain that has nothing to do with Polkadot yet, this is all eligible for this program. If we're talking about identifying chains, there will be an application process. I'm going to talk in a second about how this looks like. So what does this program entail? Really, the overarching idea is to provide Parity's internal resources in a structured and systematic way for teams building in our ecosystem. We support teams across multiple verticals. I think the 4 biggest verticals are technical support, that's the most obvious one. Another one is kind of like community, communications, media kind of support, funding support, and business development / ecosystem development support. I'm gonna say a sentence to each of those. So technical support, as I said, I think it's the biggest component. It's also where we have the most resources internally, and it's the one where we spend the most time on. I think most of you are aware or have spent some time in Substrate Technical, this, the Riot channel. This is the biggest form of open community support that we give currently. There are now like over 900 members in there. Essentially, if you want to get questions answered there, it's a post and pray methodology. You post a question and you hope someone at Parity will pick it up. That's okay for a lot of stuff. That's okay for a smaller community. That's okay if you have a very clearly defined question. The moment you're asking something about architecture, the moment you have maybe want to make a technical decision, that's where we intertwined with your economics or potentially even your business model. It's practically impossible to get an answer on. So tech support in this program is really meant as a very dedicated kind of support where we can have sessions and stuff like that around certain things that you want to get solved. Community support is all about the idea that a lot of you here are trying to build your own community around your project, be that online or offline. A nice thing is that Parity, and in particular in the broader Polkadot umbrella, we actually have quite a bit of a community of developers and enthusiasts. So giving you guys a platform to plug into that and be able to piggyback on that is essentially the goal here. Business development and ecosystem development support. This is actually something we're doing more and more. It's all about giving you the insights that we're seeing. We're still kind of like this, in the center of this ecosystem. We know what most people are doing, so we can give you quite a bit of insights into the dynamics of this ecosystem and the markets that evolve around it. We can make sure you're introduced to potential partners, customers, users, and so on. Funding, it's essentially just ensuring you have the money you need to build what you want to build. This can be via the grants program, which kind of like Dieter is heading up, but there's also a big network of more traditional venture capital and hedge funds that we are associated or connected with. There is more, there's crazier stuff coming soon, like the Polkadot Treasury that we can, help you navigate or at least, judge a little bit the sentiment in there, things like that. So to sum it up, I want to start with what we're not trying to achieve with this, before I jump in what we're trying to achieve. We're not trying to build a Substrate or Polkadot accelerator or incubator. At least not now, at least not with this program. This is very much complementary to any external program you enroll in. I would go so far that we are partnering with a bunch of external programs, and we are well connected to a lot of external programs. And this is, it's something that should augment that. There are things that we can offer that no external program can offer, and vice versa. We're not trying to make a program for any kind of ecosystem component. Maybe eventually we want to. Currently we want to start with something that's very well defined and that we think has high impact. And I think blockchains in our ecosystem are just, it is the case there. Yeah, this is what we're starting out with. We're not trying to make the Web3 Foundation grants program obsolete. Again, similar point as the first one. This is very much complementary. We might be able to help you navigate the grants process a little bit, make introductions and stuff like that. If you are building a blockchain and you have received a Web3 Foundation grant, please apply. We're not trying to establish an exclusive club, although there will be an application simply because we have limited resources on our end and we cannot just say, please everyone come in and get this dedicated support. All of the things that I mentioned are on an ad hoc basis available to everyone. If you ping people in Parity and say like, we're trying to raise money, like, can you guys figure something out for us? Like, we will still, help you. It's not about, shutting anyone out. It's really about giving structured means to deliver this. We're not trying to make money with this in any way. We're not taking equity. We're not selling consulting services or licenses, none of that stuff. This is really a service from Parity to the community for free. So what are we trying to achieve? We are trying to establish a structured way to deliver all these different support verticals to teams in our ecosystem, and we're trying to establish a more dedicated way to give and receive feedback. To give feedback to you, whether you're on the right track, whether you make the best use of our technology stack, but also to receive feedback on actual features that we're building, on documentation that we're writing, on processes that we have, and so on. We want to establish a single point of contact for program members. So currently what happens a lot, in particular for the teams that are heavily building in our ecosystem, and I'm sure there are people in the crowd here that can relate to that, a lot of people know 20 people at Parity, and they have this like mental map of like who's roughly responsible for what. They know their GitHub handles or their Riot handles. So if they have a question, what they do is like, oh, who could maybe answer that question? And then they just start shooting questions into our organization, either via email or Riot or or any of those. This is really, really, really inefficient for you and for us. Please don't do that. What we want to do is abstract all of that away from you. You don't have to understand who is responsible for what within Parity. It's also a very quickly changing, very fast-growing tech company. Have one person that knows the history of all the questions you had so far, all the sessions you had so far, knows actually what you're trying to achieve. That person might not be able to answer all of your questions, but probably is able to answer 80% of your questions, and then for the rest of the 20, can make sure you get the answer you need. Improve communication, collaboration between teams in our ecosystem, something we see happening more and more, something I would like to see even more happening. A lot of teams are starting to get together and do kind of like joint development stuff for components that they all need. I think this is something that we want to see much more, and that's just only possible if people actually have visibility into what's happening and are able to communicate to each other and know of each other. The last point ties back to what I was saying with the second point. Improve communication between the team that's actually building Substrate and the team that's building on top of Substrate. That's just really important to us. So applications are now open with the second. You can go to builders.parity.io. There's a website. A lot of the stuff that I'm saying here is on this website. There is an email address. You can ask questions. Applications are open on a continuous basis. We're not doing batches or anything like that. We do, however, need some time to scale this thing up and to find the right structure for it. So we want to keep the applications open till the end of the year, then look at what has come in, come up with an initial set of teams that we are going to be the guinea pigs, essentially, and then start operation in the new year, and then iterate from there and slowly scale it out. What else? Yeah, as I said, there's going to be a whole announcement next week. I have to give a big shout out to Eric. I don't know if Eric is in the room. Eric, somewhere? No. Well, ask for Eric. He has made a lot of this possible. So if you have questions, either find him or find me. Yeah, that's it. Thanks so much.
So next up, we actually have a series of talks. These are the lightning talks. They're all a little shorter than what you're used to, so it's going to be 10-minute talks. And to the speakers who are doing those talks, just so you know, there may not be that much time for questions, but we do have all of those meeting rooms back there. So if you could just go back there, and anyone who has questions can go and find you there after. So I think we're just going to get you set up. We need 1 second. We got to do the weird little. Okay. So, where's the display? How do I get the mirrored? That's weird. That shouldn't show up that way, actually. System preferences. This should be a. Yeah. Huh. Well, that's a new fun. Just 1 second. And I have the mic. I think this is. Is this one on? Yeah.
Okay, thanks. Hi, everybody. I'm Thomas. I'm working at Monadic. Let's see how this works. Yeah. I'm working at Monadic, and we're working on a project called Radical, which is a platform for decentralized open source code collaboration. And our vision is to kind of bring sustainability to the open source community with the help of this decentralized platform and blockchain technology. And I want to talk a bit about how we are developing our runtime with Substrate, some of the challenges we faced, and the technique we use to kind of circumvent these challenges. Okay, so let's set the stage. We started using Substrate, I think, 2 months ago. And what my team is doing is basically building this small prototype of a blockchain with Substrate. And this blockchain is consumed by an application, a dApp, which lives in the browser but talks to some background service. And so what we deliver to this team is a high-level Rust client to interact with our blockchain so that the app can transfer money, kind of register these open source projects and stuff like that. How does the client look like? So, as I said, it's a Rust client, and the basic idea is that it looks like this, that you have a function for transferring, for submitting extrinsics or transactions, however you want to call them, and a function for getting information from the state. This is what I mean by high level, so it's not like that you need to compose your extrinsics or something like that. Yeah, so I mean the details don't matter really. This is the kind of the gist of it. So one of the challenges we faced is how to test this, and especially how, like since we're in the very early stage, how to iterate on it very quickly, rapidly, and make sure that it's still working and that we can integrate with the app team from day one. And of course, what's the best way to do it is, if you're working with different teams, kind of acceptance level tests. So what we test is kind of our contract with the app team and like with everybody in the company who's involved in designing the business logic of the ledger. So how do acceptance tests look like? Pretty simple. We test the client that we deliver. So we instantiate it. We assert kind of the initial state of the thing, which is a given recipient has no money in their account. Then we transfer some money out, and then we assert that now the recipient has 1,000 of this token. Of course, I omitted a lot of stuff. If you write this, actually, you need to use async await and do some setup and so on. But this is the high-level thing. And the nice thing about this is, like, people from the outside that are not involved in the project can look at this and say, yeah, that clearly maps to my mental understanding of this. So we kind of assert that we implemented the ledger logic correctly, but you also assert that the client that we deliver to the app team conforms to the expectations of the app team. But acceptance tests have a problem. And for example, if you come up with that idea and you start with it and then you think, okay, I'm going to use the client, I'm going to spin up a node to actually run the client. And then you quickly run into the first problem is that whenever you change runtime code, Substrate takes 3 minutes to link your binary, and to actually test it, you're waiting 3 minutes to run the test. I guess all of you have experienced this in one form or the other. Other problems are, of course, you cannot really run the tests in isolation unless you tear down the node on every test case and reset the database and start it up again. And there's some other issues with that. Yeah, so the main idea is that acceptance tests are quite expensive. You need to control all the stack and then, yeah, set up and tear down. So what is the solution to this problem? First of all, one thing to consider is that what you're building and what you're testing is this code. But if you run this full integration acceptance test, then you're also running this code, which is the Substrate code. And I guess, like, for us, this is not even to scale. It's probably like a tenth of this if you compare the code size. And so the basic idea is you circumvent this code and only test this code, but on an acceptance level. And what enables this is a structure called test externalities that you can find in the, as of 3 weeks ago, in the SRIO module. I think now it's the SPIO module, and I guess it's going to be something else next week. So there you find this struct that has a couple of very nice features. And this struct is actually used in all the tests for the Substrate runtime modules. What you can do with this is you create it, you need to pass it some parameters that I won't go into. And what you can then do is you can call this execute with function on it. It takes a closure, and in this closure you can call this function. If you call this function from the SRIO module in from any Rust code, then it's actually going to error and tell you, okay, there's no storage available. Because this expects to be run in the Substrate runtime when kind of the storage of the chain is available. But now with test externalities execute with, it kind of provides the environment for the storage, and you can write something to the storage, as well as here get something out from the storage. And so we use this to find a solution to the acceptance test problem. We create kind of a test externalities backend for the Radical client. So instead of talking to a full node over RPC, we replace the RPC communication with a call to the test externalities and make sure that it's very, very close to how the Substrate runtime is actually called. And the way Substrate is structured makes this actually quite easy, because the main entry point is, for example, I think it's called apply block, and this is everything that you need to call to kind of simulate what happens on your blockchain if a block is imported. So this makes testing super fast, because we can run the tests in memory, we control the state, we can check different Genesis configurations, we can isolate test cases, yeah, and we use this for basically everything. And there's a nice side effect to this, or to using this technique. There's also something in it for the app team. For now, I just talked about how the team that builds the blockchain, the Substrate runtime, benefits from it. But there's also something in it for the app team. And this actually, we are still thinking about the name, but this is kind of a client emulator, or you could call it a runtime emulator. And what this does is, we not only ship the real client to the app team that needs to, and then the app team needs to run a node and compile it and whatever, but we also ship this emulator, which looks like a client from the outside, but internally runs all the code with test externalities and kind of simulates the whole runtime without going through network, without needing consensus, without needing to wait for the blocks to be created and finalized. And so it's as easier for us to tell the app team, okay, here's this branch. You can use the client emulator. They start up this this one background process which provides the blockchain without any of the overhead that Substrate has. And that's it. Thank you. You can check out the code and how we approach this in this repo. You can find out more about what Radical is under this address. And if you're interested in the project, we are also hiring. Thanks.
So we're actually a little ahead of time, so I think we can take one question for this talk, just one, if anybody has any. Give you a moment. Does anyone have any questions about this?
Well, yeah, I guess if you're interested, just come up to me and we can talk about it. Thanks.
Awesome. Thank you so much, Thomas. So next up, we've got the Solang Solidity compiler, and Sean Young is going to be talking about that. Welcome, Sean.
Thank you.
And we're just going to set you up with slides. Would you like to use the clicker?
Either is fine. I don't mind.
System preferences.
Yes, please. Yes, thank you. Hello, my name is Sean Young. I've started a project called Solang, which is to compile Solidity. Okay, so what do we have for Solidity today? So the Solidity compiler is a very large C++ project that has, it only can compile to EVM. It's very tightly bound to ETH. it has a handwritten parser and handwritten. It has a handwritten lexer, handwritten parser, then produces UL, and then from UL it has its own optimization parsers, and then produces the final output. So it's an entire compiler written from scratch. It hasn't reused any existing components whatsoever. And also the Solidity language has various limitations. So you can't do string compare, for example. If you Google Solidity string compare, you see some very odd things people will have to do in order to make that work. String concatenation doesn't work. And the maps, you can't iterate them. You need to know the entry, otherwise you won't be able to access anything in an iteration. So with Solang, what I decided to do was start a new code base and write it in Rust, generate the parser from larpop, and use LLVM for optimizations and code gen. So with Rust, that's already a big save because the AST fits really nicely into a Rust enum. So that makes it very easy to work with. Having generated parser also saves an enormous amount of code. And then lastly, using LLVM saves even more code because much of the hard work of a compiler is the back end and the compiler parsers. And I don't have to write any of those. So it targets Substrate. At the moment, it has an if and a scale ABI encoder. It's still very much early days, but this is what works today. You can run Solang. You can pass in an -O for optimization. The aggressive is literally the LLVM optimization level. And the Solidity there will compile to a WASM file and an ABI file. You can just deploy those in Polkadot directly, and it works. The flip of the WASM is at the moment about 1,500 bytes, so it is smaller than the output of ink. Okay, so as I said, Solang is a new project. It has limited language support. So bools work, uints, ints, sort of a basic arithmetic, have structures and functions, loops and if statements and whiles and so on work, and you can access contract storage, but that's really it. So what I'll be working on now is more language support, expanding language support, and that's supported through a Web3 Foundation grant. I'll be adding more data types first and adding structs, arrays, mappings, abstract contract storage, abstract contracts, etc. So I'll be working towards compatibility with Solidity. There are some things which won't be able to do because, for example, in Solidity you can write assembly statements which include literal EVM instructions, which won't be supported on WASM, of course. There is actually an EVM backend for LLVM in progress. That's still early days, so it might be possible to do EVM generation one day. So that's sort of the first aim is to have feature parity, language-wise. But beyond that, there are some interesting things we can do with a new compiler. But the first thing is that having the same ABI encoder decoder as Ink would mean that Ink contracts can directly call Solidity contracts and vice versa. This means, in order for this to work, both Solang and Ink will need to be able to read an ABI file, and from that, generate the correct invocations to external contracts. It would be nice if Solang itself can be compiled to WASM, because that would mean that you could have like a playground. In the Polkadot UI, you could have just a free-form text field where you can write Solidity, compile it in your browser, upload it, and use it. Another feature would be very good would be to have arithmetic overflow. LLVM provides all the infrastructure for that anyway. It just needs to be wired up really for all the arithmetic instructions. String processing could be so much better. So a simple string compare would be fairly easy to implement. String formatting, just a printf would be good. Other sort of features would be great would be to be able to iterate over mappings, other sort of data structures like dictionaries. So it doesn't have any form of generics. That is, it can be quite awkward. So I imagine something like the TypeScript generics would be a good thing to implement. Lastly, it would be nice if you could link C code against Solidity. So what you could do is write some C code, compile it with -f freestanding with Clang into WASM, and then in Solang you could link that easily by using the LTO linker in LLVM. The LLVM has a linker as a library, so this would be actually fairly straightforward to implement. The difficulty would be to define a foreign function interface for any sort of external programs. Right. Otherwise, so Solang, obviously the first target is Substrate, but once you have language support, adding other targets is relatively easy. So it already supports Subledger Burrow. I've spoken to the guys from Sawtooth and Fabric. They are very interested. So that could be added. Lastly, EWASM is an obvious target to add, which would be very interesting because then you could do you'll kind of compete against Solidity compiler on its own sort of home ground. But yeah, that's just an idea, really. Right, so a little bit about the source tree. I've divided up into a parse directory. So the parsing stage is very straightforward. There's a LARP Solidity grammar, and that outputs the abstract syntax tree. So there's really just a grammar in there. That's all there is. So in source resolve, that's where all the hard work is. I have to resolve all the variables and generate the control flow graph. The control flow graph is not LLVM specific, but it's obviously tailored to make it easy to generate LLVM IR from that. Then in source emit, we take the control flow graph and we generate LLVM IR. So there's some busy work around generating phi nodes to make that work, but otherwise it's a fairly one-to-one mapping from the control flow graph. And there's the ABI encoder decoder. Then the final stage is the link stage. At the moment, it's just easier to convert a WASM object file into a final contract WASM, but that has to be replaced with the LLVM LTO linker if we are to link in other code. And then we have source ABI, where we generate the ABI file. And that's it. I should have included a link to the project, but I only just thought about it about 30 seconds ago. But it's a Hyperledger Labs Solang. That's it. Thank you.
Thank you so much, Sean. Okay, so questions. Sean's going to go into a meeting room, so if you have questions for him, then follow him over there. All right, next we have Alex talking about Sub0.1. Welcome, Alex.
Hello, people. I'm Alex from Ukraine, and I'm one of the first Polkadot ambassadors I'm founder of Polkadot Ukraine community. And also I develop on Substrate. I develop web UI for Substrate modules. And today I'm going to show you what we got while working on blockchain protocol for social networks and marketplaces. So our project is called Sub0.1, and you can check it out live by going to this link or this QR code. So you can open it, and then I will just run a video because it's already recorded, and I just recorded not to forget anything to mention. Okay, where is it? No, I don't have audio. I will. So. Oops. Yeah. Where is it? Yeah, I see. So with Sub0.1 you can create a profile for your account. The profile information is stored on IPFS, and the structure that includes seed, content ID of IPFS content, it's stored on a structure on a substrate. Profile is optional. You're not required to create a profile in order to have created a blog. So you can be pseudonymous, for example, like on a Bitcoin, or you can share some public information like links to your profile. So here we just created a blog. With this blog you can specify name, description, and avatar for your blog. Then you can write post to blog. Again, the similar information you need to provide, like post and description. Description could be in Markdown, so you can use formatting and include images by link. So far we don't support drag and drop of images, but in future we're going to support this one. After post is created, you're redirected to the post page, and on post page you can, it will be shown later, you can upload the post, downvote, you can comment on it, like here. So again, you can use Markdown to write comments to the post, and also it's like no-brainer that you need to, you can change your account, you can write from different accounts, other people can comment your post. It's an open system. So posts and comments could be upvoted or downvoted, and by upvoting and downvoting post comments, this increase or decrease the reputation of the author who wrote this post or comment. In this way, we have also reputation or sort of score for any entity that is a blog or post or comment in the system. And having this information, we can add some economics later on, like I don't know, incentivization based on the reputational score, or we can build different algorithms for newsfeed. And for example, if you want your newsfeed, obviously you need to go and follow the blog or profiles that you want, and they will appear here in the bottom left menu, side menu. So here we follow Web3 blog and Parity blog in this case. And here in feed you see the posts from the blogs or profiles that you follow. You can upload and vote straight from the newsfeed, like on Facebook. You can comment right here as well from this page. You can see how many reactions were to this post, a comment, and any other information. Everything is transparent. You can share a post by clicking share, of course, and adding optional comment, your opinion on this post. And if somebody is subscribed to your profile and you shared some posts, so it will go into the feed of that person that follows you. So also we have notifications. And per different account, different notifications. So notifications include something like somebody started to follow your blog, somebody started to follow you, somebody answered to your comments, somebody commented your post, upvoted, downvoted, and anything. And in feed, posts go in feed. So I guess that's it. And this was a demo, and now I will go into some details of what Sub0.1 is built of. Enter full screen. Okay, so we watched video. Again, you can go to this link. It's our first node with web UI. It's mobile friendly, so we can open from mobile. Don't worry. It's okay, that was video. Tech stack. The major components of Sub0.1 is obviously Substrate, and there we store only relations between structures, like what account created what blog, what posts related to some specific blog, what likes are in what posts, etc. And every structure, like blogs, posts, upvotes, comments, they have seed to IPFS. So by going by this seed, we can get in text information like title for blog, content of post, and so on. Next major component is IPFS. As I said, we store text information over here. And IPFS gives us replication, censorship resistance, you know all this. And then a couple interesting guys that are not so common while developing Substrate applications. It's Postgres. It's an open source database that everyone loves in the open source world. And with Postgres, we build newsfeed and notifications in offline. So there is Node.js applications that subscribes to events from Substrate, and on such events like create new blog, create new post, upvote, downvote, comment, edit, we create newsfeed and notifications for accounts that subscribe to this or that blog or profile. With Elasticsearch, we have full text search over the content, so it allows you to search for blogs and posts, comments, profiles, etc. Then Next.js. Next.js is a React framework, so you can reuse your React component on the backend and on frontend. And this gives you possibility to render server-side your blogs and posts, so it could be search engine indexed. And then also we use undesigned components, just a cool UI library created by Chinese guys. And by the way, you can follow our progress over here on Twitter, dubforce. Okay, so I just described Postgres, Elasticsearch. Yeah, one small note. First, maybe like 70% of our code base of UI we created inside of a fork of Polkadot.js subs, and then later we decided to move to Next.js plus undesign because we needed this server-side rendering, so we want the content to be indexed by Google and other search engines. So again, mobile-friendly. Everything is mobile-friendly. You can see that we have this mobile-friendly menu. It's collapsible here. Good rendering of notifications, blogs, and posts in a blog. You can check it by going to the link I shared with you. And also we are developer-friendly. So there is one script called start.sh. And by calling this script, you can launch everything from Sub0.1 repositories on your server. You just need to pass the IP address of your Elasticsearch and Postgres, Substrate, etc. So you can just go here or just go by this QR code and you will see it. So what is next? I talked to several people from Web2 Foundation, and I proposed them to create a decentralized Polkadot community on a Sub0.1. And for this, we discussed a lot of features, not a lot, but some interesting major features that we can add to Sub0.1, so it will become a good native community for Polkadot or any Substrate-based chain. So we already designed a couple of features, and the first interesting thing will be space. So right now we have a block, but we're going to have refactor blocks to spaces, and spaces will be of different types, like organization, project, personal profile. I think it's self-descriptive. Organization could have relation to projects, project could have relation to personal profile, and vice versa. So this is a design of organization space. Here you can see a custom organization menu, team members, and projects. Here is a bigger screenshot. We created this in a Figma using undesigned components. So one of the another components is team members. You can follow them here, for example. And also you can be able to create your customizable menu per your space. Maybe you want to have forum, maybe you don't. Maybe you want to have validators tab or not. It's up to you. And another thing, we're going to create different extensions to a post structure, and it could be a status like on Twitter, article on Medium, or a forum like discourse forums. And in future, we can add job positions and poll, and there could be a console application program, so where console members that is applying to be console, they can describe the program, and treasury proposal, anything. And this is a design of our forum. So forum will be built in the same structures that we use for posts. So this is a design for polls. And the bonus, we also created a multi-sig wallet for Substrate. Soon we will publish repository, and there is a SRML module for multi-sig and web UI that you can use inside of Polka.js apps. So follow us. And we are happy to talk to anybody who want to help, join, or run a community on Subsocial or inside of Subsocial. Just reach us. Thank you.
That was interesting. Do you want to, I think it would be great if you go back there. If anyone has any questions, they can come find you. Do you mind going to the meeting room? That would be cool.
All right, thank you, Alex. Next, we've got Mate to talk about vue-polkadot.js.org. Welcome.
Do you want to do it? Cool. Yeah. So then we unhear. Then. Where was the?
Okay.
Here's your thing. You want to refresh? So now we do this over here.
Oh, on the left. Yes, thank you. Now full screen.
And then I think if you want this, do you want to just check the clicker, make sure it's working? Yeah. If not, you can do it by.
Okay. I should just a bigger font. We will see. We'll make it. Okay, so hi, my name is Maciej, and today I will just tell you about our project, the vue-polka.js, what we done. So I'm Maciej coming from Bratislava. I found back in times the progress bar hackerspace, and we've been just working on this thing. And you're missing emojis, whatever. Okay, so agenda for this talk is like how we just started with this project, the proof of work, and working on the milestone 1, 2, and the challenges in debugging, and what's next and what we plan. So the last summer, I got the chance to do some research on the Substrate developer ecosystem, and I just started digging more and learn more what's like out there. So I just learned about the ink, which is like nice DZL, but have dragons included at that time. So thanks to Sean for the great help when I tried the Flipcoin demo. It was really fun. At that time, I learned more about the Substrate runtime modules. At that time, it was called the SRML, now pellets, now frames. And it was like great extension for your runtime. So I just, cool things. So like NPMs for that blockchains could be really nice. And then I learned about more the trust wormholes when I just thinking about the more interoperability between the other parachains. And I was just looking for that, wow.
and then I just learned more about the memory safety, but I think that Schemes Butter is included from the Rust and so on. So I would like also thanks by these slides, because I just promised them to Matti and Jacob from Progress Bar that I had this opportunity to be here, so they made it to the first slide, so thank you. So, okay, I've been interested more in the ecosystem, so I just started digging in the accounts and all the operations around. So I just started doing the creation, sign, verify, and all the generic stuff. So I just been inspired by the Edgeware community, and they've been just using the Sub0.1 CLI for generating accounts, which is like safest method to generate your private keys, not using this web thing. So I just made the thing, I started digging deeper in the React code, and I just found there is the Rust thing embedded through the WASM crypto to use in the browser. And I was thinking to use it through Vue, because at that time it was the language I just known. And I was like, okay, what about trying recreating it? And then I started digging, and then I just made this demo, which actually works. You can try yourself. And probably we can make the translation for the Asian market, so actually it'd be nice placeholder how you can use your sub key as well. So it was just a whole nice idea. So then I just started digging deeper and had idea what if we can make it more useful and more wider community. So I know the whole dashboard and Polka.js apps were just only in React, so we just get in chat with the Web3F, and we just submitted the grant, we just created domain and started the work, so let's deliver the things. Then we start reading the modules, what we are doing there. So we just set the repos, deployment pipeline, documentation, generating documentation from the code, and we started on the modules. But then we start digging deeper and find out that a lot of the code is actually quite unstable, and it was really the bleeding edge development, because if we just try something, next week it didn't work. So it was like funny. So at that time, we know that we already learned the part of the Rust implementation from the keyring. So actually the build few parts was quite easy, and that we actually were used from the sub-key what we learned there. And we started digging and reversing more code for the other modules as well, how actually do they work and how they interact with the parachains. And what was actually interesting part was the debugging in the unstable development and environment we know, and actually went for unstable things as well. So wasn't the fun, because sometimes when you load the WASM crypto for the Rust, actually didn't load as you'd expected, and some libraries were quite bigger than we missed some optimizations at the time, so we couldn't ship that so big code. So we started dig deeper and what could be actually there. So we find that there were actually some missing methods which could be like handy, and we would like to keep the same way as the React. So actually you get the same interface when you're building your UI app if you are choose React or Vue. So, but at Vue.js approach was different here. So sometimes libraries didn't work, and sometimes it was like etchy sketchy, so yeah. And okay, so, and sometimes even the Chrome DevTools didn't work for us, so first time occurred that the DevTools just crashed. So, yeah, so, and finally we made it, and keyring and all the identicons and settings just started working, so we just delivered our free package, and we went to the milestone 2. So on milestone 2, it was quite fun, because we started interacting with the Kusama, and we finally find out that the Kusama is pretty advancing faster than our team. So we had to constantly update the types, and sometimes it didn't work as expected. So we need to chase the Jako and his team, and they are very pretty fast in this. They never work like machines, so. So milestone 2, getting better here. Actually, there was other things. It was related to Kusama as well. So actually, we really don't know what is here. So it just didn't work, and that was it. So okay, and I think the last thing where we are right now, we are digging through the Explorer thing, and sometimes as you need to know what's actually our best peer block, you need to know to connect to as most of peers as you to determine what's like this newest block is in your neighborhood. So it was quite fun, and sometimes actually the DevTools froze again. So actually I think we are just missing some optimizations or really doing some hard we are missing some performance optimizations. I don't know. If you have any advice, just let me know. So that's regarding the Vue Polkadot development. And I just played my lightning talk for other pitch decks, what we are actually doing research for. And I would like to introduce you to our maybe parachain we don't know. And we'd like, during the Polkadot, we'd like to introduce another projects, and we can actually build our dreams. So we came up with the idea to leverage a substrate to something big. Our initial idea was to build the metadata parachain for Fireball network that hot rocks from the sky. And well, who would like pay for the data? It happens once in a while, sorry, I know. And the first ideation was to connect all the data silos from space agencies together. What could be harder, right? But the size, average size for cities like Bratislava is like 300 teras per month, which is really big. Then I find out that actually there is one team called that hello team, LGEM, that actually they're working on implementation of the DAT. And if I get it right, it should be something like Filecoin, right? So what we plan to do here, we would like to be like curated interface for all the space data for the Earth observations, because we know that a lot of institutions are making investments based on them. So actually we'd like create some sort of the marketplace where actually you have like evaluated data from this raw processed data or something like that. So we just came up with the ideation for the tokenomics. We are really new here, so if you can recommend somebody who can actually help us, it would be really nice. And we would like to propose some fee markets for data vendors, some continuous funding for the continuous organization or something like that. So we are really experimenting here. And I think very last slides is like what's actually our purpose. We would like to do something, let's say the discoverable metadata market, and for the machine learning, so actually you can pay your machine learning algos, fill up your wallets, and actually they can process your data, so actually you chip in the coins and get some useful data out of it. And actually our huge value proposition here is actually that we would like to have the traceability of all satellite data, because now normally the REST point doesn't offer that. And actually, what is our progress? We got picked by the ESA. We got the value from the world from space. We got the guys from who are doing the crowdsourced satellite network using the state channels for the Ethereum, the Hompor guys from Bulgaria. We got in Bratislava guys from SolarGiz who have bankable solar data, and the guys who are doing the climate reports. It's actually our first pilot partners. So, and very last slides, follow us somewhere on the Star Mesh. So we are still looking for the funding, and thank you for your attention. I have still 3 seconds. Thank you.
Thank you so much, Maciej. Next up, we've got Elaine talking about Encointer and Substrate T. Welcome, Elaine.
So, hello, it's a pleasure to talk here. Thanks for being here. I'll talk about 2 projects, my nighttime project being Encointer, my daytime project with my company Supercomputing Systems, which is Substrate. So, at first, Encointer, the nighttime idealistic project, is about implementing a global basic income. Now, the whole economy of it, as this is a developer conference, I won't cover. So it's more about like the technicalities of it. So I have the following assumptions. We want to have a non-permission blockchain, and we don't want to require any state-issued IDs. Only self-sovereign IDs. And now, if we are to give a basic income, we want to be sure that we give this income to humans only, and we also want to be sure that every human gets that income only once. Now, that is not very simple to solve. I came up with a process which is a little, takes a little effort from the participants. The idea is that all the participants who want to receive this basic income, they have to participate in meetups which happen all at the same time within a time zone all over the world in randomized meetup groups. And the idea is the following: you can only be in one place at one time. So if all these meetups happen at the same time in different places, you can only attend one of these meetups. So how does this look like? Before that key date, these ceremonies, they happen every 41 days. That's just an arbitrary number, but it shouldn't be too often because it will be cumbersome. So a little bit in advance, you register on-chain where, well, more or less where you are and how far you are willing to travel for the next meetup. So Alice, Bob, and Ferdy, they have their kind of tolerance region, and the intersection now is where they will meet, where they will have their meetup. And an algorithm will make sure that it's, well, first randomized, and that that the meetups don't happen like at a very close distance. Now, what we get with these meetups is not only a one-to-one ID. So, I mean, that's the first thing. Every human can get exactly one ID. But because we have these meetups, we actually have a proof of location as well. And that means that this basic income, which is actually delivered as money issuance, so we issue fresh cryptocurrency on behalf of the participants. So it's an inflationary model, but this basic income is actually tagged to the region where you participated. That means we can have local cryptocurrencies, and as far as I know, that's a novelty. And local currencies also means that they don't necessarily need to have the same exchange rate, of course. So on the right side, you see the now the more technical slide. You see what the first proof of concept can do. There is an Android app that allows you to register for the encounter ceremonies, and then you meet people with Android nearby. You discover the other participants, and you can just sign their claims, and then send all the claims to the blockchain. And the blockchain is substrate based. You register participants, the blockchain assigns the meetups, the blockchain verifies the meetups and issues fresh money as basic income. And the app is a Java app, Android app only right now. And the clue for rapid development was just to have a native Rust library which covers all the substrate specific stuff, so all the crypto primitives, extrinsics, and so on. And so we're using the Substrate API client, which is a Rust client, to talk with the RPC interface of a Substrate node. And yeah, more info is on Encounter. Now, a very important thing, especially for Encounter, is privacy. Because if you commit to be in a certain place at a certain time, that means, for example, if you are identifiable, that probably no celebrities will take place, will participate, because it's really dangerous for celebrities to commit to being in a certain place. With just random people, I guess. But also the transfer of money should be all private. And that's what brings us to the Daytime project, to the Web3 grant project, Substrate. That's with my team at Supercomputing Systems. We're doing this, and that's about trusted computing on Substrate blockchains. what we claim with this is a bit steep. we say we solved the three big challenges of blockchains today, which are confidentiality, how can we comply with GDPR, scalability, and interoperability. So Substrate is actually that technology. We use trusted execution environments for that, and that comes, of course, with a trade-off, because trusted execution environments require us to trust the manufacturer of that hardware. A first demo, which is a private token transaction, which I will explain later, can be found on GitHub. So it's all in Docker and very easy to try out, even if you don't have any T hardware at your disposal. So what's a T in the first place? We are very used to the fact that whoever has administrator privileges on a machine can do whatever he or she wants with that machine. And not only the administrator, but also all the malware which can get administrator privileges by some way. And the trusted execution environments are actually isolating a process completely from the operating system and the access through the administrator. So the admin cannot see the memory of the process. It cannot change the code of that process. And so the same applies to malware as well. Now, how do we apply this technology? We want to interface with any Substrate blockchains. So what we do is actually just a building block. It's more of a tool. We're not having a chain with a token and stuff. So that's for all of you to use. Where we register our trusted execution environment on chain, and from then on, people who interact with this can have confidentiality. You can instantiate runtime modules, paint palette modules, whatever. Not on chain, not in the runtime. You can instantiate exactly the same code that you wrote for Substrate in our off-chain worker. And I hope soon this will be possible for ink contracts as well. Now, why should we trust this off-chain worker? We have open source code running in this enclave, but I mean, who would believe me if I say that's exactly the code that I'm running on my server? So what we need is remote attestation by the manufacturer. And how this works is the code that is run on the T, the T can be challenged by the manufacturer in such a way that the manufacturer can attest to the users that A, it's a genuine hardware, and B, that the code which is running on that hardware the binary has the hash XYZ. So if you can build the source code deterministically, you can actually be sure you can compare the hashes of the remote attestation and your build. And this remote attestation is actually sent to the chain. The chain can verify that this attestation and will only accept workers with correct attestations. Right now we use it with indirect invocation, so the Substrate chain is not only a register for workers, it's also a proxy for requests. And how this works is, let's say Alice wants to send tokens to Bob, private tokens, which are managed in a state in our world. So bear in mind, the state of the chain has nothing to do with the state in our trusted world. They're completely isolated. So Alice encrypts her call with the enclave's shielding key, such that when the extrinsic hits the blockchain, which is public, the actual payload is opaque, so no one sees what's in there. So then this is forwarded by means of an event. So we listen just over on the RPC interface, we listen to events, and we forward, we decrypt the request. We send it to the state transition function, and in the case of this demo, the state transition function is nothing more than just the balances module from Substrate. And then you can have your transfer, whatever. This works on a state which is encrypted, and the encryption key of that state is shared among a redundant set of workers. And the state is shared over IPFS. And the next thing that we want to do, so that's not yet implemented, is trustless chain state read. So as I said before, the state is completely isolated, but some use cases require that we can read on-chain state, and that's what we would like to do. So actually what we're doing is we take the Substrate Lite client, we put it in our enclave, and it will be able to verify proofs, read proofs, and kind of proof of inclusion, and so on. And now, so far we were talking about confidentiality, but scalability is the next goal, a bit further away. So we can use Substrate actually as a second layer protocol. We can, as a requester, talk directly to the off-chain workers and not have on-chain transactions for every request that we have. So we could process thousands of transactions and only write the Merkle root to the blockchain as a confirmation that all these requests have been processed. Okay, so where are we now? We have up to M4 was the grant with Web 3. M5 is what we continued on our own with, and M6 is kind of the next thing that we want to do, which is the Lite client functionality. All right, that was it. If you have any questions, please, if we have time.
I have maybe one question. I didn't understand how you want to make sure that if I attend one time one meeting, that the same person do not attend next time a different meeting.
Okay. Actually, I don't care which persons or who actually attends with what ID, because I just care about it being a human. And if you want to have a consistent one-to-one ID, then you have to link just your participations of maybe the last 5 ceremonies. And if you have attended more than half of the ceremonies, then you kind of prove that you only maintain one ID. Because if you attend 50% of the ceremonies, then it could be that you actually attend 100%, but like you alternate two identities at the different occasions, which would actually give you 2 IDs. So this kind of allows us to have a trust rating on the ID. If you have the majority of the attendance, then you can be sure that this person only maintains one ID.
My question is a bit off topic. You mentioned Substrate API client, and I'm curious, how would you compare it with SubXT? SubXT is a bit changed last time.
I'm aware of SubXT, but we were not aware at the time because it was written more or less at the same time. How I would compare it is our Substrate API client is it's synchronous, and it allows you to to compose extrinsics even in no standard environments. So that was important for us to use it with SGX, because SGX is also a no standard environment, and we needed to compose and sign the extrinsic within the enclave, because that's where the private key resides. Does that, I mean,
Yeah, yes, that's useful. And does it up to date with Substrate 2.0?
It does work with, well, let me see. I think it works with a commit which is 1 or 2 weeks old. So we do not stay up to date the whole time. We kind of, and I mean, this might be a recommendation for some of you, as this is really a moving target. It really makes sense to like commit, pick one commit, work with this, and update only if you have any problem with with the state that you're working with.
Well, 2 weeks ago is okay.
It's not exactly continuous integration at its purest, but it saved us some work.
Yes, thanks.
Any other questions?
I'm actually, with Encounter, I'm kind of hiring, but I'm not paying. So it's a not-for-profit project. So approach me if you want to do like altruistic work.
Awesome. Thank you so much, Elaine. All right, we are now onto a coffee break. At 4 p.m. In this room, Gav will give his keynote. And then at 5 p.m. will be our AMA with Gav and Frederick. If you'd like to submit a question, go to sly.do and enter code Sub0.1. And again, we've got Substrate devs back around here, so you can just drop in if you have any questions or if you want to talk about any issue you're having. All right, enjoy coffee.
you'll have to ignore the slightly bunged up sound of my voice and the sniffling. I have a bit of a cold. Yeah, it wasn't really meant to be the keynote per se, but rather hopefully an enlightening talk on what we are aiming towards in terms of the developer API with our cross-chain message passing stuff. Point of note, it used to be called ICMP, interchain message passing, but there was a little bit of a name collision, so it has since been renamed. It's now cross-chain message passing. Cool. I'm not going to focus too much on the implementation of this. It's pretty complicated. There will be ample documentation on that if and when you want to look at it. But I'm going to focus mostly on the design and particularly like the sort of high-level API, well, and how it's built. So first, like the model that we're working with. We've called it, like, since the very start of the Polkadot project, it was called this kind of parachain thing. So, you know, it was really about like trying to get people to understand that the fundamental point of abstraction that Polkadot provides for people is one of like blockchain's runtime logic. So that's a little different to the point of abstraction for platforms like Ethereum, where it's really the smart contract. So it's small snippets of logic that can join a very large kind of environment. And talk to each other sort of synchronously. Parachains are different. They're much bigger. They're much sort of weightier, and they can talk to each other only asynchronously. Nonetheless, it's important to understand the difference between what we wanted to achieve with the name parachains and blockchains in general, and in particular the difference between the bridge model and the sort of shared security model. The bridge model is one where each individual chain looks after its own security. Messages can be passed between them, but the messages are largely meaningless unless you trust the security apparatus, the validator apparatus, the amount of stake behind those validators, so the economic guarantees provided to you by them, of where the message is coming from. If you don't trust that, then the message may as well be garbage. And therefore, bridge-based solutions are fundamentally trust-bound. Now, when an Ethereum contract talks to another Ethereum smart contract, it's not trust-bound, right? It's trust-free, it's trustless. Because the same validation logic that talks to one, that defines the transition of one smart contract defines the transition of the other, right? It's the same economic guarantees that you get for one being correct as for the other being correct. And indeed, for the synchronous call to be passed and executed faithfully. So everything is guaranteed by the same underlying security umbrella, and that's why it's useful, that's why it's good. Polkadot provides that very same guarantee to all of its underlying parachains. So in many respects, it's more sensible, it's more poignant to call it a sharded solution because the parachains are all sort of executing in parallel. In that regard, it's like a heterogeneous sharded solution. And probably going forward, to try and remind people of this, we will be using more the sort of terminology of sharding than the terminology of multiple chains, because ultimately it's a really fundamental difference in how these systems operate. The final point is the important one, deterministic message passing. So basically you get certain guarantees about when you send a message from one parachain, when it will arrive and what it will do potentially in another parachain. But in particular, the messages will arrive exactly once and in order compared with each other. And yeah, there'll be a sort of definite period of time that it takes, although it could take very long depending on how often the destination parachain or parathread is scheduled. So there are three directions that messages can go within the Polkadot model. And therefore, for any parachain built with Substrate, there are sort of three kind of APIs that you need to know. Up, down, and the more interesting one, sideways. So up is relatively easy. There's like order n possible endpoint combinations. Basically, it's just all of the different parachains. They can each send a message up to the relay chain. Same with down. If the relay chain ever wants to send a message to a parachain, it's not too difficult to arrange. Now, these are already in the current sort of Polkadot code base. These are already implemented. The hard one is the lateral one, right? Because suddenly you've got all of these possible different endpoint combinations. Now, in the original Polkadot model, where it was all just parachains and all the parachains were always scheduled all the time, n here was maybe 100. But in the new Polkadot model, where we have parathreads as well, yeah, and parathreads take sort of share part of the scheduling space, the n has sort of grown quite a lot. Now it's like maybe 10,000. So that's really quite a lot of endpoint combinations. So yeah, talk a little bit more about the parathread model. I don't know how many people are super familiar with it, but basically the idea is that you've got a bunch of different parachains that can be scheduled each block. Let's say maybe there's space for 100 different parachains. This is, there's a few factors that lead to this upper limit. One of the factors is just the sheer number of validators. So maybe you've got 1,000 validators and you want 10 validators that are scheduled to validate a single parachain. Then that limits you to 100 parachains. Now, if you can scale it up to 10,000 validators, maybe you can now get 1,000 parachains per block. One or two of the other things, like maybe availability, so guaranteeing that the data that all the parachains need to be around as they sort of continue onwards, it may be difficult to arrange for all of that data to be continuously available. So there are one or two kind of things that do limit this amount, but potentially it could go higher than 100. We'll just have to see. Now, parachains, there are sort of two notions, two rough sort of families of parachains that we're going to see. We'll see leased parachain slots and also kind of permanent parachain slots as well. These are the things that just sort of get deployed and they stick around in their slot every block for some long period of time, maybe 6 months, maybe 2 years, maybe indefinitely, we don't know. But as you can see in this lovely little diagram I did, pink, purple, and blue are a sort of leased parachain, and they just hog their slot. They stick in their slot and they just continue getting scheduled in their slot as time goes on. Now, parathreads are scheduled dynamically, so they're the things that can be swapped in and out. And there's a few different colors of parathreads, the pastels there at the bottom, and they're getting, as you can see, scheduled dynamically once in every block. Realistically, I think these are not crazy numbers to aim for. So maybe 50 leased and permanent parachains, and maybe 50 that are just sort of parathreads being swapped in and out every block. And as I said, up to 10,000 on version 1. So 100 million possible endpoint combinations. Actually, it's 200 million because you've got both directions. Yeah. So A can send to B, but also B can send back to A. So yeah, if we look at the requirements for XCMP, they're fairly harsh. 10,000 endpoints. Maybe 100 of those are going to be sending or receiving in any given block. We need hard delivery guarantees. And also we've got this irregular servicing, so it's like different, some threads may be serviced only once a day, and then what do you do? Like, if everything else is sending to it, you've got to make sure that the queue doesn't just build up endlessly. Oh no. So XCMP has a bunch of important sort of design decisions. Firstly, it's connection oriented, which means you can't just go spamming messages to like 10,000 different chains. Yeah, you have to choose which chains you're going to want to talk to, and you have to. There's economic impetus to keep this relatively low. One of the pieces of economic incentive is by placing a deposit down. So you have to put a deposit down in order to actually make a connection. You get the deposit back once you've closed it, but it will cost you basically. Crucially, the relay chain is not used. It's not a point of throughput for these messages. It's not even a point of throughput for hashes of the messages. It's not even a point of throughput for like chains of heads of chains of hashes of messages. It's substantially indirectly linked to any of this messaging. It's only used basically to check whether, or to provide a top-level proof, a top-level Merkle root, in order to provide eventually proofs to the parachains that a message was posted at some previous time, or that essentially it must have been received at some previous, or delivered at some previous time. So it's used really just to record very, very, very indirect high-level information, and it's not the sort of thing that's going to sort of cause it to become a bottleneck for the sorts of numbers that we're talking about. And as I said, proofs are used based upon this information that's stored on the relay chain in order to push all the work that needs to be done out to the edges, out to the parachains, and particularly makes collators' lives quite difficult in order to do this, because they have to sort of go off to various different points in the system, collect lots of information, and create these proofs in order to prove to their own validators, and particularly the relay chain validators, that when they're delivering messages, that these messages were indeed sent. So yeah, the channels in XCMP, so this connection-oriented design, each channel is, firstly, it's like simplex, so it's just unidirectional. There's a from and a to. The to can't send back to the from. And it's here in order to bound the total endpoint combinations to well below 100 million. The other point of doing channels, of doing this connection-oriented design, is that the receiver needs to have control over who can send the messages. Very important. So broadly speaking, let's go into the stack. We've got a sort of four layers of kind of API. At the bottom is the thing that's the only real sort of proper thing that's done on chain. And that's the relay chain messaging. So that's the ability for parachains to send messages up to the relay chain. And there's, as I say, there's already a sort of API in place to do that. There's also a sort of means of getting information from the relay chain down into the parachain. It's basically just done with inherent data. If you're familiar with that, you probably have heard of it if you've been here for the full conference. And it's checked by the relay chain validators, or the parachain validators that also happen to be the relay chain validators. Built on top of this are the basic sort of XCMP building blocks. So the APIs that you're able to use by conversing up to the relay chain. And then built on top of that is the sort of end user, that would be kind of you guys, queued XCMP, the lower level of the two sort of end user APIs. And then there's also dispatched XCMP, which I'll talk briefly about, which is the sort of do nothing, super easy variant that is quite opinionated, and but may well be useful for some people. Yeah, so as I say, the thing at the bottom is the foundation of all of this stuff, so it's worth sort of understanding what is provided. Essentially, it provides this message path from the parachain back up to the relay chain. So you've got this post message thing. I need to change this. So that dest para ID shouldn't be there. It's really just post message, data, and then the data will arrive at the relay chain. Actually, the data, although it's just an opaque blob, you know how to encode it because it just needs to be a call that the relay chain can interpret and enact. So you're familiar with like calls or proposals, these kind of serializable function objects that can get dispatched via the runtime. That's just one of those, but it's encoded. And similarly, you can get these blobs of messages back out. There'll be an API for that. At the moment, it's really just inherent data that you have to read directly, but we'll put an API in for that in the not too distant future. The messages that you send to the relay chain go into a FIFO. The FIFO is serviced, and yeah, it's that simple, really. There's super strict capacity limits. Basically, it's quite low. You can sort of send up to, I don't know, something like 16 messages per block. And you can only send up to, I don't know, like a megabyte or something of data. So it's, yeah, it's pretty small. Yeah, I've gone over this really. So the parachain has to figure out how to talk to the relay chain, but as I said, the relay chain essentially isn't going to change, so it's not too difficult to figure that out. So given that we've got this like base conduit to go up and down to the relay chain, how do we sort of, how are we going to build on that to make XCMP? Now this is really the job of Cumulus and parts of the bits of the relay chain, sort of part of the bit of the Polkadot client code and some of the runtime code. That's where this logic sits primarily, and it's this logic with which we will build the real user API. So the first thing is channel setup. There's an API for this, and it's done in terms of basically just relay chain, a relay chain runtime module, right? Relay chain palette. There'll be a dot deposit to set it up. We're going to assume for now that the messages are coming from parachain origins. Yeah, so there's already part of the thing that we delivered with the relay chain messaging. There is this notion of being able to send or have a message, have a call be enacted on the relay chain from a particular origin. The origin, you can choose whether it's an account origin, account ID, one specific to your parachain, or a special parachain origin, and these will probably work with the special parachain origin. Okay, so there's, as I say, there's a bunch of kind of TCP/IP looking functions that you can call on the relay chain from a parachain. Connect, accept. There's the interesting one is accept because it's got this max pending count. Max pending count is basically the queue size. It's how many messages, or specifically batched messages, so kind of blocks worth of messages, that can be not yet delivered before the channel becomes full. This is sort of to mitigate the possibility of a channel, sort of a particular chain being spammed just by, you know, it being sent tons and tons of messages, and it would be very difficult for it to get through them potentially to some important messages that came a bit later. So where were we? Yeah, they would require dot deposits. So for these to be called on the relay chain effectively, you'd have to, the parachain itself would have to have dots within its account, or Kusamas if it's on Kusama. Yeah, I think that's probably it. So the connect and accept, it's like one, the sender would attempt to connect, and then at some point later, the receiver would check to see what the incoming things are, and if it's got any incoming things, it would see if it wants to accept messages from them, and if it does, then it would accept that para ID. And it could also sort of disconnect or whatever from the para ID if it didn't want to. Now, we get onto some of the more kind of interesting elements. So actual message passing. So within, for any given channel, at most one, at this abstraction layer, one message may be sent per block. at this abstraction layer. Now, at the next abstraction layer, you can send many messages per block. So I've decided to call it this abstraction layer, they're just called batches of messages, or message batch, right? So one batched message may be posted per block. And you can think of it literally as that, just all of the messages that this particular parachain is sending into this channel at this block are just going to get glued together into a big vec, and that's and it's all serialized anyway, so it's just going to be a big opaque blob, and we call that the message at this point, but actually it's the batch of all these messages. Now, at most one can be posted out. I say posted rather than sent because I just want to get across the fact that it's asynchronous. It's like really asynchronous. And we also may have some that are already pending in delivery. They're still waiting to be delivered. If there are, then it would limit the amount that can be sent, potentially down from 1 to none. The API is relatively simple, but as I say, you can only send at most one message per block. So rather than it being a kind of post message API, it's really just a set message. So if you don't want to send any messages, then don't call it. And if you do, then you call it exactly once. And it's just where the message is meant to be posted to, and this batch of messages, which is actually just a big opaque blob. And if there are too many pending messages, then you're going to get an error back. Or for that matter, if the destination, if there's no channel open to that destination. Now, in terms of getting messages in, at this abstraction level, it will be a push model. So messages are going to come in when they come in, and it's up to you, the Substrate parachain, to know what to do with them, to handle the fact that messages are coming in. At this one, it's going to be just basically a function that you call to see if there's, you call it once a block to see what messages are coming in this block. If you don't call it for whatever reason, then the messages are just going to get ignored. As far as the system is concerned, they've been delivered, and it's up to you to make sure you actually service it. At the back end, it's actually just an inherent data. So it's coming in from the relay chain. It's going to deliver these messages into your parachain. Your parachain is going to be checked to make sure it's delivering the right messages. And you end up with this kind of, this vector of this bunch of messages coming from various places, various para IDs, various parachains. And you also get the block number that they were sent out. Presumably, you're not going to always be able to act on all of these messages immediately, and therefore you're going to want to have code that like buffers and potentially persistently, and also enacts them, like does some action based upon their contents at some point. Now that's going to be handled in the next two things, but at this sort of quite low level layer, that's what needs to be done. So, right, now, we're to the top two bits of API. These are the bits that, people will actually use. So if you're interested in talking to other parachains from your Substrate chain, this is the important bit. Now is the time to wake up. Okay. So the first point to make about queued cross-chain message passing is that there isn't a data format. We're talking about sending blobs of data between parachains or parathreads. Entirely arbitrary. So it's up to us, the Polkadot community, to work out what these formats should be. Now, as you'll see in the dispatched XCMP, there's one suggestion for what the message format could be. But at this point, it could be anything. Like at this layer in the stack, it could be anything. And it could be different depending on what the channel is. So it might be that you've got a channel between parachain A and B, and they're expecting, message format foo, and in the parachain, in the channel that's connecting A and C, they're expecting some entirely different message format bar. It's entirely up to the parachains or parathreads in question to work out what language they're going to use to talk to each other. But I do expect there to become message formats fairly quickly, and I do expect, I think it's at least possible that we will see message formats even starting to sort of work outside of the purely Polkadot ecosystem. We might see some other cross-chain standards arising, but we'll see. So what will it look like? Well, the first thing is that channels will be handled a little bit more. So this is, just to give you some idea of where this code sits, this particular code will be in the Cumulus code base. It will be, there'll be a couple of palettes probably that you can sort of bring in order to, kind of XCMP palettes in order to be able to send messages. So there's one of the things that will be in these, one of the pieces of logic in these palettes will be this channel tracking logic. So you've got, we had the sort of TCP/IP style API from before that sat on the relay chain. Well, in addition to that, there will be this kind of slightly nicer API that will essentially prevent the possibility of you accidentally sending to a parrot ID that isn't actually a channel. So you've got this lovely kind of try-from interface to turn a parrot ID into a channel. So you can get a channel value from a parrot ID value or get an error. And then once you have this channel value, then you're guaranteed you can definitely send to it. The channels is also something that you can call in order to get all the channels that you currently have open. So you can also just, if you want to do a multicast, you can just send to all of them just by iterating on this vector. There's this post message API, so it gets given a channel, and you also put a message in. And the idea is that it's infallible. So all of the checking that's done to make sure you can send a message, to post a message, is already done as part of the creation of these types or creating values of these types. Once you have the values of these types, then you're guaranteed to be able to send. Message would be, you know, a try into from, oh no. Do we have power? Okay, I have power. For some reason, I think my machine's compiling something. I'm not really sure what. Okay. Yeah, so the idea is you can give it this sort of blob, this vec of U8, and as long as it's the right size, then it'll give you this message back. But the messages, as I said, are still very much opaque. It's up to the parachains, up to the code and the parachain to work out what format these messages are in. In terms of receiving messages, we've now moved from a push model to a pull model. Basically, all that means is that the code inside this palette that you're going to be using will look after all of the sort of pain in the ass buffering and queuing and all that sort of stuff. All you need to do is you get this, like, maybe an iterator, maybe just the function next message, but you call this next message and it gives you the message, right? Or none if there's no messages to get that need to be serviced. And then it's like basically up to the parachain, parathread, in order to make sure that next message is called enough just to keep the thing moving. In principle, you know, some of these things are going to require action. You know, they'll require some form of some logic to be conducted. Maybe it's like a, I don't know, transfer fund message, in which case you're going to have to like access storage, reduce a balance or add a balance or whatever it is. So it's up to the chain to work out how much work is being done and make sure that the work that's being done in servicing the messages isn't going to lead it to creating like oversized blocks. So that's part of the responsibilities at this level. But at least you're guaranteed that all of the messages will be queued and they'll be ready waiting for you in this like next message call. You don't have to worry about sort of having to service inherent data or anything like that. And you also get, as part of the delivered message, you get when it was delivered. So you can work out, I don't know, it might be useful to you. You can work out on the chain how long it took from when it was sent to when it arrived. At this level, messages, as I mentioned, are smaller. They're like the individual things that you would most likely call messages rather than these things that are all glued together such that you could only have one of them per block. So it looks after all of the splitting them up and gluing them together at this point in the API. Okay, so that's the main sort of cross-chain message passing XCMP API. That's how it looks. There's a sort of layer on top, dispatched XCMP. This is, I just want to give you sort of a vague idea about the sort of thing that I sort of might be doing in order to, or we might be doing in order to make it a bit easier. With this API, the channels remain the same, but the main thing is that the message format is fixed. It's fixed according to what basically looks like an unsigned transaction. So you're familiar with how transactions are encoded. You've got these like calls, right? These kind of function objects that can be serialized. And there's an idea that when you execute them, you're going to sort of add to the current weight tally of the block. So this prevents you from creating oversized blocks that take forever to execute, a little bit like gas. It basically handles all of that. It does all of that stuff. It also does fees and it does everything. So it's very, very similar to transactions. The only difference is that rather than being signed and being floating around in a transaction queue and eventually heaved into a block, they come from other parachains and their origin is guaranteed by the relay chain validators, not by any particular signature. So in terms of receiving these things, it's already done because you can already receive transactions, yeah? There's all the apparatus, all the logic there in your substrate chain to process transactions and manage things like weights and do stuff like fee deduction. So actually it's sorted, like it will just piggyback on that. Sending is a bit harder, right? Because there's no logic on the chain at the moment that creates, well, there is actually, but it's a little different, that creates transactions. The logic that is on the chain that does this works because it knows the chain that's creating the transactions or the sort of environment in which the transactions are being created is the same environment that they're going to be interpreted. It's the off-chain worker stuff if you're not familiar with it. But in XCMP, they're different, right? The chain that's creating these transactions, the chain that's sending or posting these messages is going to be different to the one that's interpreting it. It's going to have different modules. They're going to be sort of composed in different ways, parameterized in different ways. So there needs to be some way that you can you can sort of encode what it is that you want to do, encode your message, encode your instruction, your sort of transaction-like thing, from one chain and sort of make sure that it gets is comprehensible and is going to do the right thing in the destination chain. And it's not particularly easy, but roughly speaking, it will probably look a little bit like this, where you're going to use some palette that you know that the destination chain is using or is going to be composed with. Then you just create some sort of call using the palette's call enum. Encode it, and then there's got to be some addressing, right? That's what this sort of balances thing is. You need to know what the palette, how it's instantiated, and what the name of the instantiation will be so that it can eventually get dispatched properly on the other side. And that's the difficult bit. It's also a little bit stringly typed, but, you know, hey-ho, there's not much that you can do about that at this stage. Cool. That's the end of the talk. I hope you go away a little bit more enlightened than when you came in. And I think now, in case you're not, you can ask questions. Cool. Thanks. Oh, it's after. Okay. After this.
So we've got the AMA. So ask your questions on sly.do. The keyword is Sub0.1. And all right. Thank you so much, Gav. Next up, we have core developer Ben talking about Behold, the future is upon us. And I'm wondering, is this going to be about times passing? Is this going to be maybe about Substrate's future? Not quite sure.
Should I answer that question? Well, first, congratulations to everyone. You made it. Last talk. Where's my mouse? There it is. Is that working? There we go. So last official talk, I want to take a quick recap of the things we've seen and learned. Does that work? Yay, okay. I want to give a few mentions to things that you haven't seen but you should be aware of, at least in my opinion. I'm also not going to be able to give you all of that, obviously, but I'm going to show you that. And this is broken, wait a second. And then I want to take a short sidestep, think about where we are and where we're going to go from here. So one of the things we have seen, a few things that we've seen are the Cumulus way of building parachains. If you have been to that workshop, we have seen the smart contracts. This way. We've seen how to do smart contracts in the future using WASM, and we have seen how off-chain workers work. Have we? This is doing something else on this. This is confusing. Yeah, it's confusing. I'm gonna go for this non-clicker version. Wait, what the hell is going on? Let me refresh that. I don't know what's going on. It's weird. Great, TSL handshakes. Yay. Sorry about that. Nah, it looks good. Still doesn't do it what I wanted to do. Sorry about that. So now it seems to be in sync. And it's not loading pictures. Awesome. Look at it. Let's see how this works now. And we've seen off-chain workers and how they work. As mentioned before, I want to give also an honorable mention to other things you might have or might have not seen. You probably haven't seen here, but you should have some knowledge about. So the worst of this Substrate dev, Fred mentioned that in the very first talk, has been given a huge overhaul already and is a lot better. It's the starting point to do anything Substrate. But it's going to get another overhaul very soon, where we're going to go into much more background information. I want to give a shout out here to Sean, who you have seen in giving a talk and a workshop as well, and the entire DevX team who've been doing this great resource for all of us. Then you might have been aware that we have been participating in Hacktoberfest again, and we've done it a little differently this time than compared to what we did in the years before. We took that opportunity to get our act together and make it easier to contribute to Substrate itself. With this very fast pace, it was always, thanks for the mention. You can't see the pictures, it's annoying. Let's see if it works now. I don't know, it used to work just fine. There we go, the picture's there. I think it was because I restarted it. But I want to show you this one first. So there we go, nice. So we had Oktoberfest, coming back to my flow. And we've done that a little differently this time. We have taken that opportunity to get our act together, to clean up Substrate, to get a lot more issues in that have mentoring tags that are clearly described so that people can actually contribute to it. But we also took the opportunity to document a lot more ideas that we have that are floating around the company of things you could potentially already build with Substrate that we generally don't have the time to do or want to do in the soon or later future. And this is still open. Like if you go to Substrate Developer Hub, Oktoberfest, you can still find that. And I really recommend that you look at that if you're interested in building something on or with Substrate that we consider a really good experiment or useful. And there's people tagged in there that will help you do this. Another effort in the entire outreach and helping developers is also the Substrate seminars that Yoshi is giving every Tuesday now at 2 p.m. UTC. This is a Zoom call, weekly Zoom call, where they dive into some topic. You can suggest topics if you want, and it's everything from code walkthrough to discussing it to Q&A, anything. If you have questions, if you're stuck with something, I really recommend just jumping into the call, chatting with the other people, and getting Yoshi or other people to help you. So shout out to Yoshi for that. Another effort that has been going on and has not been noticed here yet is the Relay Chain blog podcast we're doing. You still have time to catch up. It's a 45-minute, roughly once bi-weekly release cycle. Roughly, there's at least one recording around here happening at the moment, but it's 9 episodes in, so you can still catch up, which is just a blockchain about anything around Substrate and Polkadot. It goes into depth with interviews, but also just sheds light on different things. Shout out to Joe and Nicole. But also in the wider ecosystem, not only we are doing stuff, we've mentioned before Substrate is an ecosystem by now. One of the things that I would like to mention is the Rust and Blockchain newsletter that has been started, that we are perfect for, obviously. But there's also other projects and other things being mentioned there. And we learn about other things that happen also through this and other means, like the Substrate Marketplace, which is already online. The blog Unison people were like, we want a searchable index of frame palettes, formerly SRML modules. And you can already submit yours. So if you have external modules and you want them to be discoverable, go to substratemarketplace.com. And take a look at that. But then also code-wise, a lot has happened, and not all of that got mentioned here. Not only between Sub0.0 and now, but also in general, also around that time already. So there's BAPE, the new slot-based block authoring mechanism. There's a new way for you to define, if there are multiple forks, which one should be picked. It used to be just longest chain. You can now define that yourself, which is a select chain mechanism. We have a proof of work proving that pluggable consensus actually works. You can build your own consensus mechanism and use that. We have transaction weights, which is similar to gas, but quite different overall. Way of transaction payment management. We have signed extensions in the header information for you. We have made a lot of effort to get the random coin flip a lot more secure and random inside them. Another module that we even have a blog post about, but I don't think gets a lot of attention at the moment, is the EVM, which allows you to plug in and run Solidity contracts, which we have been asked about for forever. When are you going to do that? Then we launched it, and it was quiet. Weird. The peer set manager is a new economical model of how to manage peer networking overall. And child trees have been improved a lot, allowing you today to effectively plug in your own trie mechanism, as long as it creates a proper Merkle root in the end, to be used inside the runtime. And you don't have to care that a consensus might need to know about this particular Merkle tree, because it doesn't, because it gets plugged in the regular consensus. So it allows you to do a lot more easy changes. And you notice here I could go on and on this, but there's one elephant in the room that needs addressing. the repo rename. It has been mentioned here a few times as well, and I'd like to shed some light on what happened there, why it happened, and what's going on in general. So, for those who are not aware of it yet, lucky you, you're not a master, we've basically tried to split up the entire repository into three main parts. The client, which is everything that is the outer node infrastructure. If you're aware with the overall architecture diagram we often draw, this should feel familiar. Then we have frame, which is our inner chain functionality, and then we have the primitives, which is the interface layer between the two, effectively. And in there, I want to get some terms right. So if you think of that as we have this one thing that is the outer system that goes like networking, consensus, management, and that kind of stuff, which is inside the client, which is all now going to be prefixed with the SC in terms of crates. Then we have this fuzzy layer in between that the client is implementing these primitives. And these primitives are implemented from the other side using frame. I'm saying using frame here because frame is our current opinionated idea of what a chain runtime should look like. One of the reasons that we switched away from the terminology SRML is that pretending that this is the only possible Substrate runtime module library is not correct. We did this change preemptively, but also retrospectively. We know of consortium chains that run a Substrate using the client and the primitives, and they use nothing of what used to be the SRML to run a runtime. You could build any other runtime that implements the primitives, completely without using anything of the framework that you have. You can build a completely monolithic chain if you like. And inside this frame, we have a bunch of crates that are the basic that you need to have in order to run frame, which is support, system, utilities, and execution. And then we have a lot of other optional crates, which in reference to this crate idea we call pallets. And I'm very sorry for the pallets in between. We heard this is why we renamed it again, which caused more trouble for some. But I hope you understand now that it's good in the long run. It's painful now, I know, but it's useful in the long run. And one of the things why we did this and also cleaned this up and cleaned up our act on this is because we want them to be more independent. What we were able to do this and prove through this is that you can now, and you've seen one case earlier with the OSCoin people, what they did. They have a runtime that in the old style still uses some client stuff, but you can build this runtime and use that runtime and run it in something else that implements primitives. It doesn't actually have to be a Substrate client anymore. They are implementing it inside a test harness. And that works vice versa. So you can run frame on other systems than the Substrate client, but you can also use a Substrate client to run other systems than frame. And we hope this makes it also easier for more experimentation. One of the key reasons we did this was to be able to release it. You have been asking for it, and we have been talking about it a lot. We want to publish 2.0 on crates. This is the thing we want to do, right? One of the reasons we couldn't do that on 1.0 is we still have one GitHub dependency in there, and you cannot publish that on crates. The other thing was that because of the way that we allowed this structure to just play around by itself, we had circular dependencies, which you can also not publish. That is gone. With this model, we are enforcing strictly that client is not depending on frame, and frame is not depending on client. And primitives are not depending on either of them either. And that means we can also release them independently now, which is very, very exciting, because it allows for a more fluid release process. With publishing 2.0 on crates, we're also going to adhere to semantic versioning. Yay! That said, there's at least a few crates we already know are not going to be 2.0 in that sense, because we're not going to release them as 2.0. Namely, stuff around networking and consensus. That will be 0, 8, 9, we have to still discuss this. But we want to make clear that we believe they will change. And we will use them, and some other 2.0 crates will depend on them. but we potentially change them significantly in the future because we just want to see them actually in practice. For almost any other things, we release them as at least 2.0, and from that point on, your build is not going to break anymore, if we do this right. I really hope we do this right, because we have a release manager now that is going to help us do this, who's already been doing the Kusama release management, and we are learning on the go. One of the things that we also agreed on doing is record changes you have to do in an upgrade, txt, dog, whatever, adog, md, that we're also going to keep up to date on master. So if you want to continue working on master, and it doesn't work anymore, the first thing you should do is look at that document and see the very first line. Have you applied what is said there yet? No, try that. And that will also make it possible to do minor and later major upgrades, hopefully a lot more seamlessly. This is a requirement for any breaking API change PR from 2.0 onwards. So we're not going to accept a PR unless they do document how you, as a user of this, will upgrade. And that brings me to the obvious question, does that mean it's stable? Well, it's complicated. As I showed you before, in the term of a blockchain that we release a blockchain framework for, what exactly do you mean by stable? Do you mean stable in terms of the API that you built on? Yeah, we adhere to Semver, so Cargo is going to figure out the best dependency tree for you. And we will make sure that this is kind of the case that you can run with. But that doesn't necessarily mean that there's other changes that might happen that require other upgrades. We have these 3 base object components now that can be released independently. We have the question of, if we change certain stuff that is not actually changing your API, but changes the data structure underneath, we would potentially fork off an existing chain. That's not necessarily stable, though Semver-wise, it's still stable. So these kind of questions are stuff we haven't figured out yet. We don't even have the entire wording for it to figure out what we want to do. So I'm trying to get away around this question to the actual question you are asking, and that is, should we build on it? And that is a surrounding yes from my side. So first of all, we're building on it. We're building Kusama on 2.0. And we have no intention of breaking Kusama. So also all of these things that I talked about just now, we will have to figure them out eventually. We don't yet know. This is what I can tell you. But with 2.0 and not sticking on master, you do get all the yada yada that I was just talking about, like Semver, stability. And overall, we are building Kusama on it because we know you can build something like Kusama on it. 1.0 was a great release to show that you can do live upgrades on a testnet, but honestly, most people switched to master because they wanted off-chain workers. They wanted a lot of other features that were simply not in it, and we didn't backport. So this one will have them, so use that. As mentioned before, it has semantic versioning in the release notes. However, there's a lot of things that we also want to do, and you've seen some people already mention them and talk about them in what they think should be coming, that potentially break it. Potentially like what? So we talked about long-running off-chain workers. Sure, we want to make it possible to do them without having a Semver breaking change, but we might have to. We don't yet know what it looks like. We might have to do this. The same is true for on-chain data migration. We're currently doing that in Kusama, but we want to have a more general approach to this. What if you change the struct that you currently use in your runtime, and there's data on the chain? You want to migrate to that new one. We need to give some way to do this. It's currently not in there. We need to do this. Maybe this breaks it. Then we do really want to reduce the macro magic that is happening. But that might also mean we have to break some APIs. And then I mentioned before already, networking and consensus. These are not stable. These two are simply not stable, in our opinion. We're using them, and we're happy, and we observe them all the time, but we're also patching them all the time. So there's going to be some breaking changes. Does that mean there's going to be a 3.0? Maybe, potentially. When? We don't know. We're going to try to not break everything immediately, but you know, it's ready when it's ready. So is this the future yet? Let's give it a quick reality check. What are we actually building here? We had that briefly mentioned by the Web3 Foundation earlier today. We're building the building blocks for Web3. When we look at the major updates of the web, whenever the web does a major update, everything that was possible before is still possible, right? But more. So in Web 2.0, we were able to publish and read in general. With Web 2.0, there was a stronger write feature in it. Specifically, it allowed everyone to write, not somebody who's just running a server, which allowed for higher level of collaboration and socializing on the net as well. Then the minor update of adding mobile access to this. When we want to upgrade this, we cannot only have this new trust. We still need to be able to bridge to this old world because people are used to this world. They're not going to give it up just because there's trust now. So when we talk about building the Web3, can we build something that is actually adding this new layer of trust, this transparency and ownership that we want to have, and governance on top of that, with the look and feel and what people need to do, they used to do. We have recently done a hackathon project, Gather, which is a meetup.com replacement. And there's a blog post, it's not linked here, it's linked later. Effectively what it did, it tried to create something that from the end user's perspective feels like meetup.com, but uses completely decentralized technologies, primarily Substrate. It is a global registry of groups and events, so yay, global registry. In a decentralized fashion. It has on-chain governance, so this is awesome. This is the new features that we have. But we also need to bridge to the 2.0 world, and we allowed there to be a really simple email password login system where we just use that to derive a key. So we don't have the feature that people can recover it if they forgot their password, but you could have this look and feel of email password. Similarly, we have an email auth flow. So via the JSON RPC, you could go to the node, you could give it the email address, it would send you an email, you would click on it to confirm the email, and they would be able to send you notifications via email, which is a common use case, right? And it would do that through off-chain workers. So an off-chain worker would notice, oh, in your group, you have seen there's a new event, so let me send you an email that there's a new event. This was all possible. The metadata itself was served through IPFS. You can read more about that in the blog post that I mentioned. By the way, the slides are all, I just tweeted them out earlier, so you can just look at them. But Gather still lacks a few things. In particular, interoperability. So you still have to have your own account, as an obvious one. Safe data storage. What I mean by that is, yes, the account can submit an IPFS link for the metadata or for the image, but there's no way to prove that it is that. There's no way to validate the data because Substrate doesn't have a notion by itself of IPFS, right? So you could put in any garbage. You could put in cross-site scripting, which is, as you remember, the very beginning of 2.0, that was a really terrible thing that happened, cross-site scripting by users. And then there's data privacy. I didn't actually know that before somebody pointed that out, but meetup.com has like swinger clubs on it. And you might not want to have that knowledge that you are in a swinger club publicly known. Fair enough. Didn't think of that use case, but I completely see that. We can't really do that. Everything that is currently consensus relevant is something that the chain needs to know of. So what are we doing about this? Well, I mean, going through that from increased, highest likelihood of happening to the least likelihood of happening. So not interoperability, that's obvious, as Paul got at. This is going to happen with parachains, parathread in XMCMP, which we just learned about earlier. Then there's also bridges, which was unfortunately not covered during Sub0 this time. There's the idea of having bridges between Substrate nodes, but also any other chain out there. And then there's Spree, which has been mentioned before as well, which is a trusted bridge in this context that we're talking about. But then you also need to interoperate with the rest of the world that is not chain right now, for which we have off-chain workers. right? So we've shown that off-chain workers can be used already, but there's more things we want to look into. In particular, email and push notifications. Push notifications since 2.5 are a thing now. You need to be able to do that. And also external login mechanism. People still want to sign up with their Facebook. In regards to data storage, I'm leading a project internally which is called the large file storage approach, which is an extension to Substrate and Frame that should allow you to natively store and retrieve just with your node. So you don't have to do like another process anymore for IPFS or Dart or Scuttlebutt, but you would use this extension on your node to store data off-chain and have Substrate have a native understanding of that data. So there would be a type in your runtime that the off-chain worker understands to be data that it can fetch. In particular, the email example that I mentioned before with gather, because the off-chain worker doesn't have any notion of what that string in there is, this hash of IPFS, when it sees a new gather entry, it can send you an email that there's a new event, but it doesn't even know its name, because the metadata is stored off-chain and it's not something that Substrate currently has access to. And hopefully this would also allow you to piggyback that on your peer-to-peer network that you already have. We're still investigating multiple ways to do that, but one of the ideas is that you won't have to have a secondary network just for the data distribution, but you could manage that within your data, allowing, for example, also validation of that data. So if Substrate has a native understanding of, oh, what you're posting here is supposed to be a JSON, it can fetch that data and check that it's actually a JSON, and refuse to put it on chain if it's not. Third and most researchy part of our endeavors is around data privacy and security. So zero knowledge proofs are obviously something we're continuously looking at and are very interested in. We're not exactly sure where we go with this yet. We're definitely looking to maybe playing around with Zaxi or the new ZK rollup, ZK Sync, that has been launched just a day ago or yesterday or 2 days ago. We're very much interested in seeing other off-chain worker schemes, so off-chain worker just being out there. A multi-sig scheme is obviously something you might want to increase trust, or a threshold scheme where only once a certain majority of people have agreed that this value is on there is actually existing on-chain. But also in the lower layer, like just deeper in Substrate, talking about finally getting quick on spoilers. Getting quick on their on libp2p to make it completely agnostic to the rest of the network that you're actually doing a P2P network here, not an HTTP, is definitely something that will happen, in my opinion, next year, but who am I to tell? And then a project that we used to have in Ethereum, which is a secret store, is also something we do want to port over. The idea here is that you would have a node or a network of nodes that you would give private information to, and they would do a private calculation with it and then submit the result of that, rather than it being like the code and the data being on chain. And that obviously goes one step further, and we have seen that in the lightning talks earlier today when we talk about trusted computing, either in a subset of nodes or even in hardware. But that is all going further than even next year, I think. But of course, there's many more things, and I want to bring that back to the hackathon Oktoberfest slide that I showed you earlier. There's a lot more ideas on here of things that people want to work on, and you might want to work on. And that brings it around to, the saying goes, like, the future is what you make of it, right? So it's not as much a question of what is Parity doing about it, but it's more like, what are you doing about it, all right? So, and with that, if you don't have anything better to say what you're going to do with the future, you should definitely sign up to the newsletter. And there's my details, and thank you very much.
We don't have time for questions, but what's the best way for people to get in touch with you for questions?
Well, the details there.
Yes. Okay, cool. All right.
Otherwise, I'm going to be down here.
Okay. Awesome. Thank you so much, Ben. So we're going to quickly get set up for our AMA. We have beer at the back, so grab a beer and please come right back to your seat. See you back here in a minute. Also, this is your last chance to ask questions and vote on questions at Slido, so sly.do, and the keyword is Sub0.1. Thanks.
No, I have not. I have just pushed the trigger. Now it's real. Okay. Give me a minute. Alex, did you want to have anything on there?
No, we're gonna have it dark because it's gonna be off. Because otherwise it'll just be on their faces.
Yeah, right? So is this the line for video?
We don't use the beamer now.
Okay.
Put them wherever you want.
Okay. Maybe just sort of line that's not shining in your eyes. It might be a little bright on them. Yeah, because that light's not shining right in your eyes.
What do you mean?
There's a lot of light because it's shining right in your eyes.
I can take it a bit down.
Yeah, you can. Oh, you can dim it. Oh, sweet.
Of course, I can take it a bit down, but you want to see it in the video. You want to see the faces in the video.
Yeah, can you tell me if you want to tell them you're going to see the down a bit. Take it down a little. Yeah. It's like blinding. Oh, there we go. Oh, now it's that one. So sorry.
You look so good.
Same.
Feel better?
Almost. It's like it's an angle thing.
Now you're
Yeah.
black a bit in the video. Is that okay?
Yeah, that's better. Is it for video? You want to test to see? Angle more? Also, can you, I would actually, can you move the chairs?
The mask. Maybe carry it through the rain outside.
Okay. This? Closer? Okay, yeah, and move that guy over.
It does look much better. So stay there. Oh, wait.
That?
We don't need the lectern anymore, huh? There's no use of this anymore. Yeah, but you don't, of course, yeah. You don't see it. No, take it off.
Take it off?
No!
Don't take it off.
Leave it there. Nobody will see that. We do.
number 2 on stage, number 3 for you. Will they have questions?
No, I think that we will take questions from the audience.
Number 4 for you as well, but I would keep it
just
sorted.
Yeah, agreed.
Yours is open.
I would like them to move a bit, so if someone can sit down again, but they like it.
Okay. I'm sorry, we're trying to. Can we just have you sit or move? Thank you.
Because I just want to see where the head is when they sit down.
Can you. Rosanna. Rosanna. Just because we're testing out the mods. What's wrong? How is it? It's okay? Okay. Ooh. Do we need one more? Can you grab one more water? Yeah, I think that would be nice. Okay. Oh, great. Ready to get started? I'll get people seated. We're gonna get started, so if you can get seated.
I'll do the thing. I'm just gonna leave it.
All right. Looks like people are starting to settle in. I'll give everyone who wants to a chance to get a beer and sit down. Hang on for another 30 seconds while people wrap up. All right. So here we are again since the last event. Had a similar conversation there. How does it feel? It's for me, it feels like a really long time ago. How much has happened since the last event?
We got a new prime minister in the UK, so yeah, quite a bit.
We're going to do a bit of mixed questions, both from the Slido and try to take something from the audience here if people have it. So we try to keep it a little bit live, and it's not just me reading from a phone all day. But we'll start off with some questions from Slido. Number one, top voted by far is, and I'm curious that so many people are interested in this, but what key management options are there for validators, e.g. HSM options?
I don't know.
So this is an active conversation that I'm in with many validator teams. Everyone is requesting remote signing. Everyone is requesting high availability setups and being able to use HSMs, being able to use TEEs, being able to use ledgers, people are kind of desperate for any kind of remote signing, and it is something that is obviously high on our priority list. A Ledger Ledger app is being built, so that might be the thing that comes first, or just a basic like remote signing that isn't like a trusted kind of HSM environment, but at least a different computer that you can secure in a different way if you want to. But I was talking with a guy over here sitting front row, Substrate T or Substrate TE, and talking about building a support for doing validator signing. And there's different levels here where on one hand you can just do like signing anything that's being sent into a TE, but then you can also do things like preventing double signing, but you can do something super advanced like running a light client inside a TE to make sure that you're actually signing valid blocks. So there's a whole slew of things that we are working on actively. So while there isn't much option today, soon there will be.
Are we really actively working on them?
Yeah, we are.
The Substrate TEE, we're actively working on an SGX.
No, well, they are actively working on that, but we are actively working on making sure the node actually can send off a payload to an external signer.
Yeah, I mean, I think it's great that there's an obvious product that a lot of people who apparently have a bit of cash to spend are interested in buying, and I throw the welcome mat open to people who want to seize this opportunity for a bit of solid business development and entrepreneurial spirit to go find somewhere in the world that can create HSMs and make these guys something that they want and sell it to them for a nice fat profit. But honestly, it's not Parity's not a hardware company. We're not going to be designing or manufacturing HSMs. So I would invite validators to create themselves a little validation group and go off and fund one of these things, or invite entrepreneurs in the audience to go and make something and sell it to these guys.
Yeah, for sure. I mean, so when I say we're working on it, we're working on making sure that the node is able to give off the signing privileges to something else. And what that something else is, I don't particularly care about, but validators might. Second question is something that I know you can't really answer, but when can we run parachains on Kusama? You might be able to give at least an interesting discussion around it.
As soon as I'm convinced they won't destroy Kusama, which could be quite soon. It could be, I mean, I would hope that we can get something in many weeks in advance of when we are meant to open it up on the Polkadot mainnet. So, let's hope sometime early on in the new year, like first 2 weeks of January. But it really does depend a lot on when Cumulus becomes sufficiently hardened.
I think that people in the audience who were at the Cumulus workshop and have seen some of this in action now have like a better idea when this will actually come. And if you weren't at those workshops, then maybe you can find it online later. So you can sort of convince yourself when you think it's going to be ready. How can you ensure a sustainable validator economy over time?
Well, this depends a lot on which validators, but assuming the relay chain validators, the idea isn't so much to create a sustainable, the question isn't so much how do you create a sustainable economy, but rather how do you guarantee a certain level of security. As long as these tokens have some value, then there will be, well, as long as the value that the tokens have is sufficient, such that 10% a year will pay off 1 or whatever 4 validators, the minimum number of validators required for the particular consensus to work, then it's good, right? It's in principle, it's secure to some degree. the issue is, well, maybe we want it to be more secure than you can, than like, I don't know, whatever, 50,000. You spend 50,000, you can suddenly break everything. So it's really, at what point do we consider it secure? And that's really just a function of the token price. There's not much more to it than that.
Yeah, I'm not sure what the question asker means by a sustainable validator economy. I mean, is it just that as a validator you make more in profit than you're spending on servers? Then that's pretty easy because it's not that expensive to run and validate. Like even a sophisticated validation setup is not that expensive to run.
Yeah, I suspect it's really just, I'm a validator and I want to make more money. How do you ensure that I'm making enough money such that I don't get the arsehole? It's like, well, different people have different levels of money that they need to make before they get upset and walk away. And it's, we're not really making much of an effort to try to ensure that the validators who have perhaps a little bit more self-entitlement than others, and who have sort of higher amounts that they want to make, are not going to walk away when there are perfectly good sort of decentralized alternatives. And I think you do see a lot of like. I feel that this message does come a lot more from the sort of the validators who consider themselves, actual validators, like professional validators who are running, professional validation operations. And really, the way that the Polkadot sort of validation, the MPOS system works, is to favor lots of smaller validators rather than these like large multi-node validation outfits. So it may just be that Polkadot doesn't offer an especially good rate of return for large validation outfits, and it really is something that's that ultimately ends up being serviced by many 1,000 individual or very, very small, not very professional validation outfits.
Yeah, I said the word sophisticated validator, and by that I mean basically just mean someone who is secure enough to actually provide the services. And an argument that I've heard, I mean, in the same vein of this question, is that these validator companies, these kind of big entities that are professionally running validation services, they're in high demand, and that networks are trying to convince them to validate for their network and kind of providing them better deals. So indeed, it might be a question of like competition, and this kind of to me goes against the spirit of proof of stake in the first place. If we're just putting everything in one company, then why are we bothering doing this thing at all? And but there's still a question of like, what is a sophisticated validator? How do we make sure that if it's not a few companies, how do we make the whole world sophisticated enough to be able to provide the services? And I think here, proof of stake is such an early technology that your average Joe probably isn't going to run a super secure setup, but this will quickly improve, I think. And it really isn't that hard to run something solid.
Yeah, I think it really just takes a few little tutorials, maybe one or two, bake your own validator kits, and it won't be too long before we get reasonably decentralized and secure system.
I'm going to ask one more question, then try to take one from the audience. If you have something, raise your hand already, and we'll get Alex to run your mic while I ask this next one. This was asked exactly the same at the last event. What is still missing for Polkadot mainnet?
Well, XCMP, so implementing all of that. That has been, the design for that is more or less finalized. It's now it's really just the implementation. and that's something that's already been started on, but it's it's pretty complicated, so it will take a little while. Cumulus, I guess technically isn't needed for the mainnet, but it's needed for the mainnet to be useful. It's something that kind of does need to be finished before we can really claim to have delivered it. Other than that, things are there. Things are in place. Kusama is going. It's a thing now. You can play around with it. It's fully public. I'm not in my godlike position over the network anymore. I was kicked out, booted from heaven. So yeah, there's not all that much that needs to be done in terms of the sort of base level version 1 of the mainnet, which is why we are talking about laying the potential Genesis block later this month. The audits obviously have to be done too.
All right.
I had a question about what you were thinking off-chain coordination might look like in the future and how that will play into things like the governance in Kusama, Polkadot, etc.
Yeah, I mean, off-chain is. Ultimately, for the relay chain, we're trying to avoid any off-chain stuff that isn't directly connected to parachain validity. So the idea is to remove all of the governance and all of the staking, even the balances stuff, off onto parachains. But talking sort of more generally, how I see it for parachains, I can definitely imagine we have so one of the things I wanted to start working on in the not too distant future is a kind of a grand oracle system, so that we can actually implement oracles with a reasonable guarantee that it won't just ultimately come down to sort of opinionated validators or random sort of oligarchs that have been elected to the council. And so the idea behind that is to have a sort of a jury that is elected primarily on some objective real world criteria, and that would have sort of they'd operate as a body that's off chain, but would otherwise act as a sort of oracle of last resort, and would be there would be some game theory as to why they would actually tell the truth. Probably a combination of professional liability with shelling points and sort of economic incentives. Thinking more kind of abstractly, once you've got this grand oracle, then you can have lots. You've really got the ability to have lots of smaller oracles, lots of think of price feeds, think of checking for identity. Hey, does this Facebook identity have this account ID on the page? Does check Twitter? Do all of this kind of interesting pulling of data in from Web 2. I like the stuff that Ben's been doing with the email oracle and email actuator, and of course it's off chain, useful for both of them. Well, necessary pretty much for both of them. I don't know. There's a lot of stuff. There isn't really a super coherent, specific timeline for implementing any of it. It really comes down to what we feel at the time is the biggest opportunity or the most pressing need.
I'm going to ask a different read of the same question that I asked before about the sustainable validator economy, but a slightly more interesting take on that question for this audience would be, how do you design a good collator economy? How do you ensure that collators do their job?
Well, you make sure that they get paid. I mean, if you don't want to do it yourself, it could be that the project just runs their own collator nodes. If there's relatively little, if there's a degree of trust, relatively little risk of of there being problematic censorship, or relatively little risk of your users believing that there is problematic censorship, then maybe it's the right way forward. Assuming that you want to incentivize others to do the collation for you, then transaction fees are the obvious way of incentivizing it, essentially getting your transactors to pay your collators. And you can have a transaction fee economy using, some sort of floating value, and have the value go up if blocks, if transactions aren't getting in, and have the value go down if they are. It's kind of stuff that's already relatively well known how it works. Like I don't think I need to sort of answer in terms of how transaction fees can form a valid economy. Now then it's like, well, okay, why do we trust the collators? Like how is it, what's the consensus? And the thing is, there is no need for consensus at the collator level. There's no need for trust, and there's no need for punishment, because collators are not in any position of power, right? The parachain validators coming from Polkadot are, but they are already incentivized by virtue of being in Polkadot. Now you might want to have some form of pre-selection for your collators. So it might be that you have a very basic proof of work, which gives collators, or gives your collator candidates a ticket to become a collator, and therefore author a block to collect transaction fees. It may be that you have a proof of stake. It may just be you have a whitelist that a council decides. I don't know. It kind of depends on your parachain. It's likely that we will do some sort of proof of stake variant, or we might actually implement a proof of work and a proof of stake variant as part of sort of the basic set of palettes for Cumulus. But in principle, you don't even need those. In principle, you can still just have collators be entirely free and open, and anyone can collate, and just they fire it off, and Polkadot parachain validators might get a bit spammed with block candidates, but yeah, it should still basically work.
Where do we stand regarding multi and threshold SIGs? And I kind of have to read this as on the relay chain, like having multi-sig and threshold SIGs as like a native feature on the relay chain, because on a Substrate chain, you can of course just implement this yourself. It's just a thing that you implement. So on the relay chain, is there a plan to support these things natively?
Yes, although as I say, the relay chain, we are trying to reduce functionality. So there's two ways of going, and we'll likely do both. One of them is actually already kind of done. So the Schnorr Ristretto variant of 24519 that we work with on the relay chain already supports threshold multisig. So you can do that today. The software is out there. There's very little user level support, but in principle the APIs are there, and it can be done. It's just waiting for someone to make it easy. That's something that we'll probably integrate at some point next year into Parity Signer. So when you create an account, you'll be able to create an account that uses like 3 different Parity Signers, or 2 Parity Signers and one hot account, and be able to send to it, and then use the hot account plus a Parity Signer in order to empty it. There's the other thing that we can go with is something that's like much more in the style of the current Bitcoin multisig, where you've got some on-chain logic that actually counts how many signatures there are, and when the hits a sufficient level, releases the funds or whatever, sends on a transaction. This is something I want to put in anyway. It's unlikely to make its way onto the relay chain, but it'll be something that's kind of useful for parachains. I mean, it might make its way onto the relay chain. We'll see how much account stuff there is on the relay chain at the end. But the idea is that it's a super general way of remixing how accounts work. So you'll be able to create new accounts that are like proxy accounts that are just rewired configurations of pre-existing accounts. So simple way of doing that is, well, we've got the account something, it's just created, it's just like a random hash, like the account is nothing special. But there's a kind of pseudo-like module, so you're familiar with the pseudo module. One of the variants in the pseudo module is pseudo as, so you can send in a transaction from the pseudo ID, and also a call and an account ID that you want the call to be made from. And all the pseudo does is the pseudo as function does is it checks that it comes from the current pseudo account. And if it does, then it just redispatches a new call, the one that was passed in, but this time from the account ID that was passed in. So it's very similar to the Unix style like sudo thing where you can specify what account it is that you want to run as next. Now, what this would do, though, is basically the same thing, except it would only ever run from this one new hash account that was just an empty account, so it's fine that it runs from that account, that it's called from that account. You still pass in the call that you want to come from that account, but you pass in some other account, and it allows some other account to kind of redirect itself as one of these accounts that it's created. So it allows one account, you to retain the key of just one account, but to control many different accounts with that one account key. And you just state which account it is that you want to control whenever for each transaction that you want to move. Now, the reason that I want to do this is because if you're controlling lots of different validators, so maybe you've got like 10 validators, maybe you're Adrian Brink, you've got 30 validators on Kusama, right? And you've got 30 controller keys. And it's a real pain having 30 different accounts, like administering 30 different accounts. Suppose you've got like 30 different nomination accounts, and you want to add one extra validator to each of those 30 different nomination accounts. Then you have to do like 30 different keys you have to sort of bring out of cold storage or fart around with using your mobile app. Much easier if you only got one key. So the idea is that you have just like one super controller key that has many different kind of sub accounts that it has control over. Yeah. And then the idea is that you can also batch up transactions. So you can make a single transaction that has like 30 different renomination transactions in it, and then just a vec of 30 different accounts that you want to send it from, and then you fire off one transaction, you sign it once, and it sends it from all 30 accounts, these 30 different transactions. And then you can combine that with a multi-sig. So now you can say, instead of there just being a single account that controls this, well, a single account is actually another proxy account that's a proxy for a 2 of 3 multi-sig. So you first send the thing that you want to send on from one of these 3 of the 2 of 3 multisig. Then you send a hash of the thing from the second of the 3 from the 2 of 3 multisig. And what that does is it says, there was already one here. I'll send that off. And now I know the pre-image because that was what the first guy gave me. And then that goes into this controller sort of fan out thing, which then resends it from the 30 different accounts. So what you can do now is like have all sorts of crazy ways of organizing how your accounts work, still within the account system, but separating it off and abstracting it out from this assumption that there's like one private key per account.
Yeah, this really actually reminds me of Alex Vandersand's whole scheme for logins that he's been talking about for a long time. This is in the Ethereum world, where then all of these kind of proxy accounts require all their own contract, and it's a super complicated setup. But the use case is basically that you have all these different dApps, and you don't really want to use the same identity on all dApps. But you also don't want to create 10 accounts and split all your money across these 10 accounts and have to like pay transaction fees from all these different accounts when you're interacting with different dApps. So it's sort of like you have a bunch of different identities split up on different applications because you don't want to use the same key with everything. You don't want to be identified as the same person on all applications. But you can effectively control many different applications from this one key, but still kind of remain somewhat anonymous.
Yeah, I mean, the anonymity thing isn't really provided with this. It'd be really obvious to see which accounts are behind which other accounts. The anonymity thing would have to, come through some crazy, like, ZK snarky cryptographic scheme. But yeah, in principle, it could be that the balances are shared, or rather the balances are moved just in time. So it's kind of like you only have one account with a balance, but then immediately before it sends the transaction in this kind of fan-out operation, it just puts enough money, enough of the balance in. And
So there's a proxy kind of thing.
Yeah.
All right, do we have an audience question? Anyone?
Thank you. So my question is, how is it going to be the exchange of dots, and if there are any plans for a decentralized exchange?
We, as Parity, don't plan to build a decentralized exchange.
But I know of plans to build decentralized exchanges. Someone will.
So yeah, I think it wouldn't be difficult. Once there is a bridge, then it's pretty trivial just to have a market between the two tokens that exists within, on the bridge, potentially on the bridge parachain, potentially on a separate parachain. It's like I guess the tricky thing is like integrating it into front ends, making it usable, and all the rest of it. But again, that's not really something that we're aiming to take on ourselves.
All right, I'll take one from Slido. This is one that I get asked quite a lot as well, but I feel like we've answered it a ton, and I don't like. Maybe we have to find a new way of answering this question. But what is the difference between DPoS and NPoS?
One of them is secure, and one of them isn't. I mean, so Al is by far the better person to answer this than me, but basically DPoS is sort of a more of a voting system. So it's like allows holders of the token to place their weight behind oligarchs with no recourse if the oligarchs, for whatever reason, are bad. Or validators, sorry. There's the assumption with DPoS is, well, if they're bad, then the token base will, token holder base will move them onto other validators, which kind of doesn't really work because the point is the attack scenario isn't we have lots of people who are all paying a lot of attention and who care even if their tokens are 100% secure. The attack scenario is, well, we have someone who wants to, I don't know, pass an invalid transaction. How many of the tokens do they need to buy and hold before their transaction goes through? With NPoS, we retain a similar voting mechanism, but the difference is that the votes are, they stay with, well, rather, those who you vote for, those oligarchs or those validators that you vote for, are a portion of your total vote is assigned to them. And the portion that's assigned to them is an optimization problem. But a portion of it, somewhere between 0 and all of your votes, are assigned to them. And your votes are your stake. And what this implies is that if that oligarch does something bad or the validator sort of is malicious, then it means that you can be slashed, right? So you are at risk of losing your tokens. Now this awesomely alters, it radically changes the economic impetus now for me as a token holder, because there's a risk involved. And when there's a risk involved, it's like, right, well, I'm not just going to vote for the guy that gives me the most money or gives me the most freebies. It will be, I will vote for someone that I believe isn't going to lose me my money, which means either that they've put up a lot of their money themselves, which means they will take the risk of slashing before I do, or it means it's someone that I've actually looked into and I've researched, and they have a big community footprint, and they seem like real people, and maybe they've got their validation equipment audited, maybe they've been around for a long time, maybe I've met them in person, maybe I know where they live. And in general, there's a degree of trust that I know that this particular person or this particular outfit probably isn't going to go do anything bad. And the trust need not be blind trust, it need not be faith, it can be evidence-based. So it could be that, as I say, there may be independent audits that have done, it may be that you actually visited this. If you're talking about a significant amount, it may be that you visited and you've inspected it yourself, what their operation's like. So critically, NPOS has risk involved, and that means that the game theory is different. It means that people will back those that are least likely to be malicious for the network, and it means that those who are validating have a much bigger impetus, much bigger incentive not to misbehave.
Yeah, I mean, I can understand people's confusion, especially as a non-English native speaker. The difference between delegating and nominating is I mean, it's sort of, this is the same thing, and sort of I'm giving something to someone else. But I get like, and on top of this, DPoS has been massively confused by 50 different protocols calling their thing DPoS, but actually being completely different things between all 50 of them. But I guess the short summary is like, one carries risk for the person giving or like assigning their tokens away, and the other one does not. What is next on the priority list for Substrate?
Well, there is some degree of parallelization, so we can have more than one thing, but roughly, next year should have more interesting off-chain workers. That's something that I think we're going to be pushing forward on because it is so useful. Cumulus and XCMP, obviously are super high on the list as well. If we're talking pure Substrate, then parallelization. So the ability to execute transactions in parallel, but also the ability to have just general worker threads within your runtime. So it might be that you've got stuff that isn't to do with transaction execution, but rather is a job that just happens to need to be done in the background, and that's something that we'll probably want to do as well.
Or you might have many jobs that you want to do, like computing proofs or whatever it may be.
Yeah, I mean, you might not want to compute proofs on the runtime, but yeah. One example might be the the fragment election stuff, where you can probably, depending on how much data is involved, do that in parallel to executing a bunch of transactions. Although that's more of a candidate for off-chain computation as well. What else? I mean, Ben already touched on this in his talk, but like some refactoring of the runtime macros. So there's a general desire to move away from the decal module, decal storage, decal event, and all the rest of it to just straight tags, very similar to how the syntax of Ink works now. Yeah, that'll be really nice if we can do that, but I mean, it's a fairly large job, so we'll see.
General Rust improvement is obviously high on the priority list, like adopting async await and making the code base nicer. But if the question is not just Substrate core, there's obviously a ton of stuff happening in the Substrate ecosystem as a whole. Like in my slide, I showed sort of what's going on in core, what's going on in runtime, what's going on overall, and Parity is expending a massive amount of effort on tooling, and I think that is, as we're getting closer to maturity and having things deployed, tooling is a high priority.
Also, an increasing amount of optimization and analytics, debugging aids, metrics and telemetry. This is all all stuff that we have direct efforts, like focused efforts on now.
Yeah. Before I ask the next Slido question, does anyone in the audience have anything? Anything Substrate based instead of Polkadot based? All the other questions in Slido are Polkadot questions.
Touching on exactly that aspect, what about runtime governance modules? I've seen you doing the membership council thing.
Yeah, lots in store for the palettes. So if you're not familiar, the palettes already had a membership palette to allow you to create this a club of accounts that could act as a collective. We have the collective palette that allowed them to act as a collective. We have the fragment elections that allowed you to create a club from a bunch of staked, sort of a proof of stake club. In addition to these, there's also going to be actually there is already a palette done which is the selected, I can't remember what it's called now, but it's like a selected membership group. This will form the basis, I hope, assuming that the Kusama Council goes ahead with it, for a Kusama Grand Oracle Committee. Much like, as I mentioned earlier, this would be the sort of top oracle that would allow an appeal process from lower, less well-staked oracles. And on top of that, I'm also currently working on a society module that allows essentially a membership group to grow based upon membership criteria that is the criteria being evaluated off-chain by the existing members. So there's again another experiment that I would like to push out on the Kusama chain that would use this sort of Kusama this society palette in order to create a membership of sort of citizens of Kusama, let's say. In addition to that, I mean, there's a lot of stuff that a lot of ideas floating around for governance, and I think we've got a really nice sort of between the origins and the membership abstractions, we've got a really nice base on which to build these kinds of social constructs and roll them out in in different guises.
There's a "we live in a society" meme to be made somewhere in there. Would you be open for starting a Kusama meme competition?
Definitely, yeah. No, we should definitely do that.
Speaking of Kusama, there's a question here. Where do you see Kusama in 3 years? Is it still in operation? Will it be used as an experimental network for parachains?
It's really hard to predict, but I certainly hope that Kusama will still be in operation in 3 years' time. As I say, I would. One of the ways that we kind of try and categorize Kusama is there's a Litecoin to Polkadot's Bitcoin. So something with which we can push out earlier, crazier, more experimental features. Maybe stuff that, like, with Polkadot, for example, it has to remain stable. It's super important. And so we're not going to do crazy experiments on Polkadot. We're not going to put additional runtime modules on Polkadot. It's going to stay as minimal as possible, and we're going to try and push as much into the parachains. And we're not going to make the work any harder for us by adding extra features until that's done. Kusama, it's like, let's see what works. Let's see what doesn't work. That's kind of the raison d'etre of Kusama. So adding some interesting features to it, adding some interesting governance stuff to it, and seeing what comes out of it is definitely something that I'm interested in doing. So yeah, 3 years' time, I would hope it's still going, still has a vibrant community, has a really good meme competition. You know, had lots of artwork and memes coming out of it, and has led the way for Polkadot features, but also for you know, features that have made it out into the general ecosystem.
Something I'm particularly excited about with Kusama is, you know, blockchains have built up this kind of vibe now that it has to be super stable. We can't experiment. We can't do anything interesting or exciting anymore. Once it's published, it should stay this way forever. I mean, even like sort of experimental and name things are kind of going, no, this is it now, and we're not going to change. So building up a community of people who are expecting chaos, who actually want to have some fun, like that would be an amazing community to be in. And I think that is a different community than the ones that will be on Polkadot. So
yeah, definitely.
A question in the audience back there.
Hi, what are the biggest risks for the Polkadot universe from your point of view?
Biggest risk from the Polkadot
universe.
Universe. Okay. There's okay. So the smallest risk I see is the product risk. I think it's still a risk, but I'm relatively bullish that this idea of parachains and parathreads, I think is probably a sensible one. Like the fact that other chains have now, particularly like Shasper, have come up and said, oh, actually, would be pretty cool if we had domain-specific shards. It's like, okay, yeah, well, that's what Polkadot is. So yeah, I think broadly speaking, the value proposition is sensible and on target, and I suspect it's going to be copied by a lot of other things in the future. The next risk is tech risk. That's that is a risk. It's like what happens if the technology fails. You know, we're doing what we can to mitigate this with things like Kusama, with audits, with, you know, code reviews and all the other sort of measures that we have in place to try to minimize the chance of bugs making it in there. But we've also built ourselves a bunch of like fail-safe mechanisms as well, and those are things that we will continue doubling down on as the mainnet moves towards launch. So I still think it's a bigger risk than product risk, but I'd still say it's like a manageable risk. And then probably the biggest risk I would say is the risk of competition, because that's the most unknown risk, at least to me. It's not clear at what level competition is at. I think there's always the possibility that, you know, other teams will come along and just magically come off, pull out a sort of unicorn. It's the other, like, sort of related to that is just the thing of, you know, to what degree is the product Polkadot able to be properly communicated and marketed. So it's all very well having the product, and it's all very well the product actually being useful, but unless everybody knows that it's useful and they know that in order to do this thing you have to come to Polkadot to do it, then it's you know, it's still a risk for the system being actually used, for the system fulfilling its proposition. So it's happily the crypto community is relatively, like, there's a lot of cross-pollination going on between it. So again, I don't think it's like an insurmountable risk, but it's definitely something that we need to be conscious of, and something that we need to make sure everyone from the various corners of the ecosystem are familiar with precisely what Polkadot does, what its value proposition is, separate to other projects, and we need to be clear about, we need to make the on-ramp as easy as possible, basically.
We are out of time, so I'm just gonna ask one final little question from an anonymous poster. Can you send me 10,000 KSM?
It's an anonymous poster. Did they give an address?
They did not.
Ah, well.
Sorry, should
Oh,
have
well.
given an address.
Unlucky, you missed the trick there. If I had the address right now, then I would completely do that. But I don't.
All right, thank you very much.
Cheers.
All right, thank you everyone for joining, and thank you for building on Substrate. If you want to stay tuned for new event news to come to the next Sub0, then please subscribe to our newsletter. You can find it at parity.io/newsletter. And if you missed the Zero Cool reference, then you need to go watch Hackers.
Also, I don't think this is on. I sent out an email today with a bunch of restaurants that are close by. I can recommend, there's one called Mom's Creations. It's only a few blocks from here. Yesterday we had food, today we don't, so you're gonna find your own way. But yeah, take a look at those links. Hopefully you find something tasty. Thanks, everybody.